Hello everyone, welcome to this Python for Data Science full course by Intellipaat. According to Forbes, the global data science and artificial intelligence market is expected to increase at a compound annual growth rate of 37.3% between 2023 and 2030. Fun fact, this dynamic industry is expected to surpass the combined GDP production of China and India by 2030, infusing an amazing $15.7 trillion into the global economy. Data science and AI have been growing at an extremely fast pace. Thanks to advancement in generative AI, terms like edge AI, multimodal AI, and large language models were not even heard of a few years back, but are now being learned by top data scientists and AI engineers around the world. Data science has been among the top career options for many years, but today it is the best career option for anyone who is looking to make a career in data domain. This Python for Data Science course has been taught by top industry experts associated with companies from Fortune 500 companies like TCS, IBM, Infosys, and many more. Here's what the agenda for Python with Data Science looks like. We'll begin this course with an introduction to Python with Data Science, and then we will look into libraries, packages, modules in Python. Next, we'll explore the Numpy Library covering array concatenation and splitting, an overview of the Pandas Python data science library focusing on data frames, discussions on classes and objects in Python, and examination of functions in Python. And finally, an introduction to object-oriented programming OOPS in the Python, followed by a segment of Python interview questions and answers. This may seem like a lot at this point, but don't worry. We have made care to break down these ideas into small pieces so you can easily understand every single aspect. That being said, let's get started. But before you do that, make sure to subscribe and hit the bell icon for Intellipaat's YouTube channel.
Python is one of the most popular programming languages today. And guess what? It was created as a side hobby and named after a comedy series. How cool is that? In this video, I'm going to answer some of the most asked questions about Python, such as what is Python, why to choose Python, what are the features of Python that make Python stand out, applications of Python, salary trends, and then we'll also have a short quiz based on this video. Now that we know the agenda of this video, let's get started with our first topic, that is, what is Python? Well, in technical terms, Python is a general-purpose, high-level, interpreted and dynamically typed programming language created by Guido van Rossum. Now, you must have heard this definition a lot, but what do all these technical jargons mean? Let's understand them one by one, starting with general-purpose language. A language designed to be used for writing software in various application domains without being restricted to a particular domain. Basically, what it means is that Python is used in a variety of fields, unlike domain-specific languages.
Let's have a quick quiz question, guys, and the question is, which of the following is not a data structure provided by Numpy Library? And your options are ND array, array, matrix, or data frame. Please mention your answers in the comment section below.
High-level language. A programming language that uses natural language elements, which makes it a lot easier to read and understand the codes. A high-level language also automates significant area of computing while coding, like memory allocation and management. Interpreted language. Python is an interpreted language, which means that your Python script is saved and executed in the same format in which you created the script, as opposed to the compiled languages, where the code is first translated to a set of machine-specific instructions and then saved as an executable file. Dynamically typed language. Being dynamically typed means that the Python parser automatically infers or identifies the type of variable on the basis of what kind of data you have assigned to the variable, which means that you don't need to worry about declaring a number correctly that will store the sum result of an integer and a decimal. How convenient is that? Now that we fully understand what is Python, let's move on to the next topic and understand what are the various reasons for choosing Python over other languages. Well, the very first factor that attracts the majority of the coders to a programming language is the ease of learning, and Python by its very nature is designed to be easy to read and write. The syntax of Python can be easily understood even by the beginners. Not just easy to read and write, Python is also free and open source. Now, being open source means that the source code for this language is available for the public to download, use, modify, and distribute. This may be the primary reason that Python has been evolving over the years, and even though it's over 20 years old, it's still one of the top languages of 21st century. Python also usually involves less code lines, which in turn results in less time to write the code. So something as simple as a hello world program takes at least 2 to 3 lines of code in other languages, while in Python it just takes 1 line. Now I don't know about you, but I feel that's quite amazing. Python is also approved by data scientists. Python is so versatile in nature, no wonder it is increasingly becoming the top preferred language for data science. So if you're looking for a career in data science, that's all the more reason for you to choose Python. Python also has a huge community, which means that in case you get stuck, there's always going to be someone out there you can reach out for help. And the best part about choosing Python is that it opens up a plethora of career opportunities for you since it has so many applications in so many domains. We'll talk about the applications in detail, but first, let's go over some of the main and important features of Python. Python follows object-oriented programming paradigm, which means that programs in Python can be grouped and bundled into individual objects, making the codes look neat and easy to understand. Now that's just one of the many advantages of being object-oriented. Python is also a cross-platform language, which means that a Python program written on a Windows system will also run on a Linux system, with little or no modifications required. Python has an amazingly large and rich collections of libraries, which are also cross-platform compatible. This provides users with a lot of flexibility while working in Python. Python is known for its simplicity, and it's very easy to use, which is something we cannot really say about majority of the languages out there. Python can also be integrated with other programming languages, such as C, C++, Java, and many more. Now we have already discussed that the syntax of Python is very easy to understand. Its English-like elegant syntax is what that makes Python stand out the most among other languages. Now that we know all the main features of Python, let's move forward and learn about the top trending applications of Python. The first one being web applications. Python is used to create web applications of different levels of complexity. Not just web application development, Python is also used for data analysis. Due to abundance of libraries such as Numpy, Pandas, and more, Python is leading and preferred choice for data analysis. Machine learning. Python can also be used for machine learning to implement predictive analysis by using its machine learning libraries such as scikit-learn, TensorFlow, and many more. Game development. Python is also very popular in the field of game development as it has an entire module named Pygame for this purpose. Automation. Python can also be used to automate repetitive stuff such as sending emails, opening a browser and posting a Facebook status, and many more.
Just a quick info guys, Intellipaat offers advanced certification in data science and AI in collaboration with iHub Divya Samparka IIT Roorkee. Through this course, you can learn all the important concepts of data science and AI from esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in field of data science and AI.
I want to begin the session by asking you this. So did you know that Python is one of the most preferred skill, one of the most requested skill in fact in all of the job description whenever you look at any data science jobs today? Well, yes, Python is the #1 programming language today and over 9 million users actively use it on a daily basis, and it has a huge community with respect to data science or any other field in general. And of course, when you're looking at data science, you would already know this, but then again I would like to add some more value to the idea that data science is the #1 career path for the decade. Well, this decade just started 5 months back, and we can already see from the leading researchers such as Gartner.com or anyone else for that matter as well, even Forbes, these guys guys say that with respect to data science, it's going to change the world in the next 10 or 20 years, and that the trend is just going to go uphill from now. So I would urge you guys at this point of time, if you're looking for data science careers, or if you're looking for anything data science, and if you have any questions, make sure to head to the comment section now and let us know. Our team is standing by to help you out with all your queries. Alright, after understanding that data science is the #1 career path in today's world, we need to take a quick introduction to what data science actually is. Well, I'm going to keep it short and simple here, and we do have a lot of in-depth videos on data science on the channel, so make sure to check that out after the session. Alright, coming back. So what is data science? In my opinion, data science is a skill, data science is an art. So this is the skill and the art and the technique and whatever you want to call it, basically where we take some raw entity such as data and we eventually produce something valuable from data. Well, what I'm trying to tell you guys is that we can take data and we can produce results and produce insights from it, which are basically valuable to drive a business to success, or give you an insight which you might not be able to find out when you look to the data with respect to your naked eye. Here is where data science will play a lot of impact. If you can find out hidden gold, hidden treasure in your data, which you can basically leverage to get one step ahead of the competition in today's extremely competitive world, or be it in any solution to any problem that you might be facing, well, that will be hugely advantageous for you as a problem solver, and in fact to your organization on the whole as well. And this is where data science is adding a lot of value in all of the fields today. So on that note, you might have a question saying, why do we require Python for data science? What makes Python the gold standard when someone thinks about data science in today's world? Well, of course, let me tell you this by starting out saying that Python is the #1 programming language in today's world. I still remember the days when Java was still the king of the programming languages, and then Python came out of nowhere with this popularity, with this huge, powerful community. Of course, open source community. Python is a free language, and these guys started developing the language in such a beautiful way. It has beautiful syntax, it's very easy to use, and it scales across multiple domains, be it artificial intelligence, be it natural language processing, be it handling and designing web pages, whatever it is. Python is there, and it's expanding rapidly across various regimes in today's world. With respect to data science now, in fact, let's dial it down one more notch before we talk about the specifics of Python for data science. Let's talk about how simple and readable Python actually is. Now check this out. I have a Java code in front of you guys, which basically prints one output on the screen which says hello world. Do you see the amount of characters, the amount of complexity that goes beyond the understanding of the common man to basically get at this output? Well, all we're trying to say is, hey computer, can you please print hello world to me? And look at how we can do it in Python. If you were a programmer and you understand that data science is a very complex arena with lots of statistics, lots of mathematics, and lots to do with artificial intelligence, data handling, data pre-processing, data analysis, and whatnot, I think this would give you a lot of clarity on what would be your best choice to pick up a language, right? Well, I've just given you a very clear examples on the basic statement of how to print something. Well, I can tell you and I can assure you that with respect to all of the other syntaxes in Python as well, this is exactly the same case. Even if you do not understand the syntax, when you're using Python, the advantage it gives to the readers is that you can actually look at the syntax and figure out most of what it says, and you do not even have to know what it means to sort of, guess what it's doing. With respect to other programming languages, I believe this is not true, because I was there a couple of years ago, in fact, when I was trying to figure out syntaxes of languages that I did not know, and it was really tough for me at that point of time. So what do you guys think about Java and Python? These two are the top programming languages. Of course, we have other languages in the world of data science as well, but then to understand that in the complex world of data science, keeping it simple is everything, and I would emphasize more on that. And again, here in my opinion, Python wins for just being simple and having the high readability. Now let's talk about a little bit in terms of what it offers when you're working with big data. in the world of data science, as you might know it, there is tons and tons, gigabytes and petabytes of data which is basically generated on a daily basis. When that is the case, you need to have the statistics, you need to have the tools, you need to have the techniques to handle all of this very easily. Well, again, with Python talks amazingly well to all of the big data frameworks out there, be it Apache Spark, be it Dask, be it PyDoop, or any other framework which basically handles all the big data in today's world. With Python and with all of these tools, we can bring the power of parallel computing to today's world. You might be wondering what parallel computing means. Well, let me tell you that basically if you have a task which needs a lot of computing power, instead of making it run on one single computer, you can actually assign it to multiple machines in a network and use the computation power and leverage that extra power to get it done. So now instead of stressing one single machine out, you can spread this task across and get the same job done easily, quicker, and in a more efficient way with respect to multiple computers. Now I just made it very simple for you guys to understand, and there is a lot more complexity of where this comes from. And even in that case, referring back to my first point with respect to Python, it makes it really easy to work with the first step of data science, which is basically to handle the data, bring in the data, and even perform some pre-processing with the data. Now, artificial intelligence is something most of you would have in your mind as soon as you clicked on this live session, right? Well, I've got you covered. Well, whenever we talk about artificial intelligence, you need to understand that AI has been the paradigm shift that the world was looking for, because now we have numbers saying that we can prove artificial intelligence is an entity which is helping humanity to its maximum. There is a 44% increase in basically enhancing the products we use by using artificial intelligence. We can optimize all of the operations within our organizations, within our companies and firms by up to 42% by making use of AI and its related concepts. And believe this, we thought humans were the best when it comes to decision making, right? Well, of course I would agree on that point, but then to add on to that, well, with respect to that, we can make better decisions with over 35% of guarantee when we use artificial intelligence. How cool is that? And of course, we can optimize external operations by up to 31%, and we can free workers to be creative. We can make sure that they're not doing the mundane tasks which can be done by computers in today's world by over 31%. Well, you might think, okay, these are just percentage numbers which might not mean a lot to me. Now think about the billions of people, if not the millions, who are actually in the world of IT and who are actually waiting to revolutionize the world, who are waiting to jump on this trend. Now all of these numbers will be extremely beneficial to the people, will be extremely beneficial to the employers as well. Let's come back to the specifics of Python. The first thing is that when you're working with Python provides a very efficient way to help you process all of the data. When you're working with artificial intelligence, you need to understand that having more data equally relates to getting your model trained better and helping it become more, let's say, intelligent. Now when that's the case, you might be wondering, okay, so how big is the data? Well, this depends on each of the scenarios, but then with the general understanding that we need more data to train the models better, you need ways where you can efficiently process this data, right? With more data, you will be inviting more complexity. With more complexity, you will be inviting more problems. And of course, we don't want that, right? That is exactly what I'm talking about. When you're working with Python, it gives you very elegant ways on how you can handle data, which of course we'll just check out in the upcoming slide. And then coming to the vast library ecosystem of Python, of course, as I told you, Python is one of the biggest growing programming languages in today's world. When it gets that kind of a tag, when it gets that kind of an attention, there's a reason for that. And I believe this is the reason for that, because it provides thousands and thousands of libraries for people to work with anything that they have in mind. So let's say you're trying to solve a problem now and you're stuck at any point. Well, basically all you have to do is, the first thing if you're working with Python is just Google it out, find out if there's a package in Python which will basically help you for that. And if by chance you're in luck, let me tell you, 99% of the time there is a package, there is a library in Python that will basically help you with exactly what you want. And this is amazing because we're catering to millions of people here with probably hundreds and hundreds of thousands of problems, right? When that is the case, all of these libraries which are present in Python will be the guiding force to solve these problems quicker. Coming to visualization tools, again a little more on this in the next slide, but then you need to understand that with Python, with all of the frameworks and the library extensions of Python, it becomes a very powerful tool when you're working with data science. And of course, community support is everything. If you're stuck with a problem, you have a community which is open source, which is widespread across the world, where you can dive right in, ask your question, and even solve the problem probably in under 24 hours, no matter where you're in the world. So this is the kind of community support that we have with respect to Python. And this is the reason thousands of companies around the globe have invested in Python, have invested in Python developers as well. Now, coming to the specifics of a couple of libraries that Python provides for the data scientists out there, we have two main concepts, and the first of it is numerical computation. Working with numbers, making sure that your mathematical game is up to the picture, ensuring that you can perform these computations and operations in arrays, be it in the form of matrices or whatever it is. Pandas and Numpy are the library in Python to be made use of just for this purpose. Coming to data visualization, you can create beautiful looking plots by making use of two very good data visualization libraries, which is Seaborn and Matplotlib. Of course, these are just like one or two tools in a whole pool of tools, and of course we're going to be looking at this a little more here as well. And this brings us to the Python developers trends of today's world. You might be asking, okay, so if it's the top job in today's world, if there is a huge requirement for Python developers, what do the trends look like? Well, you will be astonished that there are over 2 million jobs in 2020 and beyond. It is told that every year there is almost an addition of 500,000 jobs for Python developers. Yes, 500,000 every year, and in the year 2020 we have 2 million job openings for Python. So this is amazing when you even look at the Google Analytics chart you can see on the above. So this Google trend picture is trying to show you the interests of people over time, when all the way from 2015 and coming to 2019, and even showing a bit about 2020. At the end of it, you can see steep rises, steep curves everywhere, and there is a reason for this, and people understand that this is adding a lot of value to their organizations, and this is adding a lot of value to themselves as Python developers as well. Hence Python is this amazingly easy to use, friendly and trendy language out there now. If you're wondering what is the average salary that a data scientist gets in today's world, well, these numbers are amazing. So the average data scientist salary really does not care for inflation around it. And this sounds funny and humorous, but then it's amazing to see that right from 2014, which is now 6 years before today, the data scientist salary has always been above 120,000 American dollars. $120,000. This has been increasing, by the way. I have friends who are data scientists who make well around $190,000 to $200,000 per year as well. So when this is the situation, so you need to understand the importance of the salaries, because again, at the end of the day, we might be looking to make a career out of it for our lives. We might be just people who are interested in Python or anything. Knowing that there is a lot of potential here is very important. The average salaries in the United States of America is over $90,000 and all the way up till $140,000 and up. Be it recession, be it any sort of downs in the world of IT, a Python developer, a data scientist who can work with Python will get paid and compensated in a really nice way regardless of all of that. When we talk about India again, everything from 8 lakhs per annum all the way to 24 lakhs per annum. So basically what I'm trying to tell you guys here is that regardless of your experience, you might have questions asking, saying you might not be from a computer science background, but you want to jump on the trend train now. Well, let me tell you that, there is no strong requirement and prerequisite when it comes to becoming a data scientist. Of course, if you pick up a structured program where you're taught all of this from scratch, at the end of it, you can become proficient in data science without having to have any prerequisites of any sort. Coming from that kind of a thing to understanding that there is huge salary on the other side and it's trending and there's millions of jobs out there for Python, for data science out there, I don't see any disadvantages here at all. Now, if you're wondering what is the demands for data scientists in today's world, well, let the screen load right now for you guys. I have filled the screen end to end with people who are hiring constantly for data scientists, for people who know how to work with Python when it comes to data science. All of the social media that you can think of will make use of data science and Python in one way or the other. Be it Instagram, LinkedIn, Pinterest, Viber, WhatsApp, I can name everything on your screen right now. Amazon, YouTube, Unisys, Fractal Intelligence, again, basically Mu Sigma, IBM, Ernst & Young, yeah. Edgeworth, Ola, Siemens, Oracle, and everyone else, even Adobe and Apple. So basically everyone on your screen right now is hiring. So you need to put yourself out there, and you need to have a data science oriented profile to basically land a good job at all of these people who are hiring. You might be asking, well, how can I do that? Well, in my opinion, as I just mentioned, a lot of project works and a lot of industry level experience where you have a good amount of hands-on, where you have a good amount of teaching and structured learning will basically help you get there. You might have 10 certifications in hand right now, but then what if you do not have the ability to clear that interview, right? So that's what I'm basically talking about. A good certification program will ensure that you have the right experience. It will ensure that so you can crack interviews at all of these companies is what I'm saying. Now, if you're talking about job satisfaction, again, in the world of IT, there were multiple surveys conducted from 2010 and above, and people say that if they're a Python developer, they are about 80% satisfied with their job. You might be wondering, well, it's only 80%, it's not 100%, right? Well, no, 80%, trust me, is a lot when you're talking about an IT job, when you're talking about a job which requires you to program, which probably requires you to perform data pre-processing, data analysis, probably pushing you to achieve some sort of artificial intelligence, use deep learning, use machine learning, use data visualization, create dashboards. Well, that was a mouthful. You get the point. If 80% of these people, if 8 people out of 10 people are immensely satisfied with their job, I believe that Python is adding a lot of value to the world of data science. Now, on that note, you might be asking the question saying, what are the packages that are available when you're working with data science? We already covered 2 or 3 packages in a very gist before, right? Now let's take a look at Pandas, for example. Pandas is a beautiful library in Python which will help you with all of the data structures that you need. And you can work with data wrangling concepts, data cleaning, data hunting, and in fact, even data manipulation and data visualization. So basically, if I have to order up everything that I've mentioned on the screen, from data cleaning, from adding data structures to whatever raw entity you have, to manipulating that information and to visualize all of that, well, one library can do it all for you with respect to Pandas. And this, in my opinion, is again a beautiful thing in a programming language. And Python is all about these kind of libraries and packages out there, and Pandas is surely living up to the name to be one of the best libraries out there for that. And of course, Numpy. When we talk about Numpy, numerical computation, array processing, array operations, even linear algebra concepts, guys. So basically, for all of these needs, Numpy really stands strong, and it makes your life a lot easier with very good syntax, high readability, and at the same time ensuring that you can put in the required time to solve the actual problem at hand rather than worrying on the syntax. That is what Python is about. Then if we talk about more packages, we have SciPy. So SciPy is of course a beautiful library when you have to work with all of the statistical concepts out there, and we need a lot of statistics when you're working with Python as well. Linear algebra, calculus, integration, all of these mathematical concepts follow slightly behind in the world of statistics, and these form to be the foundation in my opinion. Making sure that as a developer you can work with these easily, well, that is all the goal about SciPy, to basically help you on your data science career. Now, if you're being worried about data visualizations or how we can create, beautiful looking graphs, well, let me tell you this, Matplotlib is a beautiful library to do that. In a recent survey conducted, it is noted that humans can perceive images 3000 times faster than numerical data. If that is the case, would you like to see an Excel sheet filled with thousands of rows and columns of data, or would you like to see one or two beautiful looking graphs summarizing all of this information? I'm sure you guys will say the graph, right? Of course, with this, you can plot amazing 2D figures, you can work with it as an object-oriented API, you can perform very good data visualization, and at the end of it, if you have to compare it to any other tool out there, it is very similar to the working of Matlab as well, in case if you have used Matlab. So on that note, again, to come into the side of machine learning, to come into the side of artificial intelligence, we have scikit-learn. Scikit-learn is a beautiful library which will help you by providing all of the machine learning algorithms out there. Be it supervised learning, unsupervised learning, reinforcement learning. You have everything from classification and regression for supervised learning, clustering for unsupervised learning, and of course, it will help you tune your model, work with model selection, and much more. Scikit-learn is again an amazing library to work with, and I'm sure if you guys have had experience and exposure to machine learning, so you would have used scikit-learn on a minimum of once or twice while learning on that. Coming to TensorFlow is the gold standard for being the deep learning library, for being the library for neural networks when you're working with Python, and this forms a very important role of data science, because one of the majority goals of data science, as I've been repeating, is to ensure that you can achieve artificial intelligence. With TensorFlow, you can perform analytics on steroids. Yes, I just said that. Why do I say this? Because you can perform everything from sentiment analysis, voice recognition, face recognition, even TSA. TSA is basically time series analysis, and these are just the 4 things that I have put out here. When you're working with neural networks, such a complex procedure that you might think, we are trying to imitate how a human mind would think, and we're teaching a computer using those techniques, right? Now, you might think this is very complex. Well, let me tell you, it is complex if you probably work with any other programming languages. When you're working with Python, TensorFlow, and even there's PyTorch as well. PyTorch is basically another package for data science. So when you're working with libraries like TensorFlow and when you're working with libraries like PyTorch, it makes it so much easier to work with these. And I've been using TensorFlow and PyTorch for years together now, and I have fallen in love with it, guys. So again, if you've ever used TensorFlow or any of these packages, again, head to the comment section and let us know what your views on this is. And on that case, we've come to the section where we'll quickly check out a use case in Python to show you how easily you can handle data in Python. Just before that, let's talk about the use case. You might be wondering, so let's just say you're in the market for a new house now, and you might be wondering what concepts, what is the basic factor, what is the basic foundation of where the house pricing lies. So how will you understand how much price to pay for a house? What are the factors that is involved in knowing that one house is very expensive compared to the other? Is it because your house has a lawn that it is expensive? Is it because it has a swimming pool? Is it because there is a car parking available, a basement available, a lot of square footage of living space, and whatnot? Well, let me tell you that there is a lot more depending on this when you're considering about putting the most value to a house. What adds most value to a house is exactly what we're going to check out in our demo today. Let us see what are the factors which will play a very important role in assessing the price of a house and in validating on how people would like this based on those factors. Now, let me quickly jump to Google Colab. So Google Colab is basically a Python Jupyter notebook hosted on the Google platform. With this, we can basically write Python code online. It will be stored always, and it makes it very simple and nice to work with as well. So on that note, let us quickly jump into the code. The first thing you need to do when you're working with any sort of Python project or any programming project, in my opinion, is that you need to begin by loading all the files that's required, loading all the libraries that is basically required. Here, we're going to import all the libraries which is spoke about. We spoke about Pandas, we spoke about Seaborn and Matplotlib, which will basically create beautiful looking visualization for us. And of course, in some cases, data visualizations will not work, and this is just for the cases where it might not work. And we're going to be using a plot style called as BMH. BMH is basically Bayesian method for hackers, and it's a beautiful visualization initialization way as well. So let me click this play button, and it is as easy as this. Now as soon as that's executed, basically what it's trying to tell you is that it's done. Now we need to load our data set. So how do we load our data set? And as soon as I run this without the data set loaded, it's going to throw an error now saying, hey, you know what, I cannot access the file that's present. So where is this file called training.csv? Well, let me quickly click on the tab on the left side, click on files, let me upload it. And as soon as I click OK, it'll start uploading. You can see here on the bottom left. And as soon as that's uploaded, it basically is in the current runtime now. It will basically expire as soon as the runtime is restarted. But until then, we will have our data set loaded and ready. And as you can see here as well, we have the ID for the houses and we have a lot of information here. Everything from the lot frontage, basically telling you the square footing of the front lawn or the porch area. We have the total lot area, is the street which is paved, does the house have an alley. You can check out a lot of configurations as well. So is it inside a neighborhood, is it in the corner, what kind of a neighborhood is it in a college area and whatnot, what is the condition of it, what is the building style, what is the house style, is it a 2 BHK, is it a 3 BHK and whatnot, the overall quality based on a rating of 1 to 10, the overall condition right now, what is the year that the house was built in. This is of course a very important criteria to consider. When was it remodeled, if it was ever remodeled, what is the style of the roof, and what is basically all of the area which is available as well. You can find out even the type of concrete which has gone into building this house, and this data set is beautiful. The type of central air conditioning available, does the house have heating, does the house have a basement, if it has a basement, what is the square footing of the basement, what is the first floor square footing, second floor square footing and whatnot, total living area in the ground floor, how many bathrooms, how many full baths, half baths, and you can see that this is just a pool of data, right? And of course at the end of it you have the sale price at which the house is sold at. Now when we have to analyze what we're trying to do here, what we're trying to basically achieve here is to ensure that we can find a way where we can say, hey, these are the features, these are the factors which determine the price of that house. And as I just showed you, there is a lot of objects here to be considered. See, some places, some factors might mean a lot as well. In most of the cases, some houses might not have any of the miscellaneous features which is required. Some houses might not have fencing around it and whatnot. So when you have a lot of data like this, analyzing it, wrangling around with it and playing around with it is really fun in Python. But to do that, we need to perform some sort of cleaning, some sort of basic pre-processing. So what we're trying to do is, on an average, we can see that there's 1460 values for each of the features that we saw. If that is the case, then there is a good chance that if there are features which are very less in numbers, that they won't add any value to our analysis. For example, pool QC has only 7 non-null values. How will this stand a chance when you're performing analysis on an average of 1640 objects, right? So what we can do as a basic cleaning measure is to ensure that we can remove all of these values which are basically less than 30%. So basically you can see Ali is not a...
Just a quick info guys, Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatal. Through this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplotlib, Lambda functions and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What is the primary data structure used in Python for storing multiple elements in an ordered sequence? Your options are A. Tuple, B. Set, C. Dictionary and D. Array. You can comment your answers in the comment section below. Now let's continue with our session.
Number, as you can see, NaN denotes that it's not a number, so these will not add any value to our numerical computation, and we can drop all of these columns as well. And you can see that ID, Ali, pool QC, fence and miscellaneous features got dropped. ID got dropped, alley got dropped because, again, when you think about it, alley is not a number, and much more. And just like that, you will understand that pool QC was less than 30% of the values. Fencing wouldn't add a lot of value as well, and miscellaneous features are less here as well. So on that note, you need to check out how we can, analyze the data by actually taking a look at what it means. What does the data mean when you basically look at it? So since we're trying to figure out and map the way the sales price is actually given, you can see that the mean sales price of a house which is being sold in all of the data that we have is $180,000. So for around $181,000, this forms to be our basic mean, saying that this is where all the house prices might have clubbed on, and this is where they are structured about. So on an average, if you're thinking about all of these thousands of houses, this is where the house price is being sold at. And when you're working with numerical computations, as I just showed you, you can find out a lot about data frames when you're working with Pandas as well. And this is one of the biggest advantages. You can find the mean of it, you can find how many counts of data it's present, what is the standard deviation, what is the minimum value at which a house was sold, and what is the maximum price at which a house was sold as well. So all of this data is giving you a beautiful standard deviation curve, which will give you the mean, which will give you the 25%, 50%, 70%, 75% deviations, and much more as well. Now, if that is the case, the next step is to understand that what is the type of data that we are trying to pick up from the data set, and what is the data that we will not require. As I previously mentioned, since it's a numerical computation based demo, we will not require any of the categorical data, right? So if that is the case, let us quickly print out all the types of data that is present. We have integer, we have floating, and so we have integer and floating as well. Now, when that is the case, we need to pick up only the numerical data. Now here, if you see, we have dumped all of the categorical data, which is not an integer, which is not a floating value. If I quickly scroll up to the data before performing pre-processing, you could see all these categorical data which are present here, which will not make any sense for the numerical computation that we're doing. See, for example, all pub or LVL or inside or FR2 will not add any value to the computation we're doing, right? So now, after removing all of that, we have a very clean, elegant looking data set through which we can work with that. Now, before we begin any work on it, we need to understand that we have to take a quick look at the data to figure out all of these values that we have filtered. We have to figure out all of this. So we have to figure out all of this in a simple way. How do we do that? In my opinion, the most simplest way you can do is you can start plotting all of these curves and then taking a look at each one of these. So there's a lot of houses with a good amount of first floor square footing. So you can check out the average ground floor living area, the year on which the garage was built in the house, what is the square footing of that, and much more. So all of this data that you see on your screen right now in a very methodical way shown here will ensure that you can take a look at it and immediately grasp an idea saying that, hey, so this is basically what's happening. So for example, a lot of average garage area is basically somewhere around 0 to 1000 square foot. So this is somewhere around 500 square foot of average garage area, and I didn't need to perform any sort of analysis to tell you that. All I had to do was take a look at the graph, understand that this is a standard distribution, and all I had to do was trace the center and probably guess a value around that. So this makes it very simple to work with it at the same time. Now, on that note, let us start working with our data and let us hunt for things which will help us understand the sales price. So basically, we need to find out all of the features which will have the most impact with respect to sales price. In data science term, we call this as correlation. Correlation is simply the attachment that it has to one particular feature where it depends on it a lot. When that is the case, let us create a list, and this list will basically tell us that these are the values which have a strong correlation with respect to the sales price. See, 79% of the time, the overall quality of the area matters a lot. 70% of the time, the living area matters a lot. The number of cars you can park in your garage has a 64% impact, and even the basement footing, square footing of your basement adds a lot of value. And people say even the year it has been rebuilt was basically adding this much of correlation when we are thinking about sales price. Now, on that note, we need to hunt for linear relationships where we're trying to functionate and we're trying to understand everything, saying this is the reason that the price is increased, right? So that is exactly what we're going to do here. Again, basically, we are printing out all of these linear relationships out here, and you can, just by looking at it, you can understand that there's a lot of outliers in the data which might not have and add any sort of linearity to us. Well, as I told you, to keep it very simple, let us not be concerned with a lot of data cleaning, but understand, how the data operations are actually performed. Well, after creating our list and after understanding that we need to find some sort of linear relationships where we'll be tracking that feature with respect to our sales price, then we need to understand there is one important thing. There is a lot of cases where there is a lot of zeros, right? So let me give you an example that the garage area is 0 in a couple of houses. So what this means is that there is no garages in that house at all. And how many cars can you park in that garage? If it is 0, it obviously means that you cannot park any car in the garage, right? And this is mapped against the sales price of the house as well. So if this is the case, if the number of cars you can park in that garage is 0, if the garage area is 0, if the swimming pools is 0, full baths is 0, then you need to understand that if it's 0, it will really not add any value to the computation. So basically, if that is not present in the house, if there is no garage in the house, if there is no swimming pool in the house, we need to remove that feature. And when we have to find out how many features we have to remove, and to understand that after removing all of these values which will not add any value to our sales price, let us see if we can find out any more correlated values out there. And after doing just that, you can see a lot of data printed on your screen. Whenever you see a 0 point number, understand that this is the probability and there is that percentage of chance. If it's 0.19, it means that there is 19% chance that this is adding a value to that. So after removing all the features which do not add value to our houses, after doing a little bit of cleaning, after finding out linear relationships, at the end of it, we can print out what we call as our golden features list that we just created a couple of steps back. And this here will ensure that these are the values which have a lot of these are the values that have a lot of say in correlating with that particular price. If the price is very high of that house, people are considering the year that is remodeled, the year that is built, the presence of a full bathroom, the first floor square footing, the garage area, the total basement square footing, all the way until the overall quality of the house. So these are the factors which are playing a very vital role in the price that's been quoted for those houses. And then now that we have our result, if we take a quick throwback to seeing this data, would we understand just by looking at this, saying, hey, this is exactly what is adding value to the house? Well, no. You have 81 columns and you have 5 rows of data here. So basically, looking at this, you will get a clear understanding of what we are trying to do, but you will not get a clear understanding of what the result is. And now with the power of Python, with the power of simple programming concepts that's shown here at the end of it, you can confidently say these are the values and this is the list containing all of the features that is basically ensuring that it has strong correlation, and this is the reason the house is priced the way that is. How cool is this and how powerful this is, right? Well, exactly my point. This is again another reason why you should be considering Python for data science.
If I want to discuss about the libraries related to data mining, the first process in data science is getting the data from the various sources onto the system. So that is data mining. So first we look at the libraries that is used in data mining. And the first one is Scrappy. Scrappy is an open source library which is used for data scrapping. It is used for developing crawling programs to extract the structured data from the web. It can also be used to extract data through APIs. I hope so it's clear to you what's the use case of Scrappy in data mining. The next library we have is Beautiful Soap. Beautiful Soap is another Python library which is used for data scrapping and extraction. The library gets its name that poorly marked up web pages are often called tag soup. Therefore, the library is known as the Beautiful Soap. It is far more flexible than any other scrapping library in Python. The data scrapped through Beautiful Soup can be arranged into various formats and not into only CSV. Now, after the data is collected, we process the data for analyzing and modeling purposes. So, the first library which we are going to discuss is the Numpy. If I talk about Numpy, Numpy stands for Numerical Python. As the name suggests, it helps in analyzing the numerical data. It contains an array package. This contains a multi-dimensional and extremely powerful array object. Numpy also provides various functions and operations that can be performed on the Numpy arrays like add, remove, reshape, indexing, etc. Numpy forms the base for other or more complex libraries like Pandas, SciPy and scikit-learn. The next library is Pandas. If I talk about Pandas, Pandas is an open source library that is made mainly for working with relational or labeled data, or both easily and intuitively. It provides various data structures and operations for manipulating the numerical data and the time series data. This library is built on the top of the Numpy library. Pandas is fast and it has high performance and productivity for users. If I talk about the advantages of using Pandas are, the first one, it is fast and efficient for manipulating and analyzing the data. Data from different files or objects can be easily loaded. There is an easy handling of the missing data, which is represented as NaN, in floating point as well as non-floating point data. Then the factor comes up is the size mutability. Columns can be inserted and deleted from the data frame, and they are also higher dimensional objects. Dataset merging and joining is also present. It provides time series functionality. And finally, it is a powerful group by functionality for performing split apply combine operations on datasets. Now, many of you would be wondering why Pandas should be used for data science. Pandas are generally used for data science. This is because Pandas are used in conjunction with other libraries that are also used for data science. It is actually built on the top of the Numpy library, which means that lot of structures of Numpy are used or replicated in Pandas. The data produced by Pandas are often used as input for plotting functions of Matplotlib, statistical analysis in SciPy, and machine learning algorithms in the scikit-learn. Pandas program can be run from any text editor, but it is recommended to use Jupyter Notebook for this, as a Jupyter given the ability to execute code in particular cell rather than executing the entire file. If I talk about the Jupyter, Jupyter also provides an easy way to visualize Pandas data frames and plot. I hope so. Now you would have got answer that why Pandas is used for data science. With that, let's move to the next library. Our next library is TensorFlow. If I talk about TensorFlow, TensorFlow is also an open source library which was created by the Google Brains team at Google for their internal research. Now, TensorFlow is also a Python-friendly open source library which is generally used for numerical computation that makes machine learning and developing neural networks faster and easier. Machine learning is actually a complex discipline, but implementing machine learning models is far less daunting than it is used to be, and thanks to the framework such as TensorFlow. TensorFlow can train and run deep neural networks for handwritten digit classification, image recognition, the word embeddings, recurrent neural networks, sequence-to-sequence model for machine translation and natural language processing. It is also based on simulations. Best of all, TensorFlow supports production prediction at scale with the same models which are used for training. It also has a broad library of pre-trained models that can be used in your own projects. But the question is, seeing this picture, you would be wondering, how does a TensorFlow works? TensorFlow allows developers to create data flow graphs, which are structures that describes how data moves through a graph or a series of processing nodes. Each node in the graph represents a mathematical operation. and each connection or edge between the nodes is a multi-dimensional data array or a tensor. TensorFlow applications can be run on most of the any targets that is convenient, which is a local machine, a cluster in a cloud, an iOS device, or the Android devices, the CPUs or GPUs. If you use Google's own cloud, you can run TensorFlow on Google's custom TensorFlow processing unit, which is the TPU. I hope so you would have got idea about TensorFlow. Now let's move to the next library, which is Keras. If I talk about Keras, Keras was also developed by Google. It also runs on the top of TensorFlow. It acts as an interface for TensorFlow library. Keras is built for fast and hassle-free experimentation on the neural networks. It provides a good option, so if you don't want to deep dive into TensorFlow, then you can use Keras for your projects. Now, let's discuss the next library, which is PyTorch. If I talk about PyTorch, it is also an open source library, which is developed by Facebook for developing and testing machine learning modules. PyTorch expertise lies more in deep neural networks. TensorFlow and PyTorch are the major competitors of each other. Whenever you use deep learning technologies like object recognition, text recognition, face recognition, or chatbots, there is a high possibility that the architecture was developed by either PyTorch or TensorFlow. Now, let's move forward and discuss our next library, which is SciPy. SciPy stands for Scientific Python. It is used for complex scientific computations. It is built on the Numpy library. It is extensively used for scientific and technical operations like calculus, linear algebra, differential equation, integration, and statistical computation. I hope so you would have got idea regarding the use cases for SciPy. Now, let's discuss our next library, which is related to data processing, analysis, and modeling. And our final library is the scikit-learn. Scikit-learn is actually built on the top of many familiar libraries like NumPy, Pandas, and SciPy. It mainly focuses on data modeling. Scikit-learn is used to create models for predictive data analysis. I hope so you would have got idea regarding the use cases for the scikit-learn. So after the data is processed and modeled, it is time to visualize the data to get the important insights out of it. Therefore, now we will see the libraries related to data visualization. And our first library is the Matplotlib. If I talk about Matplotlib, it is used for data visualization in Python. It provides all the necessary graphs and charts for univariate and multivariate analysis. It is used to create industry standard and publication standard plots. Matplotlib contains an object-oriented API that can be used to integrate plots and charts into applications. I hope so you would have got idea regarding the Matplotlib. Now let's move forward and discuss our next library, which is Seaborn. If I talk about Seaborn, it is built on the top of the Matplotlib library. As it is built on the top of Matplotlib, it has higher interface level and provides cleaner plots than Matplotlib for visualization. It contains set of different built-in themes. It provides extensive plots like heat maps, pair plots that are used for multivariate analysis. I hope so you would have got idea regarding Seaborn. Now let's move forward and discuss our final library for data visualization, which is Bokeh. Bokeh is fully independent of Matplotlib. Bokeh is used to create interactive plots in the browser using JavaScript widgets. Like Seaborn, Bokeh to assist us in creating complex visualization, but it majorly focuses on interactiveness. Its interactive functionalities help in creating complex visualization like dashboards, network graph, etc. Now, after all discussing the libraries related to data visualization, analysis and modeling, and also for numerical computation, I have come to certain conclusion that there are thousands to lakhs of Python libraries available in the ecosystem today, and the list only covers the most popular and the must-know libraries. Also, we covered the most important libraries from all domains to give you a brief idea about the areas of your interest. These are the libraries which are used by professionals to work on the day-to-day basis. You got a good understanding of how these libraries function with each other and also how more complex libraries are built upon the core ones. There are many more complex libraries that you can read about. Sky is the limit of knowledge, and you can learn more and more as per.
All right. So let me explain you what the difference is. So generally we speak about these terminologies a lot in Python. One is library, one is package, then the third one is module. Sometimes people call it a function also. All right. So generally people use it interchangeably, but each term has its own definition. They're quite distinct in that way. They're quite different in that way. What is library? So library, we'll start with this. Library basically is it's a collection of pre-written codes, right? It's a collection of pre-written code that you can use to perform specific tasks. It's like a set of tools which generally you borrow just to help you build something, right? Like a house. So you have a lot of tools with you which you're using to build a house. Each tool is like a function, okay, and it serves a specific purpose, right? If you use a screwdriver, it only does one or two things, right? It doesn't do everything, right? A carpenter, if you see, has a lot of tools. Each tool is for different purpose, right? So similarly here, each tool here, you use them to simplify your coding processes. All right. So that's your library. But then if this is library, then what is package? So package is it's a more comprehensive collection of code. It's a more comprehensive collection of code, right? It includes your library tools and resources, all right, everything. Think of package like, it's a ready-made kit for building something, all right, like a robot, right? So it might include sometimes multiple libraries also, all right? But generally, we, again, use the definitions interchangeably with libraries, right? Actually, in fact, module is the smallest one. It is the smaller unit of code, right? Smaller unit of code, you can say, which generally contain a specific function. Generally, it's one function or maybe a couple of functions, all right, which we call it as a module. Okay, it's like a single screwdriver. The single screwdriver only does one thing, right? So this is that thing, only doing one or two things, correct? While package maybe does multiple things, all right? For example, let's say here you have two or three kinds of tools which do similar stuff. So there will be screwdriver, right? Screwdriver, and then there'll be maybe bigger screwdriver, right? But everything is basically a screwdriver only. Okay, you might be having 3 or 4 types of screwdrivers, but eventually you realize that they all are screwdrivers, right? So we can put all of these 3 things as a package because they all fall under one category. Similarly, you might be having another set of tools, maybe which are just for making holes or pokes, right? So they will fall in a different package, right? So that's basically the definition of package. While module is only one thing, okay, only one tool or one specific category of tool, which does only one or two things. Package is a combination of that. All right, package is the entire thing. All the tools which are falling in one category or cluster, that is your package, right? Then what is library? Library is everything combined. Library is it's a big library where you generally see a lot of books kept, right? It's like that. So you have a lot of packages kept in that library. That's the main difference. So in summary, module is the smallest one. Then we have generally package, and then we have library, which is the biggest one. Correct? So a library provides very broader view of entire function, package, and everything. Okay. While package, it's a extensive collection of all the modules, and a module is a smaller part, a smaller unit of code. Can a user create its own library? Yes, a user can create its own library and module also. So whatever way you design, then others will have to follow that. Okay, this person has designed it this way. He said that we need to use this and that argument only. Then everybody has to use only those arguments. They cannot change it because that is already defined by you. Okay, so this is just a broad level overview. Know what these things are. Okay, we generally keep on hearing we're gonna start with Matplotlib library or SciPy library or Pandas library. The reason we call them as library because they are very big and they have a lot of packages and modules in it. Okay, so when I say library, yes, we'll be looking at them in every session, don't worry. So when I say library, generally we talk about Numpy, SciPy, Pandas, right? These are all libraries. People sometimes call them package also, but they're in fact, they're so big that they are basically a library. Okay, so it doesn't matter sometimes, if you call it a library package, unless and until you understand what it is, right? There's basically a big set of packages. If you go inside Numpy, there you will find several packages. Okay, for example, there will be packages which only do additions or subtraction, everything. This is your numerical Python, right? So numerical Python means the simple numerical calculations is what you can do using Numpy. There will be certain package only does one task. There will be certain packages in Numpy which will only perform, let's say, multiplication or maybe let's say creation of ranges and all those stuff, right? So maybe range, a range, linspace, these are all types of you creating a range, so they will fall under one package. So like that. Okay, so they will be called as package. But if I only pick one thing, let's say only addition, that we can call it as a module. So we'll be dividing this course into 3 parts. We'll first understand what is Numpy, why do we need it. Then we'll try to get our hands into some of its functions and modules. And then we'll just summarize and have open round of questions. Okay, that's how we're going to divide today's session. We might not be able to complete Numpy because it is a huge topic. All right. But I think we'll cover some of the packages and functions. Please give notes. Yes, notes are we already have, I think, given notes. This PPT deck is itself a notes for you, right? And what I just explained, that was a separate part of this session. That was not part of the scope of my training session. But I still, I thought maybe just to ask you guys, if you are not clear, I'll explain you that part. Okay. So that note is not available. That I will explain you separately. All right. But if you want that as a separate note, I'll share that. The difference between Numpy, library, package, and module. Okay, that I can share. Don't worry. Other notes are already shared. They're already prepared by Intellipaat. We have codes available. We have this deck available. So everything will be shared with you all. I think a lot of material is already there in LMS and study materials, so you can refer that also. Yes. Okay. So yes. So see, Anil Kumar is also saying the PDFs are already available. The notes are already available in LMS. You can go there and check all the study materials. Everything is available. Just to reiterate, no difference between module package, because you want a definition. Module is basically a file. Okay, so basically a simple, in Python terms, it's just basically a file. It's nothing else. Module is the smallest one, as I said, right? So module is just a simple file, a function file, which contains Python definition. So you can you will see people, writing this way, right? DEF, writing the function name here, and then let's say they want here sum, right? Sum a plus b. So they're basically just doing a simple addition here, right? So that is nothing but if you save this function as .py file, it becomes a module. All right, as simple as that. While package is nothing but you have such different modules. All right, such different functions available. Package is just a way of structuring it. The package says, okay, this function and this function basically same. I will structure it this way. Maybe I'll keep this first and this second, and I'll put them in this one folder. All right, and that's it. I'll call them as package. Okay, it's basically nothing but a directory of files, directory of module file. Okay, that's it. That is what your package is. All right, and library, as I said earlier, just a collection of these. Right, this is your library. Huge thing. Let's begin with this NumPy quickly. So let me explain you why it is important. So you all have heard about data science, machine learning, right? So if we talk about data science, if we are going to use data science or machine learning, you're going to need to know NumPy. All right. What is NumPy? NumPy is nothing but your numerical Python. All right. That's how the name was defined. Numerical Python. Right. The first few letters got combined and called as NumPy. All right. So that's a NumPy. And as I said, if you're going to use data science, and pretty much on almost every data science library, why am I saying this? Because every data science library, which we'll be learning in this course, whether it is scikit-learn, whether it is Pandas or Seaborn, Matplotlib, whatever, it's all actually built on the base of NumPy. All right. So it is one of the most useful libraries in Python, especially if you're working on data or crunching numbers, right? Now, why is it used so much? The main reason is because it is fast. Okay, it is really fast. You can crunch numbers much faster than by just by if you use list or loops, it will run faster than them. All right. NumPy is used in numerical calculations and scientific calculation, scientific computing also. Very classic. I'll give you a classic example of scientific computing. It is that of let's say a weather prediction, right? If you, let's say, whenever you get a weather prediction, what's going to be weather like tomorrow or today, that is a little complex activity at backend, right? It is not simply just A plus B. You don't just add or subtract 2 or 3 things and get the weather prediction, right? It involves lot many factors to predict what's the weather going to be like, correct? That is basically your scientific computing. Visualization is a different aspect. It's just to show the prediction how it looks like. That is different thing. But how are you even arriving at this prediction? That is the point, right? The prediction is not happening. My point is the prediction is not happening by just looking at how much was the yesterday's rainfall or how much was the previous day's rainfall. You add it and you get tomorrow's prediction. It is not like that, correct? You're not doing that simple activity. It is more than that. And that is what is your scientific computing. Okay, to be specific, to be very specific, it is a linear algebra in Python. So when we talk about scientific computing, we are talking about linear algebra. And that's why the first line says here, NumPy is a linear algebra library in Python. What is linear algebra? I think we all have heard about it, but I think the definition is what I would want to put up first. Okay, just for clarity purpose, right? Linear algebra It's a branch of mathematics. Okay, it's a branch of mathematics, and we all have studied about it in our academics, in our elementary school, and it is very useful in data science and machine learning today. I would say that it is the most important mathematics skill in machine learning. All right. And I would just urge you to maybe read about it separately, just know what this is based on your understanding. How do you think, how much you know about it? You can look at some examples also. But from my side, I would like to just give you maybe a nudge in understanding what this is so that the foundation is clear. So let me reiterate. So linear algebra is just a branch of mathematics, right? It is quite useful in data science and a very important math skill. And your most machine learning models, right, most of them, everything you know, that it can be expressed in a matrix form, right? What is matrix? Matrix is nothing but something of this sort, correct? You all have seen matrix. Whenever we're used to write in the school, numbers written in a box, right? This is a matrix where you have one dimension here, one dimension here. That means rows here and columns here, right? And that you put inside a matrix or in a box, and we call it a matrix, right? Even if you look at your Excel file, right? Your Excel file, you all have seen Microsoft Excel, right? It has rows and it has columns, correct? There's rows and there are columns. And here in Excel, we also have column names that is different. But if we don't look at column names, if you look at just the values or cells inside this spreadsheet, that is nothing but a matrix because it has rows and it has columns, right? So it can be represented as a matrix. So what is this Excel? This Excel file is nothing but a data set. Right, guys? We call it a data always, right? Whenever you use an Excel, we call it file or Excel or data set. This data set itself can be represented as a matrix. All right. And what do we do in machine learning? In machine learning, we use data sets, right? That's how the machine learning is connected to your linear algebra, right? So I said that most of the machine learning models, they can be expressed in a matrix form, and the reason is because it uses data set, and data set often is represented as a matrix. We'll be doing that quite often. We'll be using many machine learning libraries and packages, and we'll be using the data set again and again. All right. So eventually it will be clear. Even if it is, let's say, not clear that much, it will be clear later on because we're going to do this activity a lot. Okay. Now coming back to linear algebra, just to again give you a heads up on the linear algebra understanding. Linear algebra, it is used in data pre-processing, data transformations, and also model evaluations, and lot many ways. Okay. Now, these are obviously the terminologies which we use in machine learning. So we have not, come across these yet. Might be difficult to understand what am I talking about. But just to give you a broad level overview, data pre-processing is where we clean our data. Okay, make it basically a model ready data set, right? Data which is very much clean, everything is taken care of. Let's say that you have renamed the column, everything is proper. So you pre-process it, okay, and then you pass it to model. That step is called as data pre-processing. All right. So here, when you do data pre-processing, you require linear algebra. Now, when we talk about data transformation, you might be, let's say, changing a variable from, let's say, numerical to categorical, right? They'll say there is a variable called as age, which is all numerical values, but then you convert it into age bucket. So that is you transforming it. So even this activity requires linear algebra. Okay. Similarly, you have model evaluation. Once you have prepared your model, you evaluate, you check, you validate it. All right. And that is also where your linear algebra comes into play. So linear algebra basically has a lot of role to play in machine learning. All right. Now coming back again to the definition, what is NumPy? Put simply, NumPy is just a simple Python library. Okay. Not simply a package. It's a big Python library for creating n-dimensional arrays. List of continuous elements. Okay, that's right. Array comprises of rows and columns. Right. Okay, if that is array, then how is it different than a matrix? Array is ND, right? You can have n-dimensional matrices, while my matrix is just 2D, right? I just explained you guys that matrix is like this. That means you only have one dimension here, one dimension here. That means you have rows here and columns here. It is a 2D type, right? Matrix is a specific type of a 2D array. This is also an array only, but it is a 2D array with rows and columns. All right, is that clear, guys? Correct? While array, it's a completely different matrix. It's a fundamental data structure that can hold elements of the same data type. Right? First of all, I said same data type. That means whatever elements you put inside the array. Let's say this is your array. That has to be of same data type. Okay. Even if you put this as a category, everything will then eventually be converted as a category, because it can only take elements of same data type. Right? So we'll be learning all of this in Python, don't worry. But the main difference is this is 2D and this can be ND. Okay, n-dimensional. All right, so that's the main difference. So multiple matrices can be also clubbed into one array. Array can be used for wide range of data matrices. That's right, nothing. All right, guys. So that is what basically your array is, and it is expandable to any number of dimensions, while matrix is not. Okay, that is the difference. Here, as I'm repeating, matrix is just a specific type of two-dimensional array. All right, but here your NumPy arrays, here you can create n-dimensional array. When I say dimensional arrays, meaning that NumPy arrays can be structured from 1D to 2D to 3D to ND. That means it is expandable to any number of dimensions. Great. So for starters, generally this is what we write. We first have to import the library, right? Whatever library which we plan to use, that has to be imported on the current session, because once you open a new Jupyter file, Jupyter doesn't know which library you want to use, because your system has n number of libraries and packages. And obviously you don't want to import everything, otherwise your system will hang, right? You will only want to activate those libraries which you're going to use in that session. And today we are going to use NumPy. And that's why we're going to use import NumPy function or import NumPy command to import NumPy, and we'll put an alias name as NP. All right, so let us import NumPy. Can we give any name? Yes, you can give any alias name you want, right? I'll repeat it. Whenever we start a new session, we have to first decide what sort of libraries or functions we are going to use today. Okay. Accordingly, we should be importing that particular library. And why do we do this? Because you don't want to import every library which you have in your system. Otherwise, your system will not be able to handle it, right? Because you would only want to activate those libraries which you plan to use on that particular day. And today we are using NumPy. Only activate that, right? Import function, import NumPy as NP. As is just the alias name, basically the name which we will be using again and again to refer any package or module within NumPy. Is that clear? To refer anything, we have to use an alias name. It is not necessary though. You can even use NumPy name, but that's a big name, right? I mean, you have not very big, but it is bigger than just NP, right? So why to write NumPy when you can write NP? And NP is a standard name. So it's better to write a standard alias name instead of giving our own name. I mean, we can give my name also, like Hassan, right? But it is, I don't think that makes sense because it will not be standard. Others might not be able to understand what library it is, right? If someone is referring my code, they will not understand what library it is. So to make it standard, we all should use same alias name. It's an alias name, Sri Harsha. It's an alias name, okay? It's an alternate name, so like a nickname given. Great. So let us start import NumPy as NP. And once you run, how do you run it? I think you all know it. You have to do Shift Enter. Once you do Shift Enter, you will see a line number popping up on the left hand side. Once you see this line number, you should realize that the cell has successfully run. Otherwise, you will either see a blank or a star sign. Okay, if you see a star sign here, if you see a star here instead of 2, if you see a star, that means the cell is still running. So you need to wait. Okay, don't just Shift Enter again and again, realizing or assuming that it is not giving you output. Just check this first. If you see a number, that means it has run successfully. If you see a star, that means it is still running. And if you see a blank, that means it has not been run yet. Okay, just to make things clear. Now, I believe everybody has imported NumPy. You all can just check quickly your NumPy versions. All right. Ensure always that you have latest NumPy versions. All right. Ensure that you always have a latest NumPy versions, or at least they're not very old. Okay. Because even if you look at my version, I don't think that is latest one, but it is among the latest one. If I'll run it, I'll show you mine is 1.20.3. How do you run it? You write a print function. All right. When you write a print function, just remember here, whenever you write a function in Python or in NumPy, whatever, after the function, you have to write a round bracket. Okay. Since print is a function, you have to write a round bracket, not a square bracket, not a curly bracket, but a round bracket. And within this round bracket, then you have to provide two things. First, what text do you want to print? Okay. Second, what is the function what is the computation which you want to do inside this print? So there are two things. Again, I'm repeating. Within print, you have to pass first, what is the text you want to print? Second, what is the computation you want to do within this print command? And since print is a command or function, you have to write round brackets. How do we update the library? It's very simple. So if you have not installed it, you can install using pip install, right? Which is exclamation pip install, which I put in the 4th line. All right. But if it is already there, then you can just do upgrade. So I'll write it here. Then just do exclamation pip install, and then you can just upgrade NumPy like this. Okay, so you can run this line. I'm again commenting this. To comment, you can just add a hashtag, right? Add a hash here, it will comment it out. Otherwise, if you want to run it, just remove the hash, okay, and then you can run it. Unable to open new notebook. Could be a Jupyter issue, Sriram. Maybe you can use Google Colab for today, all right? Or just check or download your Jupyter again. Either. Which line did you run, Bharat? Yeah, say import NumPy, you just have to confirm the left-hand side. If you're getting a line number, that means it has run successfully. Okay, it will not throw any output because here you're not printing anything. You're not computing anything. You're just importing, which will not throw any output. Okay, all right. So once you have checked NumPy version, or if once you have upgraded to NumPy, all right. Now let us create our first one-dimensional array. And to create a one-dimensional array, there are two things which you need to do. One is you need to write something on the left-hand side of the equal to, okay, which is going to be the variable name. And right-hand side is going to be a computation, which you want to do so that it can get saved into the variable name. All right, so this is like left-hand side equal to right-hand side, okay? Whatever you do on the right-hand side gets saved into left-hand side. All right, so this is essentially here you're creating a new variable called as A. You can give any name you want, doesn't matter. Right-hand side is important, left-hand side is merely the name. Okay, so let us create our first one-dimensional array. One-dimensional means what? Let's say if there are rows and columns, then you don't have columns, you only have rows. All right, that means you only have one dimension. For example, if I look at X and Y axis in maths, this is X, this is Y. This is like row, this is like column, right? So this is a two-dimensional graph, all right? But since we are creating a one-dimensional array, we don't have this Y, we only have X. Clear? Right? Let us create our first one-dimensional array, and to do that, we'll refer NumPy. Since the alias name given was np, I'll write np dot. Once I write np dot, I can now refer any package, any module from NumPy library. Yes, it is mandatory to write np dot, otherwise Python will not understand which library are you using to create this array. All right, array is just one module, but this module should be referred from which library? So you have to refer that here by writing np dot. I have not used replit.com, Shriram, but if you're comfortable with that, you can use that. Doesn't matter. It's just that it should be giving you a Jupyter environment like structure, or maybe just Spider would also do. Spider or maybe shell or anything. Whichever you feel comfortable, okay, doesn't matter. So np dot will give you the reference of NumPy library, and then you write array function. Again, as array is a function here, you have to write round brackets. All right. So array round brackets, and then within this round bracket, you write a list of elements. Let us write 1, 2, 3 or whatever number, up to you. Okay. You can write big numbers also, doesn't matter. It means the same thing. All right. So once you write this, you hit enter. All right. And then you can also print A or just write A. Okay. So once you've run this, see, this is run successfully because I can see a number here, just 5, line number 5. That's right, Indrani. Okay, so once you have run this This will not give you any output because here you're not printing anything, right? You're saving it into A. So it has saved it into A. Okay, so everything is fine. Now, if you want to print A, just write A here, or you can write print A also, means the same thing. Once you write A, it will give you this output, which is the same list of elements which you got, which you used to create this array. So the output will be array 4, 2, 3. Now here, this is one-dimensional array. And to check that, what you can do is, you can just check the number of square brackets which you have put here. Since we are using only one square bracket, okay, you can assume or declare that this is a one-dimensional array. Okay. Now, I'm not explaining this because this is just a part of explanation I made to one learner who was asking very different and advanced questions. So I have used that. I'm going to remove this. Okay, just to remove the confusion. All right. So we are done with creating array, creating one-dimensional array. You can print array by writing A, or you can also write print A. Okay. You can also write print A. It will also give you the same output. But I'm commenting this because both gives the same output. Now, you can also pick any one value to print. For example, if you don't want to print everything, so you only want to print one or two things. In that case, what you should be aware of is that how these numbers are saved here, right? In Python, whenever you just create a list, let's say you write a list. You all should know that Python is a zero indexing, index based, right? Zero indexing elements. So that means the values which you see in Python, it starts from 0th index. So this is at 0th position, this is at first position, this second position, and this is the third position. Clear? This is what we mean when we say zero index based. That means it starts with 0 index. Is that clear? Right? Similarly, if I want to read the same list from behind, it will be in a reverse order. So this will be at -1 position, -2 position, -3 position, -4 position. When I say position, position means index position, okay? Index number. So this index number here is -1, index number is -2, -3, and -4. But if you read it from left hand side, it will be 0, 1, 2, and 3. That means 8 can be read using 3 as well as using -1. Both will give you 8 answer only. Is that clear? So 8 to extract 8 from this list, you can either use 3 or -1 because both refers 8 number only. Right? So in our scenario, we have 3 numbers, 4, 2, 3. So if you want to, let's say, pick 2, what will be the index number here, guys? It's 1, right? So we'll have to use 1 to extract 2 from this list. Can you all do that? Can you extract 2 from this list, from this array? Not list, it's an array. So if you want to extract 2, how will you do it? What command will you write? Correct, A1, that's right. So I'm not sure if I showed it by mistakenly, but this is the command. Okay, let me share again. So you can write print A1 or just A1 will also do. It will extract 2 from here. Okay, so this is the output, which is 2. You want to try it with the negative number, you can do that as well. Great. Yeah. Negative will also do. Okay. All right. So this is clear. Now just to confirm, what number of dimensions you have just created this array. What you can do is you can use ndim function. Okay. Ndim is actually not a function, but an attribute. Okay. There's a difference between a function and an attribute. An attribute is something where you are not supposed to pass anything like you do in functions, right? That's why there is no round brackets here. Whenever you see round bracket, that means most of the time that there are arguments which you can pass inside this round bracket. Okay, that's why there are round brackets, right? That is the only purpose. The round brackets are there because there are arguments which you can pass in this function. But in attribute, there is no argument. That means you have to use it as it is. There is no arguments which you are supposed to pass. That is the only difference, and that is why it is called as an attribute. Okay. So ndim is not a function, but it's an attribute. So you just have to write whatever you have created. You have created A, right? So if you want to know the dimensions of A, you write A dot ndim. Will give you 1. That means our created array has 1 dimension. So this validates that. So while Sriharsha list can have different data types, array can only have same data type. That's the difference. Okay, so let us quickly run ndim function or ndim attribute. Done. Great. Now let us try with different data types. All right. We'll try with different data type because I said that in array, you can only have elements of same data type. So to validate that, we will write elements with different data type and see how it, how is it saying that it can only have same data type. Let us put different data type. One will put it as string, one will put it as number, and second again string. Let us see what data type it considers. So write np.array. Again, array is a function, so write round brackets. Within this round bracket, you need to write a list of elements. So write A in a string, 2, and then C in a string. And then you run it, and then you run alpha. So it will give you this same array, but you will see here that everything is now converted into string data type. Yeah. So whenever you have a string data type in your array, you will get D type option also in the output. This basically is in a Python telling you that you have a Unicode or you have a string. Okay, Unicode basically is not for string, but it refers it is only printed, this word is only printed whenever you have a string object inside a array function. Okay, inside this list, if you have a string, you will get this output that data type of these elements, or these elements rather, is less than U11. So it's basically what it is doing is, once it looks at this, it understands that it needs to adjust space at backend to accommodate your text. Okay. By default, text takes more space than a number. That's why Python is obliged to create that space for you. Okay, so as soon as you have string here, it creates 11 bits at backend. 11 bits means you can have 11 alphabets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. Okay, so at once it creates 11 space at backend, assuming that you can create that maybe later on. Okay, so by default it creates 11. If you increase this, the length of this, you will realize this changing because Python automatically updates the space at backend to accommodate what you are writing. All right, you can test it. Let's say I write a huge thing here and again run it. Okay, so it is, I think, still within the limit. Maybe let's say a bigger one. See, now I have a bigger set. So now D type is now not U11, but it is U16. So it automatically adjusts the space at backend. Okay, just to make things in an optimized way. Okay, so you can experiment that and rerun it and check. Yeah, I'll repeat this. So whenever you have string in your list, you will also get output of D type option. D type will basically tell you that what is the amount of space which is being or created to accommodate your string value. It is actually not of that use for us as of now. It probably only comes into play when you have a very large array or very large data set you're working on, which is in maybe in a big data format. Then only these things actually come into play. Otherwise, it is not of that importance as of now because we only have a 3-element list. Okay, but still to understand, this only gets printed whenever you have a string object inside your list. And U means Unicode. Okay, that is basically only referring to a string. Okay, that is a Unicode. That means there's a space being created. And how much space? Unicode of 11-bit size is being created at backend to accommodate your alphabets. Okay. What is the use of data type? Just to tell you that whenever you see data type or D type, it means that you have string in your element. Okay. Scroll up. Okay. Let me know if this is what you want to look at. I will not a little. Unicode, surely Unicode is just it's a system. Okay, in Python we use Unicode as a standard encoding system. Okay, and this encoding means you basically trying to create a character encoding system, which is just to represent every character. Okay, so we have one character here, okay, but how do we represent it, right? That I have one character or one symbol or one text. To represent that, we have a coding point system. Okay, so this is a numeric coding point or a unique numeric code, which we called as a code point. Okay, so I'll just write that down here for your reference. The unique code is a standardized character encoding system. All right, where we are basically representing every character. Okay, and it provides a unique numeric code called as code point. What is the primary goal of Unicode? Primary goal of Unicode is to provide a universal way of representing text. So this is not related to just Python, but it is related to entire computer system. Okay, you will also find sometimes this in Excel UTF-8, correct, or UTF-16 encodings being used, right? So these are basically similar stuff. These are basically used to store your unique characters in computer memory. Because computer, whatever you write, it converts into numeric format, right? And then it saves it into its memory. So that's how it does it. It uses this encoding system. Okay, so it is storing your Unicode characters in computer memory or in whatever storage device. What is this for? This is just for the space efficiency, because it creates space at backends, right? So just for that space efficiency, it creates this character or creates space at backend. All right, let us proceed. Right. Okay. So this was just, I think someone asked me last time that if I want to, let's say, create different space, I want to not create 11, but if I want to create 20, then how will you do it? Then there is a method called as type. So you can just, instead of like how you write ending, you can write as type also, and then you can replace it with U20, and then U20 or the 20-bit size will be created at backend. Okay, but this is not part of scope. This is not actually useful because this Python automatically is creating, I think, optimal space at backend, right? Spacious encoding has already been taken care of, so you need not do this, not required. All right. If at all, let's say you want to check the data type of the entire array, so you've already created array, you already know that it is of one dimension, right? But if you want to know what is the data type of this array, you can just write dot d type, dot alph dot d type, which will give you this output. So it is U11 directly. So this is whatever you got printed here, you can also print it separately by writing d type attribute. Right? Similarly, we again check ndim for alph. Again, it gives me 1 as answer. You can skip this part, but you can run d type and ndim quickly. Okay, that is less than, surely. That means less than U11, less than 11 bits. Yeah, less than 11 length. That's right. All right. Okay, so I hope it is clear so far. Now that we have created one-dimensional array, now let us proceed and create two-dimensional array. All right. Since it is two-dimensional, what the only change which we are going to do is add one more square bracket. Okay. So just count the number of square brackets here. We're writing 2 square brackets. That means it is going to be a two-dimensional array. All right. So I'll again write a equal to np or array. Array is a function. So I'll again write round brackets. And within the round bracket, I'll create 3 rows, which is first row having 1, 2, 3, second row having 2, 3, 4, and third row having 3, 4, 6. Remember, you can also create 2 rows, doesn't matter. Okay, you can have your own numbers, own set of rows. But once you write 2 square brackets, it automatically considers it as two-dimensional. And then you can print A, which will give you this answer. 2-dimension means you're adding one more dimension. Previously, let's say you only had rows. Now you also have columns. So if you look at this data or this array output, here you have these as rows, right? You have 1 row, 2nd row, and 3rd row. But you also have columns, 1 column, 2 column, and 3 column, 3rd column. Difference is basically among the requirements, Sarah. So if I, let's say, have customer detail, let's say this first column is age, second column is, let's say, something else, salary, third column is spends, right? But I only had, let's say, I only have this for 2 customers, 1 customer and 2 customers. Then the 3rd row will not be there. And I will only have 2 rows. But if I have more details, then accordingly more rows will be added. Okay. So if at all you want to create new rows or a new data set to work upon. Let's say you're working on an experiment. Okay? Maybe you want to test out some formula. Okay, so you will say that, okay, I will create my own list of arrays. Okay, I will create my array and apply my formula in this array and see if my formula.
Okay, by using def we will do. Ayush is asking what is the difference between functional and procedure. See, function, Ayush, you are creating a function by using def command, def keyword. But in procedure oriented, you are using small snippets of code. Okay, you are using small snippets of code and then you are using it. It's not a function, but apart from function, you're writing small pieces of code like small software or something of that sort. Not a function in specific, Ayush. Okay, so this is something that we are going to use it. Now, what are objects. So what exactly we are trying to do? So understand one thing, you have certain objects in real world. Can you name some objects, whatever you see around you? Can you name some objects, whatever you see around you? So every object will perform certain kind of a functionality, correct? Every object will perform certain kind of functionality. Now, each and every object you are using to solve a real world problem. So real world object, real world problem, because that object is available to you physically. When you use the same thing in a code, what happens? I will tell you. When you use something in a code, so basically solve real world problems using virtual world objects. So this is what we do in our object oriented programming. We solve real world problems using virtual world objects. So what are virtual world objects here? Can someone tell me? Take a guess. Just like how you have physical, uh, just like how you have your physical objects, you also have virtual world objects. Virtual world objects are nothing but your classes and objects, whatever you write it in the code. Now you're understanding why object oriented programming, how are you going to do things using object oriented programming? You're able to connect properly. Very good. Now, when I talk about an object, when I talk about an object, object basically has two things. One is an attribute, other one is a behavior. So what is attribute? Attribute talks about the name, age, etc. of the attribute, I mean object. Behavior talks about the action that a object will do. So to be more specific, attributes are stored in variables. Behaviors are basically from methods. What's a method? Basically, function in oops. Whatever functions you write, no, those functions in oops are called as methods. Are we clear, guys? Functions in oops are called as methods. So every object will have an attribute and also a behavior. Got it? Right. So you have a name, you have something for an object, you do that. And then for a behavior, you're doing basically your action. So since you have already understood basics of oops and everything, I'm not going to type everything from the beginning. So we will refer to the code and then we will understand the concept. If you have any confusion, you let me know. I will explain it to you line by line. Okay, fine. So this is a basic concept of object. Now, what exactly is a class and what exactly is an object, I will tell you. Assume that you have a design of your cell phone here, right? So I'm just giving you a simple example. So this is basically a master design of your cell phone, which you will not have access to. So this will be available in your factory, correct? Now, using this master design, many copies will be created, which you will be using, right? So on like this. So these copies are your objects. So basically, objects are nothing but instances of class. Got it? So there will be an original master design that will be created once, and then you create objects which are belonging to that particular master design, which are either a copy or they will have characteristics of that master design. That is called as an object. Clear, all of you guys? Understood now? This is the basic concept that we are talking about. So when you have your master design, this is your class. All the other objects that you create from that class are basically your objects. Now let us go to the code part of it. So this is a basic thing that I told you. I don't want you to type all this. So I will just help you to understand these concepts so that we can refresh what you have done and then we can move further. See this, a part of functional programming, you're basically creating functions. A part of functional programming, you're basically creating functions. So basically, this is a def message, hello Python 2, hello Python 3. So this is something that you're trying to create. Now, this is a normal function that you do. There's nothing much in this, there's nothing great in this. So you can create your addition, subtraction, all this. So since we are doing a review, I'll not ask you to do any other functions. But what I want you to do is, wait 1 second. Here, I want you to type this and let me know once you're done typing. Just type this and let me know once you're done typing. I will tell you what exactly we're trying to do here. So once you do this, what you're trying to do is you're taking a variable called a. In that you're storing a number 1000. When you store a number 1000, this particular a becomes an object of your integer class. So integer is a class, 1000 is an object that is a part of integer. Similarly, integers have so many objects in them, minus infinity to plus infinity. All of them have a same character, which is all of them are whole numbers. Understood? Int is a class. In that 1000, 200, 400, all of them are objects. Getting the point? Clear to all of you? Very nice. Now tell me something. So these are inbuilt classes. Your int, float, all of them are inbuilt classes. Correct? So all of them are inbuilt classes. Do you think with object-oriented programming, you can only use inbuilt classes to do programming? Do you think so? No, we might also need to write user-defined classes. So how are we going to write that user-defined classes is by using a keyword called class. If I had covered your oops from the scratch, I would have helped you to type all these things. So since it is covered, you might have an idea. So I'm just showing you the things that I have done, and then by using this you can be able to follow, and also some things I will ask you to type, you can also type it. Okay, see, whatever you are trying to do, you're trying to create a class. As I told you here, whatever you're trying to do here now, this is a class. This is basically a class. This is a master copy. These are objects. So these objects are basically the copies of it. So this is a master design. These are copies. So when you create a class, what you're trying to do, you're trying to create a master copy. So class is your keyword, which you will use to create your class name. Computer is basically your class name. I mean, the class name. Class is a keyword. Now, every class or an object that you create, as I told you, has an attribute and also a behavior. So what is the attribute of this? What is attribute for this? Can someone tell me what's the attribute? Name, age. How do you identify this object? What is attribute? So the name of this class is basically computer. That is the attribute. And what is the behavior of this object? What is the method inside this particular class? Config, correct. So the attribute name is computer. The behavior is config. So this computer basically does this config function, that is the action. In the function body, you can write anything. I'm just writing a small function, that's all. You can write anything. I'm writing a small function, that's it. Now, once your class is ready, just like how you created a variable a is equal to 1000, what we are trying to do here, we are trying to do comp1 is equal to computer. So when you do comp1 is equal to computer, you're basically creating an instance of computer, which means like a copy of computer and storing it in comp1. So what this comp1 becomes now? What exactly comp1 becomes? Can you tell me? Comp1 is an object of computer. So you create this, and then once you do it, you will get class main computer. Like this you should get. So for a sake of clarity, all of you create this class and create this computer. I will give you 2 minutes time. Kindly create it, type it, and once done, let me know done. We will go to the next topic. I'll give you 2 minutes. Please type these two things, run, and all of you should get this main computer. Just like how you got int, what exactly is it? So this is your class, and this is basically your uh, object. Yes, it gives a formatted output. Correct, Anil. Is this clear to you guys? Class and an object concept, no problem. See, whatever you're trying to do, typing it and doing it hands-on. So this is what you're trying to achieve. So I asked you to do that. Now, once we do this, we'll go to the next concept. See, as I told you, in every class, you can create an object. But what I told you here is, with every class, you can create multiple objects with a similar character. So single object may not be used. You can also create multiple objects, right? Single class, multiple objects you can create. So how are you going to do that? You're going to do it like this, right? You can see, as you saw this, you can use the same code, but what I want you to do is, you're creating a class, do comp1, comp2, comp3, comp4, and then check its config. You should actually get the same config for multiple objects as well. Can you create multiple objects hands-on? Use the same code. Instead of comp1, use comp2, comp3, comp4, and all of that like that. Can you do it? Done? Very good. Now you have created a single class and multiple objects. Now what we are trying to do is, you understood that your class here it is having only one behavior, means one function. So as a standard, a class can have multiple functions also, not just a single function. It can basically have multiple functions also, right? So how are we going to have that multiple functions is what we are going to do. That multiple functions you can have by using multiple configs, right? So all of you understand what is self, right? Can someone tell me what is self? Very nice. So this is what your self exactly is. Now, what we are trying to do is define function in a class. Correct. You're right. Yes, all of you are correct. So you can basically go ahead and then create same thing. You can see, you can create one more def here. So this class basically has multiple behaviors and multiple objects. Can you just do this Intel AMD, create multiple objects and then run and check if you're able to get similar outcome? For comp1 you can refer Intel, for comp2 you can refer AMD. So this is not a standard that you have to refer only that. You can refer to anything for that matter. What you're supposed to do is, here in this class, you're supposed to create multiple methods, Intel and AMD, and then create multiple objects and check if you're able to get comp1 Intel, comp1 AMD, comp2 Intel, comp2 AMD. Can we define multiple functions with same name under one class? Try it. Happy? I don't think it will be possible. Just try it once. Try it and then you will know. I don't think it will be possible, but you can just try it once. Okay, class computer. Now, what we are trying to do here is a similar one. You can see here, you're basically trying to create human, human walk, human dance, human sing. So now you're comfortable, right? So whatever you're seeing, are you able to understand this particular class and also objects? So you created a class called human. You're creating walk, dance, and self as its methods, which means these three are the behaviors. Walk is one method, dance is one method, sing is also another method. So these three methods you are basically creating. Once you create these methods, you're creating. So here, walk, dance, and sing you can create comp1 human, comp2 human, comp3 human. So basically, how many objects we created here with human class? 3. And the 3 objects can access how many methods in class human? Those 3 objects can access all the 3 methods of human class. Correct. So comp1 object can walk, com1 object can dance, com1 object can even sing. So that is what we are trying to tell here. Com1, com2, com3. You can access any object. I mean, you can object any method from any object. So don't type this. This concept is clear, na? A class can have multiple methods and you can create multiple objects. All objects will access all the methods of the class. So this is something that we are trying to do. Now, once we have done this, what exactly we are trying to do next is I have something called as a init method. All of you have covered initialization, init method. I will share this file. No. All of you have covered init method. Yes. It is called as a constructor. So constructor is basically used for initializing variables. Variables that you use in our object-oriented programming in your class. The objects that you need, the variables that you need to use in your class will be used by using your init method. Now, what we are going to do here in this particular process, you don't have to type this, understand init properly, and we will go ahead. Class computer def init. So what this init does is init basically initializes the variables. And one thing that you should know about init function is whenever you create an object, I don't know whether it is discussed in the previous session or not, but whenever you create an object, init method will get executed whenever you create an object, right? So whenever you create an object, init method will get run once. Anil, init method you will use if you want to initialize some variables, which you need to use it in your class. If you don't want to use any variables in your class, you don't use the init method. That's all. As simple as that.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatal. So this course, you will master Python data science by working on various Python libraries such as SciPy, Numpy, Matplotlib, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What is the purpose of the init.py file in a Python library? Your options are A. It serves as the main entry point for the library's function and classes. B. It indicates that the directory containing it is a Python package. C. It stores documentation for the library's modules. And lastly, option D. It defines global variable used throughout the library. I hope by now you have commented your answers in the comment section. Now let's continue with our session.
Understood? So if you want to create some variables, you will use init method. If you don't want to create any variables, you don't use the init method. That's all. Okay, nice. Now, one thing that you should observe here is as soon as I run this class, I have created 4 objects. See this properly. I have created 4 objects. Every time I create an object, the init method is getting called. Right? See, that is the beauty of init method. Every time I initialize an object, init method is getting called. Now, what we are trying to do is, you can see here, I want you to type this one code. You have already created class called computer. Add an init method to it. Make it as a self, CPU and RAM. So this is something that you're supposed to type it. I'll give you 2 minutes. After that, comp1 config, comp2 config, we can type it. But just create this class, create as init method. In that, create two variables, self CPU and self RAM, and then create objects like this. Done? Good. Now, what you're supposed to understand here is you're creating two variables, CPU and RAM. So what the CPU and RAM will do is, the CPU and RAM are like initialized variables under init. So the CPU and RAM, what these two things do is, these things basically help you to get the variables when you create an object. So for comp1, self CPU and self.ram will be I3 and 4. For comp2, self CPU and self RAM will be I5 and 4. So this is how these things will be done. I3, 4, I5, 4. So comp1, comp2, comp3, comp4. So this is how basically these things would work. I3, 4, I5, 4, all these things. So this is like you're passing variables into you're passing values to your variables, self CPU and then self RAM. So this is how basically you get it. Understood? So you're basically passing self CPU, self RAM. So when you create comp1, self CPU will become I3, self RAM will become 4. Self CPU is equal to CPU, self RAM is RAM. So what you're trying to do now, so this variable CPU, you're putting into a variable which is called as self CPU, which means this is your initialized variable. So this variable self.cpu, you can access anywhere in your, yes, writing that is mandatory. Yes, yes, you have to write it. Now, once you run this code, you can observe what you're trying to do is you're basically creating two variables, self CPU and then self RAM. Self.cpu is CPU, self.ram is RAM. So once you read this CPU I3, so this I3 will come and store in self.cpu. When you put 4, this 4 will come and store in RAM. So what you're trying to achieve basically here is in self.cpu and self.ram, whenever you create an object, you're passing certain value. That value you can access throughout your class. So that is what you're trying to achieve using your self.cpu and self.ram. You can see here, when you do comp1.config, you will get I3 and 4 along with I5, 16 and 1 TB. See, I5, 16, 1 TB, I3 and 4 you are getting. Similarly, comp2.config, you will get I5 and 4. See, you're getting I5 and 4. So for a particular object, if you want to define something, let us say, for example, you want to define certain variables. If you are basically going ahead and then doing it, this is what you will get. So you are passing value true, but what happens is you have to pass the value in your class. So inside the class to pass the value, Raghunath, you need to initialize the variables first. So this is the process how we are going to do it. Surely, config is a very simple function where you are just printing I5, 16 and 1 TB. I5, 16 and 1 TB is a very simple function that you are putting it for def config. Now, once you put this def config I5, 16, 1 TB, this is a standard output. This is just a simple outcome which will be printed. But if you want to access the variables that you have defined here, which you have defined here, you're basically going ahead and then defining self CPU and self RAM. So once you do the self CPU and self RAM, the variables from your init function will be called into this config method and then they will be printed. Sajani is asking a question, whenever we want to use variable, we will use init. Correct. Yes, Sajani, correct. Shelly, we are calling the variables from the init class. Init function. Yes, init method you are calling it. Correct. You can give whatever name you want, Anil. No problem. You can give any name you want. As long as your variable names are working, you can give any name that you want. Won't make any difference. Any name that you want, you can give it. No problem at all. So do you have to create init and config both? See, init is an initialization method, Sajani. To initialize variables, you have to create init. Config is a general method. You can create whatever you want. You can create a config, you can create something else also. Any method you want, you can create. But init method is compulsory to initialize the variables. That's a standard one. That is what I'm trying to tell you. Clear? Init. So these are the most crucial things that you might need in your data science. See, I will tell you one thing, understand it carefully. OOPS is a good to know thing for data science professionals. You may not use the OOPS concepts in writing your machine learning code. So that is something which I want to tell you. So whatever codes that you write, you will use Jupyter Notebook, you will use scikit-learn, NumPy, Pandas. So understanding NumPy, Pandas, scikit-learn, all of that is very crucial. Machine learning or maybe data science programs will not be written in object-oriented way. So whatever you're writing, you may not use object-oriented programming to write it. But this is a good to know for you since you are learning Python, so you can learn this also. So that is the objective. Nothing much apart from that. Pranav, for interviews, if you're applying for a developer role, they may ask you OOPS, but for data scientist role, I am not sure if they will ask OOPS or not. As far as my knowledge goes, you don't need OOPS for writing data science programs. Okay. Sriram, check the spellings and everything once. If your spellings are right, then I don't think you will get an error. Okay. So this is just information I'm just trying to give you. Next thing is we are going ahead and then showing this. See this in this particular code, what we are trying to do is we are passing in this particular code, we are passing two variables, self, name, and age, right? So self dot name, you're basically using a variable, Naveen. So this human self dot name and self dot age, you are able to get it, na? I will explain it to you, but just see the code first. So here, what we are trying to do is, here you're basically defining two variables in self, name and age. So this name and age, you will pass it whenever you're basically going ahead and then creating your objects. So you can refer to this. Now, thing that you're trying to do is, you can see init self name age, self dot name is name, self dot age is age. Now the self dot name and self dot age, you can access anywhere in your class, anywhere in your methods. Same thing here, defining an object called greeting. You're doing self dot name, which means, hi, my name is self dot name. Whatever value you pass to self dot name, that will be printed here. And then you're basically taking, I am self dot age. So whatever you're passing age here, that will be printed here. So can you do this, guys? So this is just a similar example like we saw in the previous thing. I'll maybe give you 2-3 minutes. Kindly do this. After this, we will go to comparison. Same code, same similar code, but we will do comparison. So this is your init method. Can you do this? Take 2 minutes and do it. We will go to the comparison code next. Very nice. So here, what we are trying to do is, here you're creating two variables, self.name, self.age, and you're comparing them. One thing that you should know here is, when you do h1 dot compare and h2 dot compare, h1 takes your self.name and self.age, h1 takes it. Then other will be taken by h2. When you do h1 dot compare, Naveen will be compared with Praveen. h2 dot compare, Praveen will be compared with Naveen. See, what you're trying to do here is, you're basically doing a comparison of self and also other. So you have defined self.name and self.age. Here you can see h1 dot, you have defined two objects, h1 and h2. Human, Naveen, Praveen. You're doing h1 dot compare. So h1 is your first variable, which will become self. h2 is your second variable, which will become other. So basically, when you do a h1 dot compare, h1 takes self and h2 takes other. So other is not in the self, correct? What you're trying to say is right. But here you're calling h1 and h2. So h2 is also an object, correct? h2 is also an object, correct? So h1 is your self object. h2 also is a different object which will get assigned to your other. So here comparing two, na? When you compare two, h1 comes and sits in self, h1 comes and sits in self, the other object that you have h2 will come and sit in other. Right? So you have to run it properly. So comp1 dot compare, comp2 dot compare, comp2. Okay. So what we will do is NumPy and everything we will do hands-on. Similarly, hands-on. Okay, very nice, Bharat. Very good. So now, what do you mean by inheritance? So I don't think I'll be able to cover encapsulation, polymorphism. I will try to cover encapsulation and polymorphism now. If not, I will take it in the beginning of the next session. Anyway, I will cover NumPy, Pandas, everything for you. So the other one or two concepts, if I'm not able to cover today, I will do it tomorrow. Don't worry. So if required, one or two extra sessions I will take so that all things are clear to you. Okay. Now we are talking about inheritance. So what do you mean by inheritance? Can someone tell me what do you mean by inheritance? So inheritance is nothing but you are inheriting certain characters from your other people as in you're inheriting property from your ancestors, you're inheriting knowledge from your teachers, right? So many things like that. So similarly, what we are trying to do, no problem, Anil. So we'll see much more examples of this. Similarly, in our programming also, we have a concept called inheritance. So what exactly this inheritance does? So inheritance is a process where we are basically going ahead and then inheriting. Basically, we are going ahead and inheriting the methods of one class into other class. So we are inheriting methods of one class into another class. So that is called inheritance. So how are we going to do that? Class, base class, body of the base class. So class, base class, body of the base class. Class, derived class. In a derived class, if you pass a base class name as an argument, then it will inherit all the methods of your base class. So if you pass the name of a base class as an argument in your derived class, it will basically get all the methods of your base class into your derived class. Understood? So basically the only thing that you should do is just have two classes. Whichever class you want to inherit, pass its name as an argument in your derived class. That's all. If you do that, all the methods of base class will be inherited to the derived class. I don't want you to type this in specific right now, but just understand this. You're having something called as a polygon here. What this polygon class is doing is, it is having basically three methods. One is your init method, one is your input sides, third is your display sides. So whenever you take a polygon, all polygons will have input sides and display side, which means number of sides. If it's a triangle, then the sides are 3. If it's a square, then the sides are 4. If it's a 5, then the sides are pentagon, right? So for pentagon, if it is 5, hexagon 6, heptagon 7, octagon 8, correct? Now, what you're supposed to do is, if you want to create a triangle class, you can inherit these three things. If you want to create a pentagon class, also you can take these three things, because these three things are general. You don't have to type them again and again and again, correct? Now, what you're trying to do, you have created a class called triangle and then mentioned polygon as an argument. So when you mention polygon as an argument, what happens? All the three methods that are there in polygon will come to your triangle, right? So basically, tell me, triangle has two things, init and also find area. Two methods are there. But now, since you have inherited polygon inside triangle, how many methods will be there in triangle? Can you tell me total? Basically, you'll have 2 plus 3, 5. Two methods are inbuilt triangle. Three methods are inherited from polygon. Two are inbuilt triangle, three are inherited from polygon. Clear, no? Very good. So this is something that you should know. Two are inherited, three are from your polygon. So this is inheritance concept. Now let me run them. Yes. So Vinay, what I was trying to tell you is, I was explaining the concept of inheritance. Inheritance is nothing but the process of getting the functions or the methods from one class to another class. So how do you do that is, you just have to mention the base class name as an argument in your derived class. So if you do that, all the methods of base class will come to the derived class. All the methods of base class will come to the derived class. So this is your inheritance. Now you can go ahead and then check. So polygon is basically a class that you have init, input sides, display sides. So polygon basically has three methods in that. Once polygon has three methods in that, these are basically talking about the methods that are there in general for every polygon, like a triangle, square, pentagon, anything. You'll have input side, display side. But triangle in specific, you'll have a formula to calculate its area. Now, once you mention class polygon, you have init, input side, display side, and then triangle. Triangle, you have init and find area. So once you do these things, what happens? Your triangle will have 5 methods. 2 methods are inbuilt triangle methods, and 1 method is basically your polygon method. The concept? Yes. Basically, 5 methods you will have. Now, once you have all these 5 methods, what you're supposed to do is no problem. So you're creating an object T called triangle. So once you create T called triangle, this input side, whatever you're seeing, this is a method of triangle or polygon. Can you tell me? It's a polygon method, but you're calling in triangle object. So that is inheritance. Anil, the init inside init. This init, whatever you are seeing now, this is basically polygon. So whenever you come to your triangle, inside your triangle init, you are taking polygon in it. That's all. You need number of sides self dot side. No, you are accessing your polygon init function from your triangle init. So all variables in polygon also will be part of triangle, Anil. Okay, good. Now, all of you know input side is a polygon method. You're accessing it from triangle. So you put side 1, I'll put some value. You put side 2, you put side 3. Now, disp side is basically a triangle function or a polygon function. That is also a polygon function, but you're accessing it from triangle, which is inheritance. Side 1 is, side 2 is, side 3 is. You got all these 3. Correct? This is something that you saw. Now, find area is a triangle function or polygon function. It's a triangle function. Now we are finding area properly. So input side, display side, find area. So these 3 things you have basically created and then you are using it. This encapsulation, I think I will do it in the upcoming session. Vinay, you will not use inheritance in data science. This is a programming concept. You may not use inheritance in data science. Oops itself, you may not use it. These are all programming concepts basically. Okay. Encapsulation and polymorphism, I will cover it in the upcoming session. I'll not do it today. I don't want to rush. Okay. Tomorrow starting we will do encapsulation, polymorphism, and then we will continue with the NumPy part. But now I'll give you a brief recap of OOPS concepts. Just understand whatever things that we discussed. But NumPy will not be like this. NumPy we will basically write everything and then we will code everything. Okay. NumPy we will write and code everything from scratch. So you don't have to worry. I will explain it to you. We will write and then we will code. Okay. Now I will give you a recap of all these things. Just understand it properly. You can see here, as I already told you, Python supports multiple types of programming styles. One is functional programming, second is object-oriented programming, and third is procedure-oriented programming. So these 3 things, whatever we are trying to do, functional programming uses functions. Object-oriented programming uses objects and classes. Procedure-oriented programming uses small pieces of code to do the job. As I told you, you can solve real-world problems using virtual objects. That is your object-oriented programming. Now, what are all these objects? You can see here, every object has an attribute and a behavior. So attribute is nothing but the name, age, etc. Behavior is the action that we are checking it. So all your attributes are stored in variables. All the behaviors are stored in methods. So methods come from the functions. So functions in OOPS, you call them as methods. That's all, nothing else. Then you understood the concept of class. So class is a master design that you are using. It is in the factory. Objects are the copies that you create for a class. So that is something that you do it. Objects are basically instances of class. Once you create these objects, what you are trying to do is you are basically going ahead and then using them for your programming purpose. Now, functions, create functions, you can see hello Python. So you can create a def message, hello Python. So you created some basic functions here. Once you created these functions, you understood how exactly an object is created. A is an object of integer class. Okay. A is an object of integer class. So like A, we have so many other objects. So 1, 2, 3, 4, 5, many other objects are there. So A is basically an object of integer class. Very good. So this is your inbuilt class. As we understood, we will not be able to use inbuilt classes and then do the work. So we understood how to write user defined classes by using class keyword. You wrote computer and then you created a config for computer. Once you created a config for computer, you understood how exactly these things are done, created multiple objects in computer. And then what we did, we went ahead, create multiple methods in computer, then created a different class, different methods, different objects, try to access all the methods from that objects. Then we used init for getting it. Init will be called whenever you create an object. That concept also we learned. And then you understood how self.cpu, self.ram is created in your init method. And then once you created this, we also understood human. So in human, you understood how to create self.name, self.age for greeting. And then you also understood how to compare comparison things that we saw. And then we also had polygon example. So polygon example, we saw it, right? So polygon example we understood. And then in this polygon input side, display side, so these things are all we saw. Then triangle, right? Class triangle, we also saw polygon here. So this is basically our inheritance. So polygon in triangle, you mentioned the polygon name as an argument. So all methods of polygon will come to triangle. And once you did this, we also came and then experimented with this. So next session, we will see encapsulation and polymorphism. Clear, guys, all of you? A brief recap and a little hands-on. Inbuilt class, which is integer. So we understood that. And then once we understood the inbuilt classes, we came to user-defined classes. So user-defined classes are nothing but the classes that are defined by the user, right? So user-defined classes, we went ahead and then we understood. Then we saw the way how these things are written, right? So user-defined classes, main computer. Then we went ahead and then created multiple objects. So these multiple objects that we had, right? So how to create multiple objects we saw. Then how to create multiple methods. So we saw multiple methods. So multiple methods are something, and once we had multiple methods, we also understood how to create multiple methods and also multiple objects. So these things we understood. We understood init, which is a constructor. Init is a constructor, we understood. Then once we understand init method, we came to see the comparisons, right? So self.name, self.age, we went ahead and then we did a comparison of this, greater than, lesser than, so all this comparison we did. Then we came to inheritance. So inheritance is nothing but we're inheriting methods from one class. Polygon is a class where we have these three methods. So init, input sides, display sides. So triangle is also another class. So basically we're inheriting the methods from polygon class to the triangle class. So this is something that we saw. T is triangle, T is input sides. We understood this. We saw how it is done. Then we came to encapsulation. So encapsulation we will be discussing now. So this is inheritance we did. Now talking about encapsulation. So encapsulation is a process of making some variables private. Okay, when you want to make certain variables private, you will be going ahead and then doing something called as encapsulation. So encapsulation is a process when you're trying to do certain variables as private. How are you going to restrict access to those variables? So we are basically going ahead and then restricting access to those variables by using a single underscore or a double underscore. So by using a single underscore or a double underscore, we are restricting the access to that variables. So that is one thing that we all should understand. Okay, so just to by giving a single underscore or a double underscore, we are basically going ahead and then making it as a encapsulated variable, which is a private variable. Now, once we complete this single underscore or double underscore, you're basically putting a init. Init here is a self. So self dot max price. So here max price is an encapsulated variable. What I'm trying to tell you is, if you can just check this max price. So max price is an encapsulated variable. The maximum price of an article, in this case, a computer. Do you think anyone can decide the maximum price of a computer? So anyone will not be able to decide the maximum price of a computer. So it is an encapsulated variable. Only some people will have access to change the max price of that computer. So whoever it is, the max price of the computer, to change it. So what you're supposed to do is, it should not be accessible to everyone to change it. Only limited people should have access to the max price to change it. Now, how are we going to create the access to max price? By using an encapsulated variable. So by using a double underscore, we are basically going ahead and then creating a encapsulated variable. Right? So this is something that we are going ahead and then talking. Now, once we have this particular max price, we are going ahead and then checking it. So see here, df.sell. So here the selling price is self.max price. So this is the max price. You're creating a function called set max price. So set max price is a method that is used to set the max price of a encapsulated variable. The value of encapsulated variable can be changed only by using a set max price function. You need to create a method to set the max price of this. Right? So these three methods are clear to all of you for encapsulation. Partha, no, it doesn't come under abstraction. Can we use any function name? Yes, you can use any function name. There is no specific thing that you should use. You can use any function name. Price, you should use set max price function. Yes, you're right. To change the max price, you should use set max price function. Yes, that is something that you should be using. We call this kind of access modifier in Java. Java, I don't know, Raga. I'm not aware about Java. Cannot have access to max price any other function. Hemchandra, no. Only set max price will do it. Good. So this is encapsulation, basically. So what we are trying to do is, we are having a init method, cell, and also you're having a set max price method. So these three methods are available. So once you have these three methods, so what we are trying to do, we are trying to do c is equal to computer, c dot cell, d is equal to computer, d dot cell. So once you go ahead and then run these, c is equal to computer, what happens to the constructor after invoking set max function? So constructor, nothing will happen. It will function regularly around. So there's no change. Now, once you do that, you can see you have initialized set max price to 900, which means set max price is 900. So the max price that you are basically going ahead and then doing, the set max price is basically 900. Then once you set this max price, the set max price is 900. Then later, once this is done, you can see selling price is 900, 900. Selling price both the times it is 900. Now, once you have the selling price, you can see here, I have made it 900. Now, what will happen is, if I go and then directly change C dot max price is equal to 1000, do you think it will change? So if I directly go and change C dot max price is equal to 1000, it will not change because max price is an encapsulated variable. Max price is basically an encapsulated variable. It will not change, right? So max price is an encapsulated variable. It would not change. Now, once you basically go ahead and then let us say you want to change it. Okay, so if you want to change it, what you're supposed to do, the max price can only be changed by using a set max price method. Only by using a set max price method, you can change this. Okay, see? Once you go ahead and then put the set max price here, C dot max price, this one, once you go and use the set max price method, it will change. It is 1000. So basically you can change your max price only by using the set max price function. Nothing else apart from that. Now you see, this is how basically it comes. Got it, everyone, without any problems? Understood? For every object, we have to invoke max price. No, you don't have to invoke max price. So if you want to change it, you can invoke it. If you don't want to change it, you don't invoke it. That's all. It's not compulsory that all of you should invoke max price every time. Only if you want to change it, you can invoke it. If not, not required. So that's the only thing that you're supposed to do. Now, let us go to something called as polymorphism. Right? So to set max price as 1000, Arun, you just put set max price of 1000. That's all. You have to set that as here in init function when you initialize. No, there you have to set it. I am not having rights to unmute, so you can type the question, right? So this is what encapsulation is. Encapsulation is nothing but making a variable as private. This is something that you should understand. Then once you have this, you have something called as polymorphism. So what do you mean by polymorphism? Polymorphism is nothing but it is using a common interface for multiple forms. So using common interface for multiple forms is called polymorphism, which means same kind of object existing in the multiple forms. So this is an example that we are going to do. Here, what we have done is we have created two classes. So what are those two classes that we have created? We have created two classes. One is a parrot and one more is a penguin. So here there are two methods. You can see fly, fly, swim, swim. So you have fly and swim, fly and swim. So for parrot and also penguin. Can you type this, all of you? Take a minute and type it, please. In the init method, you can give whatever max price you want, right? And then if you want to change it, you have to call your set max price. See, I've used it here. By using c.setMax price of 1000, you can change the price. So these are the two things that you can do. One is setting a price with your encapsulated variable and changing the price of that encapsulated variable. So these are two things that you can do. No, set max price is user defined. It is not built in. So all of you, can you please go ahead and then type this, whatever I'm just trying to tell you here. Slowly. Slowly do it, guys, all of you. Slowly do it, all of you. Once done, let me know that you are done. So we'll go ahead further. So what we are trying to do here is we are basically going ahead and then trying to get the functions, okay? These functions, whatever you're seeing, fly and swim, are same named functions in different classes. So polymorphism is a process where the similar functions exist, the same functions exist in different classes. Now, how are we going to do it? You can see here, to access these things, we need to create a common interface. So how am I going to create a common interface here? So common interface here we can create by using def flying test of bird. You can see def flying test of bird. So what is flying test of bird? You can see this is a common interface function. So flying test is something that you are basically going ahead and then connecting both the flies. Bird dot fly. Bird, you're passing it as an argument. If you give penguin, it will access penguin dot fly. If you give parrot, it will access parrot dot fly. So whatever you give, it will access this. So can you type these things? Now I'm creating two objects, Blue and Peggy. So when I run flying test of Blue, then it basically access parrot fly. Then when you access Peggy, it will access penguin fly. So basically it is nothing but accessing a similar name with different things. Can you type this and then let me know once done, please, without any issues? See, Parth, this is nothing but polymorphism is nothing but the way you access the things, right? So parrot and penguin are two things. So parrot and penguin are two things. Whatever you are seeing here, whatever you are seeing, na? So this basic thing is you are creating multiple methods. So these multiple methods that you are using, that is nothing but fly and swim. So this is parrot. Penguin also you're using fly and swim. What we are trying to do is we are trying to connect these two. Even though the name of methods are same, we are trying to access them like this. So once you understood this, our next discussion will be for what do we call it as? Okay, I will wait. All of you type it, please. Okay, you want me to explain error? Okay. Guys, I think you have done some kind of a spelling mistake. Just check it once. Okay. See, what I have done here is I have done two classes inside which I have given two methods. So I have done two classes inside which we have created two methods. Then once you create two methods, once you have created two methods, inside that you have two methods called fly, swim, fly, swim. So two classes, parrot, penguin, two methods, fly, swim, fly, swim. So these are the things that we have. Then we have a common interface. So this common interface is flying test of bird. So this is a method where what you're trying to do is you're passing bird as an input. So once you pass bird as an input, if you pass parrot as an input, it will access parrot.fly. If you pass penguin as an input, it will access penguin.fly. So this is the common interface that you're creating between your parrot and penguin. Okay, parrot and penguin. So this is a common interface that we are trying to create. Now, once you create this, you are supposed to do an instance. You are basically instantiating an object. So you're basically creating two objects. Blue is parrot, Peggy is penguin. So you're basically putting two. Blue is equal to parrot, Peggy is equal to penguin. You created two objects here. Now what happens is flying test of blue, if you give blue is what parrot. So basically it goes to parrot dot fly. So if you do flying test of blue, what is parrot dot fly? It is parrot scan fly. So that is something that you will get. If you give flying test of Peggy, what you will get this, you will get penguin, penguin dot fly, which means penguins can't fly. So this is something that you will get. Flying test of blue, flying test of Peggy. Understood? Happy understood how exactly this common interface is working? This is nothing but a function. Understood? Good. So this is something which all of you should know. Now, what we will do is we will go to the next topics, which is nothing but our. So what is the concern, Shivani? Can you elaborate? I did not get the input. So you want me to do it faster or what is it? I don't get it. So you want me to go faster? So guys, is this space okay to all of you? See, I tell you, Shivani, even if it gets a little delay, don't worry. One or two extra sessions we will take and then we'll close it. But don't rush is something that I'm asking you. Okay. It's okay. 1 or 2 days plus or minus is okay. But don't rush. Okay. Good. So what we are going to do now is I am going to create a new Python file. Okay. I'm going to create a new Python file. Let us start with that. I'm going to rename it as, we will start with the libraries. I will tell you what is a library and everything. Numpy, Pandas, Matplotlib. So I'm renamed it. So we will understand what is a library and then we will see what exactly is a library and how we are going to solve it. Okay. I will give you the OOPS code. You can practice it. No worries, no issues. So we'll start with NumPy now. I want to understand one thing. Have you worked with any libraries before? Anyone worked with any libraries before? No? Okay, not in Python. Okay, fine. Collection of different packages. Okay, nice. So libraries are nothing but they are, as you said, collection of code and everything. I will tell you what are all the things that are there in a library. But you should understand the functionality of a package or a library initially to know what exactly they do. Right, so I'll give you a simple example. So all of you are using smartphones, right? You can just check. So when we talk about this, you have various functionalities that are there in a smartphone, right? What all things that you can do? You can basically send messages, make payments, use it for navigation. Then what else you can do? You can use emails, etc. You can use many things like that. So for these functionalities, we have dedicated applications, correct? So for these functionalities, you have dedicated applications like this. Correct? Now, in a similar way, what we are trying to do is we are basically going ahead and then checking a laptop that we have. Basically, we are going ahead and then checking a laptop that we are having here, which is running on Python. So basically, this is running on Python. So in Python, what are the few things that you're supposed to do? So you're supposed to go ahead and then do, let's say, numeric computation. So numerical things that you're supposed to do, then you might have to do data manipulation. You might have to draw some graphs. You might have to do some machine learning exercises. So all these things you might have to do. So for this, what you have is you have dedicated applications. So these applications, if you can see, you have something called as Numpy. You have Pandas. For graphs, you have Matplotlib. For this, you have sklearn. So why am I giving you all these things is, see, these are the libraries that you have, Numpy, Pandas, Matplotlib, sklearn, and all of that. Getting the point? Just like how you have applications for doing specific job in your smartphone, we also have some applications like Numpy, Pandas, Matplotlib, and sklearn in Python, which does a specific job. Is it clear to all of you without any problems? Now, what are the things that a library contains is something that we see. So when you basically download a library from your internet, so a library will have mainly three things. You call it a library or a package, both are same. Okay, this basically has some predefined functions, pre-compiled code, and then it can also have some data sets. So these are the three things it will have. It can have some predefined functions, pre-compiled code, and data sets. So these are the three things that this particular library or a package will have. Understood to all of you without any problems? Very good. Predefined functions, pre-compiled code, and data set. So this is something that we have it. Now, once you have this library and package, we will see practically how we are going to use this library and package for our purpose. Okay. So to start with, so we are going to talk about Numpy, Pandas, and Matplotlib. So they are the three major libraries that we will be using. Now, if you can check, how are we going to use Numpy? So Numpy is basically used for numerical computation. Okay. Numpy is a library that is used for numerical computation. So once this particular library is used for numerical computation. You will know how numbers are calculated. So how do I install a library? By using a pip install numpy. Right? So basically pip install numpy. So if you do a pip install numpy, you will get something like this. You can see, you can observe. Once you run this, you will have something of this sort. Requirement already satisfied, which means you have installed your numpy already without any issues. Done. All of you do this. All of you type with me. Done. Now, what we will do is we will see how many functions are there in NumPy. So if you do dir of np, it will give you an error. For this, what you are supposed to do is, I will tell you one concept. Listen to this carefully. Whenever you assume that this is your computer memory, okay, this is your RAM, this is your hard disk. Whenever you download a library, what happens is it gets downloaded into the hard disk drive. Right? Now, once it gets downloaded into the hard disk drive, you will not be able to use it directly in your Python session. So if you want to use certain libraries, you cannot load all of them. You might have to use one or two only. So for this, what you're supposed to do, you're supposed to do something called as an import. So importing will help you to load your library from hard disk to RAM so that you can use it. Right? Understood the concept? Very good. So this is how you basically import it. Basically, I will remove it. Import numpy as np. So you're supposed to go ahead and then import numpy as np. So this is something that you're supposed to do. Import numpy as np. Now, if you do dir of np, you will see all the functions that are there in your numpy. Can you run these two things and let me know, please? Yes. Once you install it, it will basically, Anaconda will basically install everything and keep it for us. Yes. So dir of np means list the contents of the numpy directory. That is what dir of np is all about. Yes, since Anaconda is installed, everything else is taken care. Correct. So dir of np, you do it. Now, if you want to know how many functions are there in NumPy, you're supposed to do len of dir of np. So there are around 600 functions. Can you do it and check if you're also getting the same number or not? Very good. 620. Yeah. So these numbers will vary a little bit, right? So it'll vary a little bit. The reason why it'll vary a little bit is the version that you are having of NumPy, the version that I am having, both might change. NumPy dot underscore underscore version. You give this, then you will know the version. Check your version. This star means it is still executing, Anil. It is still under process. If that doesn't work, what you do is you do kernel restart and then run everything from beginning. Can you check your version? You might be having a different version. Very good. So what happens is, whenever you use something like this, so whenever you use something of this sort, this thing might vary, which means whenever you're using something of this sort, the what do I say? Like, based on the version, the number of functions might vary. So that is something that we are going ahead and then trying to do. Now, once you have imported NumPy, guys, one more thing I wanted to tell you is, today I will be closing a little early, maybe around 8:30ish we will close. Since I'm a little unwell, I will close it a little early today, please. Okay. We will continue properly tomorrow. We will close a little early today. I did not wanted to cancel this session, so yeah. So len of dir of np is 600 np dot version. So we understood how to create a NumPy version also. Now NumPy basically has a type of data structure which is called as a n-dimensional array. I will tell you what is a n-dimensional array. I will tell you how to create it. Okay. See here, if you come to this list of functions, you will see one function called as np.array. I will show you an array here. We will use that function right now. We will use few functions which are mentioned here. All 600 we will not use. We don't need also. You can see a range also we will see in some time. But right now we will use this array, np.array. In NumPy, use the array function. So basically what you're supposed to do, import NumPy as np, import NumPy as np, a is equal to np.array. Okay, np.array. So what we will do is, inside this, it is requirement already satisfied, Vinay, don't worry. That is okay. So in this, you are basically writing a list. So what type of data is this? Whatever I've highlighted, you might have read it before. What type of data is this? This is basically a list. So you're converting a list into a NumPy array. So what you are supposed to do? Print of a type of a. Print of a is 1, 2, 3, 4, 5, 6. Type of a is numpy.nd array. Slowly do it, because NumPy array carries one argument, which is 1, 2, 3, 4, 5, 6. It's a list. So if you want to convert a list into a NumPy array, you need to use like this. Done. Very good. So similarly, here you are using a list. You can use a tuple here. So to convert a tuple, you're making this square bracket into a round bracket. Once you convert it into a tuple, you will get a similar NumPy array here also. Can you try this also, please, guys, once? Import NumPy as np, a is equal to np.array 1, 2, 3, 4, 5, 6. So this is how you do it using a list and also a tuple. Where is double quote? I have not used double quote anyways. Okay, done. Good. So NumPy array, that is not a list, BK. It's a NumPy array. Is it sorting the array differently, then for list or tuple, it's the same. No, see what it is trying to do is, what you're seeing here is a NumPy array. What you're seeing here is also a NumPy array. For list and a tuple, when you convert them into NumPy arrays, you will get a proper NumPy array like this. You will not get anything differently. Right? And NumPy, you don't have to import it every time. Just we are starting to learn, so I'm importing every time. If you import it once in the top, that is enough. You don't have to import it every time. Array spelling is wrong, Sarita. Just check. Yeah, start of every new session, you have to import. So once you shut down your session, the import will vanish. You have to import at the start of every session, Bharat. So this is how you create a NumPy array using a list and also a tuple. Now, the next thing that we will go ahead and then see are two things. Do we need to give same data types all time elements of the array? No, you can give different data types also. You can make changes to NumPy, Ankur. Yes. Okay, nice. Now, what we are going ahead and then doing is the other two we will do. So these two things behave similarly. List and tuple behave similarly. Whereas if you go ahead and then use a set here. So if you use a set, no, it will give you like a set. So I can use 1, 1, 2, 2, 2. See, set, all of you know that it is a unique collection of elements. So you can see here, you are getting a unique collection of elements, but it is unordered, right? So set is basically an unordered unique collection of elements. So you will get a outcome like this, which will not have any meaning. So NumPy array is meaningful with respect to list and tuple, not with respect to set and dictionary. Okay, Karthi, how to save these codes as a program file? See, if you just put it here, it will save automatically into IPython notebook, and then you can do whatever things that you like with this file. This is not a Python file. This is basically a IPython notebook, IPYNB. Right? So IPython notebook file this is. So that is the behavior of a set. You have learned sets, right, in the basics? Sets you have learned in the basics? Yeah, set is basically an unordered collection of elements, unordered, unindexed. So there will be no index to the set, there will be no order to the set. So as I told you, 23 is in the end because set is no order. There is no order, there is no index, Ayush. That's what I told you. It will come wherever it is. So that is why set is not valid. It is not generating a proper array. Only list and tuple you can consider it using your NumPy. Similarly, I will give an example of dictionary also. This also will not be valid because see here, this is how it generates. Here also it gives you like a dictionary. It doesn't give you like a NumPy array. So these are some things that you should understand here. So in your NumPy array, you will not be having a proper set and a dictionary, but you will be using only for list and tuple. Is this clear to all of you without any questions? So once this is clear, what we are going to do is we are going ahead and then seeing how to generate an empty NumPy array. So if you want to give an empty NumPy array, just pass an empty list. Can you create this empty NumPy array and tell me? Pushpak, what you want to explain again? Can you tell me what you want to explain again? Right? All of you understood how to create NumPy array, a empty NumPy array using list, tuple, dictionary and set. All four. All of you should understand that We will look at all of that pushback slowly. BK, we cannot read a NumPy array. I mean, we cannot read a CSV into NumPy array. We will not be able to read it. We will read it using Pandas, not using NumPy. Okay. Now, what is it that we are going to do next is we are going to talk about two helper functions. Okay. I'm going to talk about two helper functions. So what are these helper functions? So these helper functions are nothing but the functions that are used to basically go ahead and then generate certain type of ready-made functions or arrays to us. So how these things would work, right? So you can see here how these helper functions would work. I have something called as zeros and ones. So import numpy as np. So once you import numpy as np, you can put z is equal to np dot zderos zeros of 3, 6. Then you can do print of z, then type of z. You can do a print of z, then type of z. So here what you are getting is you are basically getting some numpy array, which you are basically going ahead and then using it for whatever we are trying to achieve here. Can you do this? You're basically trying to generate a zeros, a numpy array 3, 6 with zeros with the help of this helper function. Zeros is an inbuilt function. Yes. 3, 6 is 3 rows and 6 columns. So these helper functions, if you want to quickly create a numpy array of zeros, a numpy array of ones, or a numpy array of any other function, you will use these, right? Based on the scenario. So in case if you want to create something like this, numpy array of zeros, numpy array of ones, or numpy array of anything else, you will use this. So numpy imported Arun, once if you import it, it is sufficient. Since we are practicing, we are importing it every time so that we don't forget. That's the only reason, nothing else. So 3, 6 is 3 rows and 6 columns. Alagu Sundar. So similar to this, what we will do now is we will basically take another import. You don't have to import it everything, but I'm just importing so that we don't forget it. O is equal to np dot ones. Okay, once you can give 3, 6. You can see here print of O, type of O. So if you give here, you will get a numpy array of ones. Can you do the zeros and ones? Can all of you do the zeros and ones and let me know once you're done, please? Ones and zeros are helper functions, correct? No, Ashwani, not every time. So since we are practicing, I'm importing it every time. So Vivek, why it creates a 1 dot is because it is a floating point number. So whenever you create it, by default, it takes as a floating point number. It will not give only whole number. It's a floating point number. That's a default. Okay, good. Yeah, once for a session is enough, Ashwani. Just we are practicing now. I'm putting it every time so that we don't miss it. That's the only purpose. Now, I will go ahead and then show you something. Import numpy as np. F is equal to np dot full. So here again I will use 3 comma 6 and then I will use 34. Print of f type of f. So if you do this, just like how you created 1 and 0, by using a full function, you can create a numpy array of anything that you want. You can create it for number. You can also create it for a string. Can you do this numpy dot full for a number as well as a string quickly? So what you're supposed to do, BK, for that is, first you have to create a list or a tuple. You would have understood how to do reshape and all that, na? In the beginning, have you understood how to reshape the array? Reshape, resize array? BK, are you aware of it? What we will do is, I will teach you how to do that in the upcoming sessions. You have to take a list, reshape it, and then convert it into a numpy array. That is how you're supposed to do it. Okay. So we will see all of that slowly in the upcoming sessions. Okay. So these are the basic helper functions. Now, once we are done with this, what we are going to do is we are going to create some random numbers. So we are going to create ones, we are going to create zeros, we are going to create other things, a range, linspace. So generating the data, everything we will do, but those things we will try to take it up in the upcoming session. So I will not go ahead and then load you with the things right now. So now what we will do is I will basically give you a brief recap of these things. Did the previous faculty give you any books to read, by the way? I will give you one simple book now. Only I'll give you one simple book now. No, every time type is not necessary, Amruta. I'm typing type just to check if it's a numpy array or not. Okay, every time type is not necessary. I will give you one simple book, 100-page book that will clear. So if we can observe all these things, whatever we had discussed and whatever we were seeing, we started with NumPy yesterday, right? Major thing in NumPy, what we did is we saw what exactly is a library. First thing we understood what is a library. And once you have that library, you were seeing what are all the things that we can do using that library, right? So just like how you have your apps, mobile apps, you have the other things as well, right? So we have the other things as well. Just like how you have your mobile apps, we also have the laptop, which is if you need to perform some action, you need to use certain functionalities. So those functionalities come from libraries. So what exactly are these libraries? So these libraries are nothing but whatever things that you're using on a day-to-day basis. So for numeric computation, for data manipulation, for graphs, for machine learning, all these things, you will be using your libraries. So why do I need a library? As I already told you. So libraries are basically, you will be, right? So library basically you will use to do a specific task. So whenever you're using specific library, NumPy, you will use NumPy to do numerical computation, Pandas to do data manipulation, Matplotlib for graphs, machine learning by using sklearn. So all these things you will basically use it. So this is why you will basically use your libraries. So majorly, this is the purpose of the libraries that we have. Now, once you are aware of this, once you are basically using this particular library for this purpose, what we are trying to do is we are checking if we can use these libraries for something else as well. So something else as in, so we can basically go ahead and then use these libraries for other things like graphs, machine learning, etc. Now coming to the contents of library or a package, it has some predefined functions, it has pre-compiled code, and also it comes up with data sets. So these are the three major components of your library. Once you are aware of this, you see there is a concept of importing your library. So how are you going to import your library? So the library, basically, whenever you download it to your hard disk drive. Once you download your library to your hard disk drive, you put it into your RAM. You import it into your RAM. So whatever it is in your hard disk drive, it will not be counted whenever you're going ahead and then doing a using of its functionality. A library will be counted only when it comes to the RAM. So to use a library, you need to import it to the RAM. So this is the thing that you're supposed to do. And once we have done that, you understood how to install a Numpy library. Importing Numpy, you understood why importing is important. Then you check the functions by using dir of np. Once you understood the dir.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. Through this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplot, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What does the underscore init underscore dot py signifies in Python package? Your options are A, it indicates the primary function of the package. B, it is a placeholder file. Option C, it is used for initializing variables. And lastly, option D, it denotes the end of the package. You can comment your answers in the comment section. Now let's continue with our session.
Dir of np. Len of dir of np we also saw. So this is the length. Then np dot hyphen version. So this version also you understood. Then once you have np dot hyphen version, you also got import numpy as np. A is equal to np dot array, right? So a is equal to np dot array. Then once you have this numpy array, you created this numpy array using a list. Then you used a tuple to create it. Then you used a set. Then you used a dictionary. And then once you did all these things, you basically started using creating an empty array. Then we saw helper functions to generate a numpy array of zeros, ones, and full. Numpy array of zeros, ones, and full. So these are some things that we understood, and then these are some things that we started. Clear to everyone till here? Okay, so we will go ahead and then understand. Now, I will teach you some functions to generate the data. So you understood how to create numpy arrays. Now we will understand how to generate data. The first thing to generate some data is a function called as arange function. So basically, arange is a function that is used to generate certain data. Here you will use start, stop, and step. So basically you will use start, stop, and step in arange. So how are you going to do this? Step is nothing but step size. Once you do this, what we do, np dot arange of where do you want to start? You want to start at 0. Then you want to end at 101. So 101 will be ignored, but you will go till 100. What is the step size? 1. So if you take step size 1, any guess what it will print? 1, 2, 3 up to, it will print 0 to 100. Correct? Step size is 1 means it will print 0 to 100. Now if you make step size 2, it will print 0, 2, 4 like that. So if I make step size 10, it will print 10, 20, 30, 40, 50. So this A range is clear to all of you. Start you give, stop you give, step size you give. This is the thing that you're basically going ahead and then talking about right now. Yes, you just basically generate the data like this. This is A range. Now, you also have something called as lin space, not line space. It is lin space. What this lin space does is, lin space generates equally spaced numbers. Basically, linspace generate equally spaced numbers. So how are we going to do that? np dot linspace. Okay, a linspace of 0, 100, 1. If you give 0, 100, 1, you're telling generate one number between 0 and 100, which are equally spaced, which means it will generate 0. If I give 2, it will give me 0 and 100. Correct? If I give 3, it will give me 0. Sorry, if I give 3, it will give me 0, 50, 100. If I give 4, it will give 0, 33, 66, 100. If I give 5, it will give me like this. So here you are talking about step size. Here you are talking about how many equally spaced numbers I want between 0 and 100. Understood? Parts are equal. All of you understood, guys, this one? A range and linspace. Okay, I will repeat both of them. See, what A range is doing is, A range is basically generating a numbers between range. So what is the number between range? The number between range is you are having 0 and 101. The number between 0 and 101, 10, which means you are generating numbers between 0 and 100, 10 numbers. Step size means between 0 to 100, you are jumping 10 steps and going. That is your A range. Linspace is between 0 to 100, generate 5 numbers which are equally spaced. Means difference between 0 to 25 is 25. 25 to 50 is also 25. 50 to 75 is also 25. 75 to 100 is also 25. So that is what you are trying to do using linspace. Clear? Clear? Okay. So last time I will repeat it for people who have not understood. Satish, listen. So A range is a process where you are generating numbers by using start, stop, and step size. Start is 0, stop is 101, and step size is basically the number of steps you want to jump. If you give 0, 101, and 1, you will get numbers between 0 to 100. If you give 0, 101, and 2, you will get the numbers 0 to 100, step size 2, means 0, 2, 4, 6 like that. If you give 0, 101, and 10, you will get the numbers 0, 101 like that, 0, 10, 20 like that till 100. So this is start, stop, and step. What linspace does is, linspace basically generates the numbers between 0 to 100, the equally spaced numbers. The equally spaced numbers it will generate 0 to 100, 5. 0 to 100, 5 means between 0 to 100, generate 5 equally spaced numbers. That is what it generates. np.linspace. That's all. What exactly we are trying to do now? Someone asked me how do I upgrade? You upgrade your NumPy by using pip install NumPy hyphen upgrade. If you do this, pip install NumPy hyphen upgrade, then you are upgrading your NumPy. This is what you are supposed to do. Okay, I will just comment this code and then I will keep it. If you want, you can use it when I give it. Now you understood how to create zeros, how to create ones, how to create full, how to create arrange, linspace, and all of that. Now we will see how to generate random numbers. So np dot random of, let's say, 4 comma 5. So by using this, you will generate 4 rows and 5 columns of random numbers. Random numbers will always be numbers between 0 and 1. Random numbers will always be numbers between 0 and 1. Why we use random? Random numbers, you need it because you may have to generate some random values. So let us say, for example, right? So let us say, for example, you might have to do sampling. Okay, you have some 10,000 data points. In the 10,000 data points, if you basically want to do certain samples, you might have to go ahead and then use your these things. What do you call? If you want to do that, you might have to go ahead and then use your random sampling. So to do random sampling, you might have to pick up random numbers. So in that cases, you will use random numbers. Clear till here? So why two randoms is, Arun? See, np.random is a class. I will show you. We have seen it already, but I will show you. Okay. dir of np. What is dir of np? dir of np is this random. See, you will see random here. This is one function. I'll show you. There is a random function here. Inside this, you will have sub function. dir of np dot random. If you give inside random, you have another sub function where you can generate random integers, where you can set random seed, all these things. So np.random is a function that will basically generate a random function for you. Ashwani, yes, OTP generation and all of that. Random values cannot be integers. We have to write some code. Mayank, this is default decimal points. You might have to round them to get some kind of a. Now, once you have done this, we will go ahead and then start with something called as array inspection. So what do you mean by array inspection? So you create certain arrays and then you might have to inspect those arrays, correct? So how do you understand what are the contents of the array? What is the shape of the array? All of that. So if you want to do some kind of array inspection, there are certain functions that will help you to do array inspection. So some basic functions that will help you to do array inspection. There are some complex functions. We will start from the basic ones and then we will go. Starting, we will create an array first. Import numpy as np. So you create this. Then you do arr is equal to np dot random. So you create an array of 4 comma 5. So this one you created. Okay. Now print of arr type of arr. So if you do this, you will basically get numpy.ndarray. All of you do this initially. and then we will see what to do next. Good. Now, see, this is a small array. You have it like 4, 5. But what if you have a very big array where you have millions of records? So first thing is you're supposed to check the rows and columns of this large array. So how are we going to do that? We are going to do that using arr.shape. So if you do arr.shape, so these are the functions. Okay. Just check this. Ashwani, 2 braces showing 2 dimension. No, 2 braces is because the random.random takes only 1 argument. So you have to pass the contents as 1 argument. So tuple. Correct, Anil. So arr.shape. Can you do this arr.shape? This basically will give you the rows and columns. Then once you do this, arr.shape is one thing. Then number of elements in the array. So what are the number of elements on the array? arr.size. So if you do arr.size, you will get 20. So arr.shape, arr.size, you will get shape and size. Then you also have dimension of the array, arr.endem. So if you do it is 2, right? Shape, size and endem are the 3 things that you're supposed to know for understanding the rows and columns, number of elements, and also the dimension. And last but not the least, the data type of elements in an array. So this you will get by arr.dtype. So if you do this, you will get the basic information about the array. First thing about the array, you will get the shape. Second thing, you will get the size. Third thing, you will get the endem. Fourth thing, you will get the data type. Means the array is having float data points. Is nothing but just to create a separation line. That's all, nothing else. Done? Good. So as I told you, it does not change the original array. What it does is it takes a copy of this 12 elements, reshape it, and then print this. But if you go ahead and then check the original array again, print of ls, the original array will not be changed. You can see here. This is your np.array. Reshaped it. But the original array still remains the same thing, which means reshape will take a copy of the original array, and then what it does is it will give you a modified copy. It will not change the original array. Now, let me take the same thing and then I will explain you resize. See here, I'm taking the same element. I'm just commenting it out here. One by one, I'll remove the comments. I have the same array here. Then what I'm doing is instead of reshape, I'm doing resize. Once you do resize, what happens is you will get none as an output. Because resize does not give you a outcome as a numpy array. It will not give you an outcome. But what is the functionality of resize? The functionality of resize is it will change the original array. Here in reshape, it takes a copy of your original array, changes and gives you the output, but it will not change the original array. But in resize, the original array will get changed. It will not give you an output. Is that clear, guys, all of you? All of you do this, reshape and resize. So I will explain you one more time. See, reshape, you have an array. When you reshape this array to 4, 3, you have 12 elements, you're reshaping it to 4, 3 array. What this does is, it takes these 12 elements, convert it into a 4 rows and 3 arrays NumPy array by taking a copy of this. So this takes a copy of these 12 elements, convert it into 4, 3 and gives you an output. Now, what you're trying to do, you're using resize. What this resize does is, it basically changes the original array. What it does when it changes the original array, it takes np.array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here it will not give you an outcome when you resize it. It directly changes the original array, whatever it is. Right? So none is because it will not return an outcome, Mayank. Resize will directly change the original array, no outcome will be returned. How to cross verify and differentiate between both? Both are different. You cannot differentiate. You have to print your original array to know the difference. Anil. Reshape is used to insert certain things in an array. Not exactly inserting things into an array. It is basically used to change the way how the arrays are being modified to the reshaped. Yeah, BK, it will store that value into X. But see, your original array is LS. If you want to store the reshaped array into X, you store it. But if you put ls is equal to ls.reshape, then it will replace the original array. Changing where you store also matters, BK. Done. So this is basically a one dimension. Then what we are trying to do next? Next, we are going to do a 2 dimension. So I will basically go ahead, create a array, which is basically 2 dimension, 10, 20, 10, 20. So this is a 2-dimensional array. np.array, there is a small mistake that I have done where I have create a bracket here. Yeah. There's a small mistake again. I need to give one more bracket. Yeah. See, create this. np.sum will just add up all these numbers. That's it. This np.array 10, 20, 10, 20. Can you do this still here? We will go and then check the next things. Just do it till here. Once you do this, if you do np.sum here, here also you'll get 60 only. Do the same thing. Let me know once you are done. I will teach you some important topics now. Okay, generally typos come when you use special characters or bracket or yes. So that errors will come when you use them. See, what happens is, if you use a list, use square brackets. If you use a list, use square brackets. Round brackets are used whenever you're using a function. np.array is a function. See, inside a function, you're passing your square brackets, which means you're passing certain list, Bharat. So what you're supposed to do is, you have to do a little bit of practice. Once you practice, you will be able to go ahead and then do the all other things. Right? So this comes with practice only. You don't have any other option. So kindly do practice and then you will be able to get it. Okay. This is basically a list inside a list. That's all. Correct, Raghunath. Now, np.sum here also, both the places, it is just adding up numbers and giving it to you. I will introduce you to one very important topic right now. which you are supposed to understand. This is applicable everywhere. Here you do a column addition. When you put something called as axis is equal to 0, you will get a column wise addition. See here, column wise addition, you are adding columns 10, 10, 20, 20, 20, 40 like this. This is a column wise addition. See, why it's not a tuple, it's a function basically. It's not a tuple. Here, np.array is a function. So open bracket, close bracket. So this bracket is basically to pass arguments inside that function. It's not a tuple. You're not passing a tuple here, Bhanupriya. Understood? It's a function. You're passing arguments inside that function. Got it? Good. Now, the next thing that we are going to do is addition only has your rows and columns, whereas the subtraction and all of that will not be supported properly in NumPy. So that is why we will use Pandas to do all these things. 10, 20, 10, 20. So you can do subtraction also like this. Subtract. There's an issue. Where is the issue? I need to give another bracket. Yeah. No, there's no need of another bracket. There is an issue. Where is the issue? Okay, I just don't need to give this. Okay, see here, it is subtracting. So you don't have to go ahead and then get into details because Pandas will be used majority for all operation. Multiply, you can do multiply. Multiply. Yeah, spelling mistake. Yeah, see, multiply, and then we also have divide. You can get this. Yeah, this is basically everything will happen column wise only. By default is column wise. Row wise things we will not be using NumPy. I will teach you how to do that in the upcoming sessions slowly. But these are basic math operations, very simple. You are basically doing a sum, subtract, multiply, and divide. All of you do it till here, guys. Once you're done, let me know. Next, what we're trying to do is we'll go ahead. Okay, next, if you get an error, I will tell you, Bharat. Okay. We will see comparison of the arrays. We will see comparison of multiple arrays right now. So when you do comparison of arrays, we have equal. So what this equal does, A is equal to 1, 2, 3, 4, 5. Then B is equal to 1, 2, 3, 4, and then 50. 1, 2, 3, 4, 5, 1, 2, 3, 4, 50. So this is something that we have it. Now, once we are having these things, what are we going to do next? The next things that we are going to do is we are going to compare. So how are we going to compare? Print of np dot equal. So a comma b. So if you do this, np dot equal is a function that will do a element by element comparison. Can't we sum two arrays, Samir? We can sum two arrays. That is what we did here. See, this is one array. You have summed it. You can sum two arrays also. Yes, you can do. You can try. NP dot equal. You can see A comma B. 1, 2, 3, 4, 5. 1, 2, 3, 4, 50. NP dot equal will basically do a element by element sum. Equal will work for string as well. Check Mayank once. It should work, but you can try it. Just replace one element with a string. Just put a or a B or a C and then try it. Can you do this, all of you, please, quickly? Working for string also, correct? That is how you check it. That's it. So np dot equal will basically compare the array as a individual element. Then you have something called as array equal. Np dot array underscore equal. So if you do this, it will compare the entire array. It will tell whether it is true or false. So it will tell whether it is true or false. Np dot equal and np dot array equal. So these are the two things that you will be using to compare arrays. Correct? Got it? Done, all of you? Now, okay, done. Nah? Good. Now we will work for some simple examples. I will show you a simple, not an example, but an exercise for that matter. I want you to do something. Create two numpy arrays, random numpy arrays. Create random numpy arrays of 3 cross 4 and compare element by element. You know what to do. Do this. I'll give you 2-3 minutes time. Anil, I'm really not sure about the assignments part, Anil. That you might have to check with some learning manager or someone. I'm not sure. So all of you do this. It's a very simple exercise. I want you to code this. Code it. Code it and let me know what you're getting as an output and why you're getting as an output. You should be able to tell me that. 1, 2, 3, 4 is just a key number. There is no meaning to it. 1, 2, 3, 4, you will get this set of numbers. 1, 2, 3, 5, you will get another set of numbers. If you want to get the old number back, just change the key. So every key will have a set of numbers. That's the use of this, Sri Harsha, is, see, whenever you do your sampling exercises in data science or in machine learning, what happens is you might have to generate a same set of random numbers throughout. You have to generate a same set of random numbers always. Unless you generate same set of random numbers, you will not be able to go ahead and then use few things. What are those few things? So your data will not come out correctly, or what happens is your sampling will not happen properly. So for that, you will use your random seed. Seed 1, 2, 3, 4 will give you a same set of random numbers throughout. Got it, all of you? Very good. Now, do this exercise again. I'll give you another exercise. Create two random numpy arrays of 3, 4 with same seed. So this is important. With same seed and compare the element by element. And let me know what you will get right now. Will you get a true or will you get a false? Just check and let me know. Here you got all of them false because you didn't use a seed, argument in seed. So in argument in seed, we have to give because, okay, I will answer all your questions slowly. Happy, correct. No, seed you have to put for both happy, not only for one. I will tell you. Ankur, correct answer, Ankur. Very good. Pranav, you will get all true. Satish, I will explain you. Okay, all true you will get. Why you should give argument in seed is because seed is like a key. So for 1, 2, 3, 4, this set of random numbers will come. If you make it 1, 2, 3, 5, another set of random numbers will come. So if you want to get the same set, then revert back the key. Every key will have a same set of random numbers. Random seed 1, 2, 3, 4 is required every time. Yes, since I'm asking, create two random numpy with same seed. So both of them should have same seed. So how are we going to do that? Np dot random dot seed of 1, 2, 3. A is equal to np dot random of 3, 4. Then once I do this, I will take the same thing. I will put it here 1, 2, 3. I will just change it to B. That's it. B is equal to np dot random. Now what I will do, np dot equal of a comma b. So if I do this, you will get all truths because print of a, print of b. So both of them will be same. All of you do this. This is what you're supposed to do. Comparison of arrays. Very simple. No problem at all. Clear? Slowly do it. I used seed only once before. Yes, Pulkit, used both times. That is what I wanted. So coming further in today's session, what we are going to do is I will tell you some aggregate functions and we will talk about slicing. I will tell you the concept of slicing. So slicing exercises, we will do it in the next session, right? Which is on Tuesday. So basically Tuesday is no 15th, correct? So 15th we will do that. If you mention seed once, it will give false. Correct. You have to use seed both times. Now, the entire purpose why I'm asking you to do this exercise is you have to use seed both the times so that you know. He'll check and he will tell me. He said, guys, I just got a message. So once he tells me, I will tell you. If not, then maybe you'll get an email. I will ask them to email every one of you. Don't worry. So this concept of seed is clear to all of you, right? No problem. Right? I will use some numbers, random numbers, or I'll use a big number. Okay. I have used a big number here. Now, what happens is whatever you get as a result of this aggregation, this is called as aggregate functions. Whatever you get as a result of this aggregation is called as an aggregate function. Now, first aggregate function is print of np dot sum of a. We saw this. What is this sum? When you add all of that, you'll get a np dot sum of a. This is the sum. Next, you cannot do a difference here or a subtract. Print of np dot min of a, which means it gives you the minimum value of this entire list. Similarly, you have print of np dot max of a, means the maximum number you will get. Right? Min max, this is done. Then print of np dot mean of a, which means the average number you will get it. then print of np dot median of a. This is one we will get. Print of np dot std of a means standard deviation. Whereas print of np dot mode of a doesn't exist. See here, NumPy has no mode, so this is a drawback. So you cannot find a mode using direct mode function. We'll have to use all of that. You can use negative numbers also in this. Why not? See, you can use negative, decimal, anything you can use, Raghunath. Mode is not supported here. That is one thing which I wanted to highlight. All other things are here. Just check all these things and do it. Once you are done, let me know. Next, what we are going to do is we are going to go ahead and then do something called as slicing. Okay, slicing. So slicing is a method of accessing elements of a array. Have any one of you worked with slicing before? We basically have the word or a letter that we were looking at is basically stored in a memory like this. You can see this particular memory. And then once this memory is there, you're basically seeing and then also understanding where it is stored, what it is stored. Okay. Now you can go through this and you see this has two types of indexing. One is positive and one more is negative, and also positive indexing has a 0. So positive indexing has a 0. Everything else is there. Positive is 0 to 11. Negative is -1 to 12. Then I have ls. So basically ls is my list where I'm storing this. Now, once you have this list, we have syntax. You can see the major thing of this ls, start colon end, right? So what is the start and what is the end we are looking at? Okay, now basically if we look at this start colon end, ls of start colon end, this is how basically you're accessing this list. Start is the starting place, end is the ending place, 4 to 7. So if you put 4 to 7, basically you're trying to access R, A, and N. R, A, N is something that you're trying to access, that is 4 to 7. Then we also have ls, ls open close, which is nothing but from the beginning till the end. So from the beginning till the end, as in, so you're basically checking the complete list, ls. SAN, FRAN, CISCO, San Francisco, it's a complete list that we are checking it. Then once we have this thing, we are basically checking this list and ls of 5 colon 9. So what is this ls of 5 colon 9? ls of 5 colon 9 is nothing but ls of 5 colon 9 is nothing but you basically talk from 5 go till 9, A, N, C, I, and C. So this is ls of 5 colon 9. So once you have this ls of 5 colon 9, we basically are going to check the other things as well. So how are you going to do this? So this explanation I gave you. So this is one-dimensional indexing that we were checking. Now, once you look at this one-dimensional indexing, there is also something that you need to go ahead and then look at it. So what is it that you're going to look at it right now is, you see, by using this San Francisco, we basically went ahead and then checked few examples, whatever we typed here. So we will do maybe a few more examples and then we will go ahead to the two-dimensional slicing today. Can you basically start running this Can you start running this? Very good. So now with the same example, we saw ls of colon colon, ls of 4 comma 7, 5 comma 9, minus 8, and also we saw both positive and negative indexing. What we can also do is, along with this positive and negative, we can also try for something called as a mixed indexing. Or maybe what we can do, we can try these from 7 till the end. So this will basically print from 7 till the end. So 7 is C, end is the end, last. So 7 till the end. So basically you can combine a single index with the ending thing, right? So let me give you an example. 7 colon 12 will print same Cisco. Then once you have this 7 colon 12, you also have ls of 7 colon. So the same thing that will also print Cisco, right? Then ls of, can you give me a equivalent of negative indexing for 7? Can someone give me an equivalent of negative indexing? What would that be? The equivalent of negative indexing, guys? Exactly, minus 5. So basically you can use a minus 5 colon, you will get CISCO. So basically the Cisco would come. You can do positive indexing, you can do negative indexing, right? So you can do mixed. So mixed as in you can use something like ls of 5 colon, sorry, minus 5 colon 12. So sorry, not 122, it's 12. So if you basically use this, you can see here also you're getting, right? All of you agree with me? What is the answer for all this? Isn't it the same? Do you think it's the same? All four? Same? Yeah. So the logic here, or maybe what I'm trying to convey here is very simple. You have many ways to do the same thing in Python, correct? So that is the logic. So irrespective of you use positive or negative, whatever, as I explained you in the last discussion, you can see direction of axis is always from left to right, irrespective of positive or irrespective of negative. Anything. Positive, negative, anything, it goes from left to right only. Nothing else apart from it. Okay. Are we good here? No problem. Yeah, I will tell you to do reverse slicing. I will tell you. Okay. U1 is nothing but the unitype encoding. U1 is nothing but the unitype encoding, where you're basically going ahead and then checking the Unicode encoding of the things. Unicode encoding, U1. That is the encoding thing, nothing else apart from that. Okay. Now I will tell you a very important concept. Listen to this carefully. ls of colon, what it will print? ls of empty colon empty, what it will print? It will print everything. So which means starting till the ending. All of you, we have discussed something called as a range, right? Do you remember the a range function, guys? All of you, a range. In a range, we had start, stop, and step. Do you remember? Yes. Similarly, here also you have a start, stop, and then a step function. So this is a start, this is a stop, and this is a step function. Start, stop, step function. So these are the things that we have. Now, if you put this, it will print the entire array. So both ls of this ls of this prints the same thing. See, this is start and stop. Here, start, stop, and step. We are putting empty, which means default steps. Can you do this? Understand this? This is a little important. So that's why I'm taking a little while. Can you do this? Both of you both should get the same thing. It's default. Now, ls of colon 1. So if you give colon 1, it's a single step function. So single step function, it is basically giving you San Francisco like this. Extra colon talks for the steps, Sarah. So ls of colon 1. So this is something that we have. Now similarly, see this. ls of colon 2, which means you're taking 2 steps at a time. Got it? Colon 2, you're taking 2 steps at a time. This is still NumPy only. In Pandas also similar slicing will come, Anish. Currently we are using NumPy, but in Pandas also similar slicing would be there. So this is one thing that I wanted to tell you. So similarly, you can do ls of colon 3, which is sfns, sfns. So you are getting 3, 1, 3, 6, 9 like that. Difference between colon 1 and colon 2, Sajni, is simple. Colon 2, colon 1, when you read San Francisco, it jumps by 1 step. When you take colon 2, it jumps by 2 steps. S, N, R, N, I, C, like that. The last number in the colon is the step. If I take 1 character. If I take 2 character. Single colon, both are same. Now the question I'm asking you is this a 1D or a 2D? This is basically 2D. So how do we convert it into a 2D now? How do we do that? What are the functions that we saw to convert it into 2D? There were 2 functions that we saw, na? No, there were 2 functions. I'm asking about the functions. Resize, reshape. This also we saw, na, Prem? So how do we know it is 1D, guys? There was one function that we discussed in the beginning. Reshape and resize, 2 functions are there. Which one will change the original array? Reshape or resize? Which one will change the original array, guys? Reshape or resize? Resize. So let's go with resize. If I resize it, very good. What you're trying to tell is good. If I resize it, to what dimension I can change in 2D? There are 16 elements. What dimension I can change? Samir says 4 cross 4, 2 cross 8. 4 cross 4, 2 cross 8, 4 cross 1, 1 cross 4, 8 cross 1, and 4 cross 2. So these many I can do, correct? 1 cross 16 also I can do. Yes, 16 cross 1 also I can do. Correct, Anil, you're right. BK right. So these are all combinations that I have. I can do these many combinations. What I will do is, I will basically take the middle one. So the middle combination of all of them is 4 cross 2. So 4 cross 2 is basically ideal. It's a square matrix. For our learning purpose, it will be simple. So what I will do is, next step, I will basically convert this thing into a 4 cross 2. So how am I going to do that? ls dot resize of 4 comma 4. Then I will print ls. Can you do this? This, what it does is, it changes the original array to the dimension that I've given, and then it will basically print it. So this is what we are trying to do. 4 cross 2 or 4 cross 4. It is 4 cross 4. Chetan. 4 cross 2 is 8 elements. 4 cross 4 is 16 elements. Since we have 16, I'm doing it into a 4 cross 4. Can all of you do this, please? And let me know once done. 2 people are done. All of you do it. So this is a 4 cross 4 that we are looking at. 4 cross 4. So once you have this 4 cross 4, what we're trying to do right now is we will go ahead and then see how we are going to access this in 2D. So in 2D, we have a similar concept. I will tell you this. You might not know this. This is something that we are going to discuss now. Understand this concept, very simple. I will just simplify that as much as possible. Just understand this 2D slicing, and then we can go ahead and then do it. So what is it that you had? A matrix. You can see you had A, right? So this is how this two-dimensional matrix looks. Now, once you have this two-dimensional matrix like this, what exactly we are going to do is we will start doing an indexing for this. How this will be stored is like this. So you can see we have ABCD and we also have MNOP like this. So this will be inside this memory. I'll help you understand this very slowly. Be a little patient and then understand it. Okay. For this, we will have positive indexing, which is 0, 1, 2, 3, 0, 1, 2, 3. So this is positive indexing for row and column. So this is row indexing and this is column indexing. Clear? This is row indexing and this is column indexing. You're clear on this? Yes? No? Very good. Now, similarly, whatever you have seen, you also have negative indexing, which is -1, -2, -3, -4, -1, -2, -3, -4. Done? 0, 1, 2, 3, 0, 1, 2, 3, -1, -2, -3, -4, -1, -2, -3, -4. So this is something that we have it here. So we are going to access this same way. 2 variable, 1 for row and 1 for column. No, this is not variable, Ankur. This is basically indexing. You are basically indexing it. You have positive indexing and also you have negative indexing. Right? So BK Raghunath, no, not yet. So access is different. The direction of access is different. The direction of access that I'm trying to tell you is a little different. The direction of access, when you see, it is always from left to right here. This is your direction of access. Got it? This is direction. I'm not talking how you do indexing. I'm not talking how you do slicing, but the direction. So for 1D also it was from left to right. For columns it is like this. For rows it is basically like this. So dir of access. Got it? dir of access is this. Column, row, column, all this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So this concept is clear, how the data comes, how we are putting the indexes, and also how we are accessing that. Clear to you? No problem. Without any issues, guys. Clear, na? Very good. Now, once we have done this, I will tell you the syntax. The syntax is very simple. This, assume you are storing it in ls. We all store it in ls also, na? So ls of what you're supposed to do is, this is your bracket. Here you give a comma. If you give a comma here, what happens? The left part of this comma corresponds to your row access. The right part of this comma corresponding to your column access. This is row access, this is column access. Now you can put a colon here. This is one colon, this is second colon. So this marks the start of your row. This marks the end of your row. This marks the start of your column. This marks the end of the column. So start, end of your rows and also columns. ls means list. No, it's a variable basically. What we are trying to store is, we are basically trying to store this variable. We are storing this variable in ls. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. We are storing these variables in ls. No questions? Good. Now, what we will do, if you want to access from beginning till the end, if you want to access from the beginning till the end, you can see ls of colon, comma, colon. So if you do this, it will take all the rows and all the columns. Priyanka, we were just doing two-dimensional indexing, Priyanka. So you can see we also have one-dimensional indexing. This is, I'm just repeating it for Priyanka. Maybe 15 seconds. So we also one-dimensional indexing in our previous sessions, right? Right? Then once you have this one-dimensional indexing, what we are trying to do is, we are basically going ahead and then checking the two-dimensional indexing. So two-dimensional indexing, we have a matrix kind of a structure, which have positive indexing, negative indexing for rows and columns. Direction of access is from left to right and top to bottom. Syntax, as I told you, it is basically a colon, comma, colon. The left side of the comma is the row. The right side of the comma is a column. Right? So left side of the comma is a row. Right side of the comma is a column. Now, once you have that row and also column, what we are supposed to do is, you can do ls of colon, comma, colon. So once you have this ls of colon, comma, colon, what we will get is, we will get it from the beginning till the end. So let us go ahead and then try one of this and then let us see how it works. Or maybe I will tell you a few logics and then we can go ahead and then do it. Now, once you have done this, I will take an example of, let us say, I want to access A. So if I want to access A in specific, what I should do? 0 to 1, 0 to 1. So to access A, I should type ls of 0 to 1, comma, 0 to 1. 0 to 1 row, 0 to 1 column. So this is A. If I were to access this complete column, this complete row. So what I'm going to do, or maybe I'll use a different color just to be a little bit more clear. If I want to access this, or if I want to access this, what I'm going to do, BFNJ can be got from 1 to 2 row. So LS of 1 to 2 row, first row to second row, all the columns. Sorry, my bad. Sorry, this is not the right one. For BFNJ, you're taking the column now. So which means all the rows 1 colon 2 column. 1 colon 2 column. So first to second column, all the rows. Similarly, EFGH, you can get it by using all the, first to second row, 1 colon 2 row, and then all the columns. So this is how you will be able to get it. So this is our rows and also columns. Got it? This is our rows and this is our columns. So this is how you get it. Priyanka, this is the row and column. As I told you, this is the syntax. So LS of start to end, which row you want? I want all the rows, means empty. Which columns you want? I want column from 1 to 2, means BFNJ. So this one. Now I will just access a subset. Let's say I want to have FG and then JK. I want to get a subset. How do I get this subset? This subset, you can get it by using LS of from which row to from which column? 1 to 3, correct? 1, 2, 3 row. 1 to 3 column, 1 to 3 row. So basically 1 colon 3. So if you put 1 colon 3 and 1 colon 3, so this is how you will be able to get it. For accessing column also, why we didn't write like that, row column 1 colon 2? No, if you see here, empty means all the rows. So you need all the rows now. BFNJ, B is first row, F is second row, J is in third row, N is in fourth row. So all the rows of second column, that is BFNJ. Next, 1 colon 2 comma empty. So 1 colon 2 is nothing but, you can see 1 colon 2 is nothing but the first to second row. 1 colon 2 is first to second row, EFGH, colon, which means all the, any questions to anyone? Understood? So we discussed about how do we access a row, how do we access a column, and also how do we access a subset. So is there anything that you need to know in 2D? You will access individual elements, you will access subsets, you will access rows and columns. That's all. Right? Where will we apply this in real words? Yeah, see, whenever you have some data sets, so let's say you have some huge data set, to access few rows, few columns, see, variable selection is where you will use it in your machine learning. Variables you need to select. Now, here you're putting colon, which means select all the rows. You will select all the rows, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P. All rows will come. Then in column, what you are doing? 1 colon 2, which means 1 colon 2 is this much. 1 colon 2 column is this much. So you're selecting BFNJ. That's it. So this is for BFNJ. If it is confusing, I will tell you one thing. See here. whatever you have written, A, this code is to access A. This code is to access BFNJ. This code is to access this. This code is to access the subset. These are 4 different codes that I've written. Can I access column index, open bracket, close my column index 3 together? I think you can, yeah. Got it? Two colon 4 comma 0 colon 2 for IJMN. Yeah, IJMN is 2 colon 4 you can use, or you can use 2 colon empty also. 0 colon 2. Yeah, correct, Bharat. We will try that. IJMN I will show you. All I want to understand now is the concept clear to you? Concept is important. Code we will write it now. We will do the same thing. We will do IJMN also. All of you got the concept properly without any problems, without any issues. No issues to anyone with respect to problem. No issues to anyone with respect to the concept. Nice. Now, since the concept is clear to all of us, what we will do is we will go ahead and then just check some examples. I'm coming back to the code. As we saw, ls of colon comma colon. So what this will print from beginning till the end, from beginning till the end. What this will print, guys? It prints all. It prints everything. Correct. Now, the first example that we saw was A. So how do I access A? ls of 0 colon 1 comma 0 0 colon 1. This is A. Can you try accessing A here? ls of 0 colon 1 comma 0 colon 1. This is A. After resizing, can we check the direction? Yes, Sarah, we can check. What is D type less than U1? I told you that is a Unicode encoding. Correct. You can use 0, 0, but just try, you may get an error. You may get an error. ls of 0 comma 0. Yeah, you can get it, but not like an array. It's just a word. You can get it. Yes, Aditya, today is Independence Day. Happy Independence Day to everyone. Do you want independence from class, Aditya? Hmm? Okay, anyway, no problem. So yeah, maybe I'll give, we will all take 15 minutes back and then we will close it 15 minutes early and then we will do it. No worries. Now, what we are going to do right now is, see, I told you ls of 0 colon 1 comma 0 colon 1. So this is something that we have. Now, we are going to do the next one, which was BFNJ. ls of, what is BFNJ? BFNJ, as we thought, is comma. In BFNJ, you need to access all rows. All rows, and then from which column to which column? 1.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. Through this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplotlib, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What is the file extension used for Python modules? Your options are .py, option B, .mode, option C, .pyt, and option D, .mdl. I hope by now you have commented your answers in the comment section. Now let's move back to our session.
2, 2. See, BFNJ, right? Next, EFGH we saw, correct? EFGH is also similar. LS of 1 colon 2, comma, this. Arun, 1 colon 2 means first row till second row, first column till second column. That's the indexing. See, EFGH we got. Then we had FGKJ. FGKJ, right? So was that FGKJ? FGJK. Yeah, this is FGJK. So this one also we understood how to do that. LS of 1 colon 3, comma 1 colon 3. FGJK. We got this. We also wanted to access IJM. IJMN. See IJMN properly. IJ, you need to get the last two rows 0, 1, 2, and 3. Means 2 to end rows, first and second column means 0 to 2 column, 2 to end, 0 to 2, 2 to end and 0 to 2. LS of 2 to end, comma 0 to 2. This is what you will get for IJMN. Clear? Got it, all of you? All this? Now, what I want you to do is, I will give you a small exercise. I will give you 2 minutes time. Use negative indexing and get all these results. A, BFNJ, EFGH, FGKJ, IJMN. All of them use negative indexes and get it. Take 2 minutes, use negative index and get it, please. -2 colon 0 -2 LS2 -2 4. Okay. No problem, Priyanka. Take care of yourself. Priyanka, you can probably drop and take rest. Anyway, you'll get the recording. Okay. Now, let me do the same thing for negative indexing as well. See here, LS of, as we all saw, we have -4 colon -3, comma -4 colon -3. Same answer in negative indexing. For this one, LS of colon, what is 1 here? 1 is -4. What is 2 here? It is -2. Okay. 1, let me think. 1 is basically -3. Oh, sorry, my bad. BFNJ, I'm taking all rows. Oh, I have to give a comma. Yeah, BFNJ. Got it. This is negative for BFNJ. Now this one, LS of -3 colon -2, comma, bracket. Oh, sorry. I have to do it in another line. If I put it here, you get EFGH. Now 1313 is there. You can see LS of 13. What is 1? 1 is -4. What is 3? 1, 2, 3, which is nothing but FG. I'm not seeing the number. I'm just doing it all by myself. 0, 1, 2, 3 is nothing but 4. Means, sorry, 1 is -4 comma -1. Let's try. If we are not getting it, we'll retype it. Don't worry. -1 is there now. What I'm getting? FJ. So I need to remove one row and one column. So I need to make it -3 to -3. That's it. This is FG. IJ, this is basically LS of 2. what is the second row? 0, 1, 2, which is -2. 0, 1, 2, 3, which is -2. So this is -2 colon. What is 0 colon 2? 0 colon 2 is nothing but -4 to -2. I'll put it and let's see. IJKL it is coming. So I need to put -2 till the end, all rows, correct? Let me think a little bit. We'll not see that, we'll do it slowly. This is for rows 0, 1, 2, 3, which means 2 to 3 all rows. Oh, I need to put a comma. Sorry, my bad. I have missed the comma. Numbers are right, I had missed the comma. Yes, yes, Ayush, you're right. Sarah, you're right. Shreya, you're right. I just missed a comma. So if you don't do it, it will become start, stop, step. You saw, start, stop, step it will become. So output you will not get properly. Clear, guys? All of you only did this, negative indexing and everything. I just read it after you did. By using positive indexing, we get the exact element. Then why we use negative indexing? See, Parth, the answer to your question is very simple. Python supports two types of indexing, positive indexing and also negative indexing. It is the discretion of the user. It is his wish, whatever he wants to use. You can use positive, you can use negative, you can use mixed indexing. But let me tell you something. In Pandas, you have column names. We will also see how to use column names and row number as indexes rather than using the 0 and 1, 2. Since Parth asked this question, let us say you have a big data set where you have some 100 columns and some 1 lakh rows. So how do you extract, what do you know? How do you extract the 78th and 79th column? Or maybe you have a telecom data set where you have 140 rows. In that, you want to extract a column called mobile number. How do you know which column is mobile number? How would you know which column is mobile number, by the way? How would you know which column is mobile number? By column name, correct. You cannot use the column number at that time. You need to know the column name. So in Pandas, we will do slicing using column names. Now, next thing that we are doing is something called as array manipulation. So array manipulation, we are doing slicing we did. We are going to combine, we are going to stack and then do all of that sort. We are going to combine, we are going to stack, and then we are all going to do all those things. Getting the point? Stacking, slicing, all of that we will see. Now, the first thing is concatenation. So how are we going to do concatenation? So you initially create a array, np dot array of 1, 2, 3, 4. Okay, so you have np dot array of 1, 2, 3, 4. Then you have b is equal to np dot array of 10, 20, 30, 40. 10, 20, 30, 40. So you have two arrays. What we will do, print of a, print of b. So these two things you will do, print of a and print of b. Clear, guys, without any problem here till here. Print of a and print of b. Clear? All of you do it till here. I'll give you a minute. Now, these two are the two arrays that you saw. How are you going to combine them? Any idea how are you going to combine them? A plus b. Okay, let's try a plus b. Print of a plus b. So you're getting an addition. I want to join them, not combine as an add. How can you join them? You can join them by two ways, one below the other and one after the other. Correct? We can do print of a comma b. Correct. You can do a comma b, but there is no join here, Nilesh. You're printing one after the other. See, this is not joined. Correct, Nilesh? Agree? Praneeth added it. Good, but you're not joining it. So now what we will do is we will learn simple things to join arrays. Okay, simple things to join the arrays we will see, right? Now, how am I going to join them? So there is something called as a concatenation function, which will join the arrays in one format. I will tell you how it joins. Print a comma b. Now, print of np dot concatenate. Okay, concatenate of, you have a comma b. If you do concatenate of a comma b, it is throwing an error. I think it's a spelling mistake. Concatenate e. Yeah, see here. When you do concatenate, it basically joins it. It doesn't print together, it joins and then prints it. Clear? One after the other. Good. So this is np dot concatenate. Now, once you are done with this np dot concatenate, what we are going to do next is I am going to introduce you to something called as axis. So we are doing a one-dimensional concatenation. Understand this carefully. np dot concatenate of, you're supposed to do a comma b comma axis is equal to 0. So if you do axis is equal to 0, it joins one after the other. It takes one after the other. We used single bracket for a comma b. See, concatenate is a function. You are passing single argument inside concatenate, which is a comma b. Single argument a comma b is concatenate. Now, this one is np dot concat. Got it, na? Good, Bharat. So this is axis is equal to 0, join one after the other. So if you basically use axis is equal to 1, since it's a 1D, you'll get an error. Axis 1 out of bound. So this is not an error, but this is nothing but 1D doesn't support it. Not supported in 1D. 2D we will see later. Right now, this is not supported in 1D. What I want you to do is understand the concept of concatenation. Concatenation is nothing but joining the data, joining your numpy arrays. np dot array 1 2 3 4, and then you have 10 20 30 40. Object is not subscriptable. Import numpy as np. So let me take your code only and then I will put it and then we will see Nadim. Import numpy as np. You have done this. Okay. C is equal to np dot array. Very good. D is equal to np dot array. Very good. np dot concatenate c comma d. What you are trying to do is same bracket Nadim. See here, bracket missing. Concatenate, you are using c comma d, which is two arguments. Here I am putting c comma d as a single argument. What you do now? Put a bracket here, put a bracket here. Then you will get it. There's some type error. np dot array. Here also one bracket missing. Here also one bracket missing. Very good. Now, next what I'm going to do is I'm going to teach you something called as a vertical stack. So what do you mean by vertical stack? np.vstack of A comma B. So np dot v stack of A comma B means one below the other. See, we were not able to do it one below the other in concatenation for 1D, but using a vertical stack, you can do this one below the other like this. This is V stack. Similar to V stack, we have horizontal stack. So how am I going to do np dot h stack of A comma B? When you do this h stack, you will get it like this. V stack is vertical, h stack is horizontal. Are we good? Are we clear, guys? No problem. V stack and h stack. The third one, we have a column stack. So how do we do a column stack? np dot column underscore stack of A comma B. COLUMN. Yeah. COLUMN. Yeah. See, column stack. So row stack means row wise, one below the other. I mean, this is vertical stack means one below the other. Horizontal stack means one after the other. Column stack means convert your data into columns 1, 2, 3, 4 into column, 10, 20, 30, 40 into column, and then stack it one after the other. So this is how basically we are going to do it. If numbers are not same, then it will not work. No difference between h stack and concatenate. There is no difference between h stack and concatenate, Mayank, correct? As we all discussed in slicing itself, there are many ways to do the same thing in Python, as I told you. Now, the last topic that we have in NumPy is splits. I will explain that splits and then we will go. So h split is horizontal split. How am I going to do it? ls is equal to, I'm creating a random part. Understand this. Random dot random of 6, 4. ls unexpected indent. Okay, fine. And then I print off my ls. So this is a 6 by 4 random number matrix. Now what I'm going to do, I am going to do ls dot h split of what? ls. Make ls into two pieces horizontally. So cut horizontally. So middle there will be a cut. So if you do this, you can see HSPLIT, spelling mistake. HSPLIT. What's the problem here? HSPLIT. Oh, sorry, this is np.hsplit. My bad. See here. So there is a cut in the middle. So which means two columns. The first two columns become one array. The last two columns become another array. Got it? Horizontally it is splitting. Clear, guys? No problem. Horizontal split. Very good. Same thing, you can also do a V split, which is vertical split. np dot V split of ls comma 2. So if you do this, np dot V split. Okay, let me check what is there in ls first. ls is proper. So we are going to do np dot V split of ls comma 2. split. It's just a spell mistake. So you can see same thing here. The first 3 rows becomes one array. The last 3 rows becomes the second array. First 3 rows becomes one array. The last 3 rows becomes the second part of the array. Clear to all of us still here without any problems? Customize the split as in C, you have to split it into equal splits. So there's nothing like good or bad. You can split it into equal split. Just ensure that the number of rows and columns are equal. But if you want to do unequal split, it is not possible in H split and V split. For that, you need to use Pandas. We will see how to do that as well in Pandas. Okay, good. So these are some small things with respect to NumPy that I had to discuss. And multiple assignment, I told you, na? A comma B comma C is equal to 1 comma 2 comma 3 if you do, and then if you do print of A, what you will get? Print of A, print of B, print of C, you will get 1, 2, 3. So this is multiple assignment. So this is what I intended to cover today. I will do one thing. I will basically give you this code, whatever I've written till now. Take this, and also in NumPy, I'll give you a link. Okay, I'll give you a link where you will be able to get W3 resources NumPy exercise. So you'll get a lot of NumPy exercises here. Python exercises, NumPy. Yeah. So use this link. So there are a lot of exercises, 200, 100. So many exercises are there. These exercises also come with a basic explanation and also some code. So this also has some code. See, exercises with solutions. Use this link, practice well. I'm giving you this link as well. Are we okay? Splits are used to split exactly. No, you can split it into 2, 3, 4, how many ever you want, Prem, but the column should be same or the row should be same. See, you get the questions and also you will get this. See how to find the NumPy version. So we know how to find. So this is how the code explanation, everything is there. So these things you can practice. I want all of you to do it. This is something that you need to understand. Now I'll just put this also here, exercise link, and then I'll give you the code. That has everything. Only I gave you the NumPy. Just check the Google. You'll get the same link for OOPS as well. When you're using Python, NumPy is basically used for numerical computation. Pandas is used for data manipulation. Matplotlib for graphs. sklearn for machine learning. So these are the major libraries that we were using for NumPy, Pandas, Matplotlib, and sklearn and all of that. Now, once we have completed this, NumPy, Pandas, Matplotlib, sklearn, all these details, we went into NumPy in detail, which is numeric computation. So numeric computation as in we are computing things numerically. So it's a numeric computation library. Then the second thing we have is basically data manipulation. For doing data manipulation, we use Pandas. Right? So for doing data manipulation, we use Pandas. So why do we need Pandas as I spoke? So you can create some data sets, convert those data sets, and then do all sort of things. So that's the reason why we need Pandas. So let us go ahead and then get started with Pandas. What are all the things that are there in Pandas and what are all the things that we will do? We will just go ahead and then see and then let us do it. So do all of you have opened your Jupyter notebooks, guys? All of you have opened your Jupyter notebooks. Now, once this Jupyter notebooks are done, the basic things that we were discussing previously, we will basically start from that and then we will go ahead and then see it. So what are they? So let me, Pandas is a library used for data manipulation. So this is something that we use Pandas for. The first thing, pip install Pandas. So once you go ahead and then do this pip install Pandas, what will happen? The Pandas library would open and then that will run. So the main reason why you need to go ahead and then do this import is whenever you do this import, your libraries, whatever you install in your hard disk drive, that comes into RAM, correct? So that's the main reason why you will need to do that import. Now, once you complete and then do that import pandas as PD, the next thing that you're supposed to do, whatever you're trying to do here, import pandas as PD, and the next thing, if you go ahead and then check dir of np, it will basically show you all the functions that are there in pandas. Can you kindly do that, please, all of you? Oh, dir of pd you're supposed to. Sorry, my bad. Same thing. You'll get all the functions that are there in pandas. For numpy, you should take np. For pandas, you can take pd. And then you just do this. Whatever it is, dir of pd you do. Then next thing, you're supposed to check len of dir of pd. So 141. So all of you know our numbers differ. We saw it in the previous session. Why? Why our numbers are differing? Because of the version. Yes, if you can check this version, pd dot underscore underscore version 1.4.2. So this is the reason why it is changing. Got it, all of you? Why it is coming like this? I will show you. The line after pip install is import pandas as pd. All of you do it slowly. So we can import both libraries NP and pandas at the same time. Varun, yes, you should do that. In every data analysis or data science program, you will have to do it. You will have to import them. So we'll basically go ahead and then check. Now this is pd dot underscore underscore version. So now if you can just check, we have pandas series. So what is this pandas series? A is equal to, I will create a series 10, 20, 30. Now, once we check this pandas series, A is equal to 20, 30, 10, 20, 30. So in this series, what exactly happens is, you are taking a list. All of you have known that we basically took a list and converted it into a NumPy array, correct? We took a list and converted it into a NumPy array. Now, what we are trying to do is we basically go ahead and then create a pandas series using this. Okay, we basically go ahead and then create a pandas series using this. So how am I going to create a pandas series using this? This one, yes, I will just create it. S is equal to pd dot series with a S capital. You have to do, and then print of S. So this is what you're supposed to do. 0, 1, 2, 10, 20, 30. This import we do not for oops. No, import is not required for oops. Not required, not necessary. Panda series is a list type. No, I will tell you after what is Panda series, but now just type this and then let me know once you are done. I will tell you what is this Panda series in a while. Done? Very good. Just like how you had this NumPy array, right? So we had a NumPy array. NumPy array was a data structure. NumPy array was a data structure. Now, what exactly we are trying to do is we are going ahead and then trying to create a similar data structure in pandas. So that data structure, which is similar to a NumPy array, here we call it as a series. So, I mean, this is one of the data structure. Now, why I need to create that series? All these things we will just go ahead and then see why I need to create and why I need to do all this. All of that we will see. Now, we create a series 10, 20, 30 pd.series of A. Once I create pd.series of A list I'm converting it into a series. What is this 0, 1, 2? Can someone want to take a guess? Anyone wants to take a guess, guys? Yes. Basically, 0, 1, 2 is a indexing of 10, 20, and 30. So basically, this gives me a index and also a value. Right? So this basically gives me an index and also a value. Now, once we have this index and also value, import pandas as pd. pd A is equal to 10, 20, 30, 40. S is equal to pd.series of a pd. Once this panda series is created, what we are trying to do next is we will go ahead and then see one important thing here. Pulkit, check the code. You will never get an error if the code is same. Check the code once. Now, what I'm trying to tell you is, see, the first thing, when you go ahead and then create anything, I have already told you Python has zero based indexing or positive indexing or negative indexing. So that one I have told you. Now, once it has a positive indexing or negative indexing, next thing what we are trying to do is, the advantage of pandas is, along with the Python based indexing, we will also have an option to give a custom indexing. I will tell you what is this custom indexing now. Okay. Pandas.series of A. Guys, whoever is getting error, I told you yes should be capital. You are making spelling mistakes here. So now I'm just trying to add an index to it. What I will do, index is equal to, we are giving A. So when I do this, my index changes to ABC. You can give a custom index in Python data structures. You should understand that. You can give a custom index in Python data structures. All of you do this and let me know once done, please. Now, once you have done this, let us go ahead. The second thing that we have here is, now what I will do is I will create a data frame. Just look at this. You can import pandas as pd, but not required every time. So you can do dictionary is equal to a, or maybe dictionary is equal to a, the value is 10, comma b, the value is 20, c, the value is 30. Then what we are trying to do, we are trying to do yes is equal to pd dot series of d, then print of d. So here I'm not giving any custom index, I'm just taking a dictionary. When you take a dictionary like this, you can see here, print of s, you will get a similar series. Same thing, but can be done in multiple times. Now, the request that I have, we are going ahead and then seeing here is, see, you had a dictionary and created. In a dictionary, all your keys will become index, values will remain values. Now, the third thing is data frames. So, data frames, the series, whatever you have seen, this is a one dimension. So, series is a one dimension. Data frames, what you will see are 2-dimension. So data frames will basically be the 2-dimension things, right? The 2-dimension things is nothing but in the 2-dimension. Getting this concept? 2-dimension as in it will have rows and columns. This is not having rows. I mean, this is not having columns. This is having only rows, right? So data frames are 2-dimension. So what we will do, import pandas as, you can replace s with any alphabet that you want. Yes, that's just a variable. Import pandas as pd I have done. I'm just doing, Sri Harsha, see this. Yeah. I'm just doing df is equal to pd dot data frame. So in this data frame, D and F are capital. Check this properly. D and F are capital. Print of DF. So if you do this, you get an empty data frame like this. Create this empty data frame and let me know. I have some more questions. What is the shortcut key to run the code in Jupyter? Control Enter. 2-dimensional pandas series are called data frames. No, data frames are separate, series are separate, Bharat. They're not the same. Right? So getting error again, restart it. I told you. Sriram, and I have a basic doubt. Could you please explain the difference between square bracket and also flower bracket? See, square bracket is nothing but you use it to access your data. Okay. You're supposed to use it to access the data. Right? So that is something. And when we go ahead and then use a flower bracket is only used to get our dictionaries in place. So when you create a list, you use a square bracket. When you basically want to access the data in slicing and everywhere, you will use square brackets. Not every time. Flower brackets are only used for dictionaries. That's it. Indentation error, unexpected indent. I think the code what you've written is wrong. So that is one thing. Raghunath, you can see 215. Give extra space in index, I think. Yeah. Bracket means set, dictionary, list. Yes. Yeah. So this is what we are trying to do. So this is something that we did. Now, let me tell you something. In our data science journey, 95% of the times we will be using data frames. 90% of the times we will be using data frames, and that is what matters. What you're learning now, this data frame is being used around 90% of the times in our data science journey. That is something that we are talking about. Now, once we have done this, 2 dimensions, we are done. Now, once we have done this, the next thing that we are going to do, right? So data frames, 2 dimension, we did it. Pandas, SPD, all these things we saw. Now, we will go ahead and then create a very simple data frame. Import pandas as PD. This is just for practice. I will take ls of 10, 20, 30, 40, 50. Now, once we have this, df is equal to pd dot data frame. pd dot data frame of ls. What we are trying to do? Print of df. Then print type of df. Can you do this, all of you? One thing that you should see now is Can I give my custom row index and column index? Custom row index and column index, can I give? In NumPy, in series, I was able to change it, right? Similarly, I should also be able to change the same thing in this data frame, correct? Yes, we should be able to do that. There should not be any problem to change that the custom index. Yes. Now, how are we going to change it is a question. Take the same code, copy paste it here. See, this is where we would have to add it. When you create a LS, same index, put the same index here, and then you have 5. So here you have 0, 1, 2, 3, 4. What we will do here is, I will give some big numbers, 23, 34, 45, 56, 67. Basically 3 digits. This is index. Then we have columns. Columns is equal to new col. Columns is equal to new col. See here. Now I changed my index and also I changed my column name. Understood this problem? I mean, understood this clearly without any problem, guys? Here, what I'm trying to do, Shirley, is I have taken my data frame df, and what I'm trying to do, I am basically going ahead and then I'm basically creating something right now, nothing else apart from that. Created a very simple data frame. Once we created that simple data frame, Shirley, what I did it is I renamed the index and also column. So basically, Pandas support Python-based indexing and also user-defined indexing. Index is equal to 23, 34, 45, 56, 67. Columns is equal to new col. That's it. Understood? Shirley, Sajani. Column name is default is Damini. It is default as 0, but since we all are changed now, it's not 0 anymore. Can we change it as we do with index? What? If you're talking about column name, we can do. I've changed it now. See, same like that. I've changed it here. Column, we have changed it, right? So previously it was 0. Then we changed it to new column. For arranging big data, we will use this. Not just big data, but see what exactly happens here is whenever you have certain data, when you're using it, you will have to basically rename certain columns and do certain exercises. For all of that, you will go ahead and then use it without any issues. So this is very, very important. Why it is important? Because unless you know how to rename your rows and columns and all of that, it will not be feasible. So we will have to know how we are going to change all of that. So that is required. So that is something which we were talking about right now. Without any problems, are we okay? Can we have an example with multiple rows and multiple columns? Yes, Mayank, we will look at all of them. Since we have started now, I've just taken a small example. He's mentioning index is equal to column is equal to compulsory. Yes, Nilesh. Can I add more than one column here? Yes, you can add it. Varun. LS is an array where we use PD data frame. It is considering them as 5 rows and 1 column. Yes. Yes, see, all these things we have seen. df.shape. See, 5 rows, 1 column. Have we discussed the shape, size, and everything, guys? In array manipulation, 5 rows, 1 column. Yes. Why it is 5 rows and y column? Should that be 5 column and 1 row? No, this is 5 rows, 1 column. 5 rows, 1 column. You're passing it as row, not as column. You're passing it as row. Now, what we are going to do is Once you have done this, we will basically go ahead and then check out the name of df.rows. If you do df.rows, you will not get anything. You cannot list the row, but you can list the column index, columns, new call. Why? Because usually you will not be changing the row numbers, you will change only the column numbers. So df.columns will give you the list of columns. Can you do this? The df.columns will give you the list of columns. So since there is only one column, it has given you one column. That's all. Now see, df.columns will basically list this. Now what you can do, if you can just pass a list of columns, my call, okay, and then my call, change it, and then print of df. Now new call has become my call. You have changed this into my call. Can you do this, guys, all of you, quickly, and let me know? What if there were multiple columns? Here you have to put the multiple column name, call 2, call 3, like this. You have to pass a list, Ankita. We will see that slowly. This is for practice purpose, I'm telling you. That's it. Are we good till here? No problems, no worries. Once you understood how to do this, we will go ahead and then check two different types of data, and then we will see how we are creating it. Okay. D is equal to, check this. I'm creating a data frame from dictionary. Just see this, create this. So basically name colon, I'm creating n1 comma n2 comma n3 comma n4. This is something, comma age colon 23, 34, 45, 56. So these are some things that.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. So this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplotlib, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What is the term used to describe a blueprint for creating objects in Python? Your options are A, prototypes, B, instances, option C, templates, and lastly, option D, structures. You can comment your answers below in the comment section. Now let's get back to our session.
We create name and also age. Now, once we create this name and age, what is this basically? You created a dictionary. Now I'm creating df1 is equal to pd dot data frame, pd dot data frame of d comma index is equal to q w e r. So just created q w e r as an index. Now go ahead and then create another data frame, df1 and df2. Now what we do is just print of df1 print of df2. Can you print these two things and let me know once it is done, please, guys? Oh, name, age. Don't give index again, Rutvik. You should not give index again. Type the same code. See, default is df1 is this, df2 is this, right? So df1, df2. Then you have joined it one after other, which means default join is one below the other, which is column wise. So axis is equal to 0 also does the same thing. Axis is equal to 0 is also nothing but you're basically going ahead and then seeing your bonsai, I mean your basic uh, df1 and df2 joining one below the other. Very good. Now what we are going to do is, once we have this, right? Sir, do indexing by taking multiple rows, multiple column ones like matrix? It should. Multiple rows, multiple ones like matrix, it should. Yeah, we will cover that, Raghunath. Slowly I'm teaching you, na? I'm doing that. Multiple rows, multiple columns. See, we had only one column here. We added two columns here, name and age. We will go to multiple rows, multiple columns also. Okay. Now change to axis is equal to 1. Whatever joined one below the other, now will join one after the other. Now, what we will do is, we have basically went ahead and then did this. Not an issue. Now, next aspect of this, whatever we are going to see, will be once you have done this, you can change the index name. I mean, just do one thing. Just change the row index little bit. Just change two indexes and then see what you will get if you concatenate it. PD is not defined. Why it came like that? Because you haven't imported pandas as PD. That's why. Now, what I will do is I will take the same thing, same code right now, paste it here, change this index. Instead of QW, I'll change it to AB. Instead of let it be AB. That's it. Now N1 and N2, I did it. Now I'll just concatenate with axis 0 and axis 1. So I don't need to print it also. Okay, let me print it, no problem. This is basically your axis is equal to 0. In axis 0, it will print because every row index is unique. Same thing, if you print it with axis 1, see what happens. Wherever there is index missing, AB is present in first data frame. So in second data frame, it becomes NaN. QW is absent in first data frame, so it gives you an NaN, but it is present in the second data frame, so it gives you a value. Clear to all of you guys till here? So far, same rows and same column. Can we have different index, but what we create two different dictionaries with same index but different name and age? Try that, Nadim. Very simple it is. You can try it out. Not an issue at all. Just slowly try it. It's all there. Just give it a try. Same NaN will come there also. Nothing different. The full form of NaN is not a number. So these are some of the major things that we are willing to basically study. Now, one important thing I will teach you right now. What is that one important thing that I'm going to teach you is how to read an external data set. Reading an external data set is very, very critical. Why reading an external data set is very, very critical? The reason is very simple. Unless you read an external data set, you will not be able to perform any operations. So reading an external data set is very, very critical. So what we will do is we will basically do analyzing of data set. Sujay, you would know where you have created that Jupyter notebook, na? Just go there, that's all. Just use this. As I told you, every time I'm importing pandas because we are all beginning. Just for practice, I'm importing pandas every time. That's all. Nothing else apart from that. Good. Now, what you're trying to tell your computer, read a CSV file which is there in this particular folder. You're telling it to read a CSV file which is there in this particular folder. Very good. But what is the name of that file? See the name of that file here. It is mtcars2.csv. Just go ahead, put a / mtcars2.csv. Run it. Once you did this, this basic thing will run print of df. Sorry, not print pd, print of df. Or maybe importing library once per file is enough. Yes. Just put df. You should basically get something like this. You should read it. Prem, yes, once is enough. How do you find the location? I told you. Just check the place where you're using it. No, df of 5 you cannot do like that. I will tell you how to slice and dice dfs also. How to copy the path like this. Go to the folder, click here and then copy it. That's all. Click here. This one. This location you have to copy. Copy. Okay. All of you are able to read these external files, guys, without any problem. Now, what I want you to do is, I will give you a minute's time. Delete this code without seeing it, freshly read it. pd.read_csv location file name. Delete this code, freshly read it without seeing that code once, and let me know once you're done. Mac, I have not done any time in Mac, Ankur. Maybe I'll have to check and then let you know how to do that in Mac. Just see the location and read it. So it's similar. Okay, Onkar has used it to upload the file in Mac. I think we will have to do it like that only. Omkar uploaded the file in Jupyter and used df is equal to pd raw c and also tsv. I think file. Yes, upload it and try Ankur. I think it should work. All of you done this without seeing it, guys? Slowly do it. You need some more time, maybe a minute or two. Please take it. But kindly do it, and once done, let me know. We will go ahead and then check some basic things in our exploration. Mission error, restart your Jupyter once, please. Ashutosh. Now, since we have read this file, see, this is the command. Whoever has done it, do it, please. Vinay, location is simple. Just go to the folder. In the address bar, you will have this location. Once these things are read, we need to do some basic data manipulation things. So this is a big one. You have multiple rows and multiple columns. You basically have around 32 rows. And then, I don't know, if you want to count, you count, or else we can do using function. So the basic things that you do is df dot shape df.shape will give you the number of rows and columns. Vinay, you have to give the file name also, Vinay. Try it once. See, forward slash from here to here, it is basically the location. After that, one more slash and the file name. Right? One more slash and the file name. This is something that we needed, Vinay. Even then, what error you are getting? Make it forward slash, na, Vinay. Why are you giving backslash? I told you make this forward slash. See, forward slash. Change all the backslash to forward slash and read it. Sundar, it also supports Excel. Danu, I don't know why you're getting permission error. Put the error in the chat once we will see. Sorted, na, Varun? Good. Permission error you will get if the location is wrong or some other thing. Put the file name na first. See, important thing is the location with forward slashes, and in the end another forward slash and file name. It. You should get the output like this. pd.read underscore csv c user admin desktop IP whoops empty cast2.csv and df. This is what you're supposed to get. It should be still running. Restart your Jupyter, restart the kernel, try it once, guys. Take some time. So that's why I'm doing this in the last. You can try this entire day. No problem. Slowly do it. Here you might be still having a star. It should be still running. Or this kernel could be still black. That also could be a chance. Many things are there. Slowly do it. Okay. If the file is Excel, then extension is different. Raghunath, this is not an Excel, this is a CSV. For reading Excel, you have read underscore XLSX. That is different, not the same one. So don't get confused. First thing is df.endem. If you do df.endem, you basically get 2. Car C is capital. Yeah, file names, different spellings, guys. Check. No, cars is small only. Whatever is the names, give the same name. df.endem of 2, first is dimension. So dimension you have to check. The dimension of the file that we are seeing here is 2. Then you'll also have df.shape. So shape is basically row. Here you have 32 rows and then you have 12 columns or 13 columns. 32 rows and 12 columns. So this is your df.endem dimension, df.shape 32 comma 13. Shape is done, size is done. So this will talk about your basic info about the data. Second thing is the head. So if you do df.head, default top 5 rows are displayed. Can you do this? Head is a function and not an attribute. Yes, head is a function. That is why you are giving a open and close bracket. If it was an attribute, you would have basically given, you wouldn't have given a bracket. So since it is a function, you are giving a bracket. Done. So head is something like this. Default is the top 5 rows. You can access 2 also. Mention how many ever rows you want to see here in this particular bracket, and then you will see only those number of rows. df.5, df.6, how many ever you want to mention, you will be able to see those many number of rows here. Right? Shape is done. I will tell you what is that. Size, Nadim. 1 second. Good. Similar to head, you have df.tail. Tail again gives you the default last 5 rows, but if you give 2, it picks up the last 2 rows. This picks up the first 2 rows. This picks up the last 2 rows. whatever number you mention, it picks up that number basically. Now, once you have this head and tail, df.shape is done. The last one is df.size. So if you give df.size, you will get 416, right? So what is this 416? 416 is nothing but the total number of entries in this data set, which means 32 rows into 13 columns. 32 rows into 13 columns is basically 460. What are endim shape called? They're not functions. No. If there is no bracket like this, head, tail, all of that, they're not functions. They're all attributes. They're like the keywords. So df.endim is 2, df.shape is 32, 13 means 32 rows and 13 columns. df.head is 2 means the top 2 rows, tail the last 2 rows, and also size is 416, which is 416 elements. Yeah, we can make graphical representations. Using Matplotlib, we can do that, Sriram. I will show you in Matplotlib how you read an external data set and then how you will be able to create graphs. So those things and all you will see. Now, starting with this NumPy. So the first one is exclamation pip install NumPy. So basically, you are using this pip install NumPy to install your NumPy. Sorry, this is supposed to be NumPy. NumPy we did it, na? We're not coming to NumPy now. Let's go to Pandas. These are all old ones, right? Very good. I think I went too far. Let me come to Pandas here. Concatenation, vstack, head split, vsplit. Yeah, import Pandas as PD. So basically pip install Pandas helps you to install Pandas library. Import Pandas as PD helps you to import your Pandas library, right? So import, what it does, basically loading from your RAM to your hard disk drive. I mean hard disk drive to your RAM. So that is something that is done by your Pandas as PD. Then you have dir of PD. dir of PD is basically the directory that we have, which lists the complete data. Once this dir of PD is done, you basically check the length. The length of dir of PD is basically 141, which means you are basically talking about 141 functions in Pandas. However, we will not be using all the 141 functions because they're not required as of now. So all the 141 things are not required. So what we will be doing is we will basically go ahead and then cover few of them, not all of them. And once we have done all of that, so whatever the widely used ones we will cover. Once these things are done, completed, what we will basically check and do is we will go ahead and then see. I'll give you this file. After the recap, I will give you that file without any problem. Yeah. Once we are able to do all these things, we will go ahead and then check the other things as well. So other things as in, we will go ahead and then check the version. The main difference that we are seeing here is because of the version. There is a version difference. So once this version difference arises, what we will do is we will basically go ahead and then right. So once you are able to do all these things here, PD version, one dimension data, we saw this, created a series, index is equal to ABC. This is something. Then you saw Pandas using this. Then you understood how index can be changed to custom index. Data frames are 2-dimension, print df, so rows and columns. So these things, this we saw. Then Pandas as PD also we understood. Later print df, so type df, row number, column number. Then you have your index and also column, right? So this is something that we saw. Index is this, column is this. Then once you have this, you check this data frames, name, age. You have name, age, name, age. So you create multiple data frames. Go ahead and then add it. df1 and df2, two data frames specific. df1 and df2 axis 0 is one below the other. df1 and df2 axis 1 is one after the other. Then we also saw what will happen if we change the numbers and then create different row numbers or column names. If you have a different row index, wherever that index is not present, NaN will be taking up. NaN is something that will pop up. Once this NaN comes in, so read external data set, import pandas as PD. So pd dot read underscore csv. See user admin desktop empty cars2.csv. So this is your read underscore csv format. 98% of the times you will be using this. So be very comfortable with this. Practice it once, twice, thrice, how many ever times you want today, but ensure that you are comfortable with this throughout. So this is something that is very much required. So this is something that you will basically need it, right? So this is the basic thing that you basically require it. Now, once you have done all these things, you read this data set, you have rows and columns. Once these rows and columns are there, df.endem. df.endem is number of dimensions is 2. It's two-dimensional data set. df.shape, shape will talk about the rows and columns, which is 32 rows, 13 columns. Head, the top rows, how many ever you want. Tail, the last rows, how many ever you want. Size is 416, which talks about the total number of elements in the data set altogether. So in the previous discussion, what are the things that we did? We were able to read an external CSV file. So I gave you this file. All of you should have read this file by now, right? All of you are able to comfortably read it. Did once or twice. Very nice. So you basically read this external file. Then once this external file is done, you have df.endem. So endem talks about the dimension of the data. It's basically a n-dimensional data set. It basically talks about the dimension of the data. df.shape. So what is this df.shape? Shape tells you the shape of your data set, the rows and columns. Then df.head. So what this df.head talks about? Head basically talks about the top few rows. It can be 1, 2, 5, whatever it is. But default is top 5 rows. You're able to get these things: head, tail, size. Work for everyone. Yes. Very good. Now, once you have done all this, one important function that we are going to talk about is nothing but df.info. So when you do df.info, you get the information about all the columns. So it basically tells us about what is the column name, how many values are there. So here you can see the number of rows in df.shape, which is 32, are equal to the non-null count 32 in every column. This has to be like this. It also tells you the data type of that column. Now, non-null is nothing but the values that are present. Null is nothing but if a value is absent. So non-null count also it will basically talk about. Right? So once this non-null count you have taken, one very simple way to identify missing values is, you can see out of all this, there is one column which is having lesser number of non-nulls, which means there are some nulls in that column. Which is that column? Correct? There's something called as QSEC. Very good. So this is the easiest way to identify your nulls. df.size only we did. That's all. Now, as I was trying to tell you, this is the QSEC. QSEC is the 29th one. So this is the non-null one that you are identifying. QSEC is 29. Right? So once you have this df.info, there's an, all of you did this df.info. Slowly do it, guys. df is not defined. How to solve that? Why Damini? Guys, can someone help her? How it is solved? What you might have done is, you might have just missed reading that file. So that is something you could have done. So that's why you are getting that missing error. Right. So read that file properly, you will get it. Okay. df.info is done. Now, once this df.info is completed, you have df.describe. What this df.describe function does is, you can see df.describe basically gives you a serial number, mpg, cylinder, display, hp, all these things. Gives the count, gives the qsec, everything. So first column is count in df.describe. Okay. Once this df.describe is here, you have your mean value of the column, standard deviation, minimum, maximum, 25, 50, and 75th percentage. We will see how to replace those missing values, how are we going to deal with those missing values and everything, and we are going to see that. Okay, that is one thing. And what are those percentages? Those percentages are basically the data, right? So whenever you have a column, in that column you have certain data. The data talks about what is the minimum value, what is the maximum value. I'll give you a simple example. Let's say you have the data starting from 0 to 100. 0 is the minimum value, 100 is the maximum value. And then 0 to 100, 0 is the minimum, 100 is the maximum. Now, what is the middle value? 50th percentage, 50. What is the 25th percentage? 250. What is the 75th percentage? 75. Like that. So if you have data from 0 to 1000, 25th percentage is 250. 50th percentage is 500. 75th percentage is 750. Then your maximum value is 1000. So basically the percentage of the data that is there. See, df.describe is a function that gives a very basic summary of your data set for every column. So if you can see the df.describe for each column, it picks up the count. So count is nothing but the number of values. Then it picks up the mean. Mean is nothing but the average value. So in the count column, if you can observe, QSEC is basically having 29 rows. QSEC is having 29 rows, which means there are certain columns which are still missing. I mean, there are certain rows which are still missing. So 29 rows, which means there are around three rows which are having null value. So this is how you basically find your missing values in a simpler way. After that, you have the average value of that column. You have the standard deviation of that column. You have the minimum, maximum, 25th percentage, and also the 75th percentage of that particular column. Info is the same thing. You're getting the column name. In that column, how many non-null values are there, which means how many values don't have the nulls, but non-null values are there. And then what is their object type, whether it's a int, float, whatever it is there. So this is your df.info. Okay. Describe is this. You want this file, I'll share this file to you. Okay. I'm giving this file, take it. Okay. Now your df.info is also done, describe is done. You also have something like df.count. So df.count will give you the same outcome as our info, where you get the number of elements of each column. So these three things, whatever you are seeing, these are the main aspects of any data set where your numerical columns are involved. And info works for categories or our strings, or maybe any column with categorical columns. But describe works only for numbers, because you cannot find the minimum value, maximum value, 25th percent, 75th percent of a data which is not a number. So this count is also one thing that you can see, df.count. Now, once this df.count is done, so all of you are done. df.count, it will just print the data frame. df.count with a bracket is a function that will give you the total number of elements in every row. So this is something that it gives. df.info, you can see df.info is nothing but every column and then the non-nulls of that column. So this is something that it gives. Count, info, and then describe. Clear to all of you? The main thing that you will use in this is you will use it to just simply see whether there are missing values or not. Count versus info, both of them are same. Count versus info, both of them are same. So it just gives you the data type, info, but count only gives you the number of elements. That's all. Okay. These are few functions which we will use to identify the missing values. Then once you have these missing values, you have something called as df of min. Min will give you the minimum value of every column. You can get this in describe function also. So describe function also gives you the minimum value of every column. df.min also will give you the minimum value of every column. df.min. But here, when you see a min, one thing that you should notice is you're also having a categorical column. How do you find this categorical column? Why do you get this? Very good. Sort it alphabetically, Mayank. Very nice. 100% true. So it is basically an alphabetical order minimum. It is starting from A. So that is why it's getting. df not defined error, Varun, you could have got because you wouldn't have read the data frame before. Read the data frame first. For mean, you should give brackets. Okay. df.min, we got it. Similarly, we have df.max. Same thing. minimum, maximum. Can you do this minimum, maximum, please? And also you can do df dot mean. You may get a warning here because you're trying to find the mean of a categorical column. It says it is applicable only to numeric columns. So that is okay. df dot min is done. Mean is done. df dot median. So these things you can do. Min, max, mean, median. All of you do this, please, quickly. So if you see, there's one more thing that I wanted to talk about to you here. So these are some things that we saw. Now we will see access the columns of a DF or maybe a data frame. So how am I going to access the columns of the data frame? DF is my data frame. All of you do this. Just take this DF, whatever DF we had. Very good. Now let us say I want to access only MPG. I just want to access the MPG column. So how am I going to do that is put a square bracket. df of MPG. You need to mention that column name in the string like this. So if you mention df.mpg, so this is how basically you access the contents of that column. Now you can do some operations on this like this. df of mpg dot mean, which means the average value of mpg column, or df dot mpg dot mean. This is also, sorry, it's df mean. So you can access it like this as well. Clear? All of you do this. df.mpg.mean is in your df data frame, go to mpg column, find the mean of that column. That's all. In your data frame, go to mpg column and find the mean of that column. That's the thing. Okay. Now, the next one that we will see is I don't know, Nadim. Code we have to see why that error is coming. The last one that we are going to do is type of DF. Type of DF is a Pandas core data frame. No, I have no idea why it is coming. Bound method, ND frame, add numeric operation, local mean of 0. No, I don't know. We'll check that. Okay. For all of you, type of DF are you getting Pandas core data frame? You have to mention mean into bracket. Is that the way? Okay, if you don't mention it, it will come like that. Oh, okay, okay. Fine, fine. You have to mention brackets. True. Code we have to see. Now, once we have done this type of DF, we will go ahead and then do an exercise. So for data manipulation, first step is check and replace missing values. So now we are doing some good data manipulation things. For this, what we are supposed to do, first step, import the data. So first step is importing the data. For importing the data, what we are trying to do, we are going ahead and then reading this particular data. So I don't want all of you to copy paste this code. All of you type it and read the DF, please. All of you type it and read the DF once so that it's a practice, and let me know once you have read it. Yes. So first what we will do is we will use this df dot describe. So using df.describe, once you read the data frame, you use this df.describe and see which column is having missing values. Can you tell me which column is having missing values? You have already told me, but again I'm asking this because in this we are checking for missing values. QSEC QSEC is having missing values here, correct? Now what we will do is, you identified the missing value, replace missing value. So to replace missing value, one thing that you should do is, how will you be able to replace missing value? What is the Vivek, see, df.describe gives you a count. All the columns are having 32, 32, 32, which is that the number of rows. Only QSEC is having 29, which means 29 number of rows, which means there are 3 missing values here. That's the logic. Now, you all saw that you can replace missing values. You all saw that QSEC is having missing values. With what number you will replace the missing value? Omkar says common or mean value. Correct. Samir says mean. Indranil space mean. Replace non-number different value. Correct, Ankur. But what is the different value is what I was asking you. What is the different value? Any guess what is the different value you would want to replace? You can replace it with mean. Correct. Mean of that column. Very good. With the mean of the column. So, how do you find the mean of the column? Mean of the column. How do you find the mean of the column? QSEC. How do you find the mean of the column? Why mean of the column is because, Shivani, mean is supposed to be the best predictor. If it's a string, then mode of the column, Ankita. How do you find the mean? df.qsec.mean. Correct. So this is how you find the mean of that column. 17. df.qsec.mean. So this is how you find it. Now, once you have this df.qsec.mean, or one more way is there. How do you find it? Sriram, why qsec is, as I told you, in describe function in the count, only qsec is having less values, not others. So which means qsec is having only missing values, Sriram. Okay, nice. Another way of doing is df of qsec dot mean. So now all of you are getting different ways of doing it. Very nice. Now you found a function to find the mean of this. Now next thing is replace the missing values. So how are we going to replace the missing values? We have a function called fill_na. df.fillNA, whatever value you give in the bracket, no, that value will be replaced in the data frame. For the entire data frame, if you use df.fillNA, or what you can do is, Samir, all of you, whatever you have given is the right answer. So if you want to replace something, what you're supposed to do, take this df.qsec.mean and put it here. So df.qsec.mean and put it here. Then it will basically replace. You can't see this here. So how do you check whether it is replaced or not? If you just do a df.count, df.describe here, it will not show you right now because it is still giving 29 because you have not replaced the original data frame. So how do you check whether it is replaced or not? You can check whether it is replaced or not. Just take this code, put it here. Then you will be able to see it is replaced. Or what you do is when you do this, just put df is equal to df.fillNA. Df is equal to df.fillNA. Then you will be able to see that it is replaced. Got it? All of you without any problems? Clear till here? If you replace df, then the original data frame will be replaced. I'm not replacing it because I don't want to read it again and again. So this basically will replace df.qsec.mean in only df.qsec.mean. It will just replace all the missing values irrespective of any column. So if you want to replace only qsec column, what you are supposed to do? It's the same thing. df dot qsec dot fill na with what? With df dot qsec dot mean. That's all. You can see only that column will be replaced now, nothing else. You just put df is equal to store it, then it will create a new data frame. Does this replace command update the source file? No, Arun. If you do df is equal to df.qsec.fillNA, then it will replace. And how to replace first null instead of replacing all nulls? You cannot do that, Vivek. You can just replace all of them. First null, second null, we will not be able to do that. It will replace only non-nulls columns. Yes. Raghav asks, if I replace the mean value with each column, how to do it? So that you might have to write a for loop. Not immediate, but or you can do column by column. I tried to do this change df.qsec is equal to fillNA. No, you can do this. That's a correct way only to do it. No problem. Okay. How can I assign it back to main array that is only specific column? Sri Harsha, you just have to do df.qsec is equal to df.qsec.fillNA. It's all about which column you are accessing and which column you are using. That's all. How can you assign back to? I told you. So getting confused in describe part after replacing the value. See, what you did is these are pieces of code. First thing is df.fillNA, which means you are taking this particular df.fillNA function, means replacing all the null values of your df with df.qsec.mean, replacing all the null values of df with df.qsec.mean, and then you are doing a describe. Once the mean values are replaced, then you will get 32 in qsec also instead of 29. If I have NaNs in other columns and replace all of them in one shot, you cannot do that, Raghav. So you're supposed to do it column by column. You cannot go and replace everything in one way. Why do I have to specific QSEC Vivek in Aman's case is because the missing values are there in the QSEC column. So if you replace those things with some other thing, then it may not be proper, na? So that's why. So that's the entire reason why you need to replace it with the missing value. Clear to all of you guys without any problems? We are explicitly calling out df.qsec.fillNA. No, yes. Then Vivek asks df.qsec fillNA, will this give different result as compared to one? What you're trying to do now, df.qsec.fillNA, we are replacing the qsec column with qsec.mean, Vivek. So what it will happen now? You're replacing the entire data frame with a single column that called df.qsec.fillNA. Means the entire data frame will go, only one column will remain there. What you're supposed to do, Vivek, is df.qsec is equal to df.qsec.fillNA. That is what you're supposed to do. What if there is a duplicate column? If there's a duplicate column, then it will not work. If missing values in multiple column, how will fillNA locate which column to target first? So whichever column you specify, na, that will be taken first. The whatever we specify, that will come first. Can we find specific null column? Yes, that is what we are trying to do na, here. In describe, we found a specific null column, qsec. Which value it is going to consider for replacing null, Ashwani? It's the mean. Vivek, got it? Very good. Hemchandra, I mean specific cell. No, you cannot do that, Hemchandra. That specific cell you will not be able to find. You can find, but there's no ready-made function for that. You can do all of that. That won't create any issues. But there are no ready-made functions to do it. That's the problem. You have to write some code. df is equal to df.fillNA, df.qsec.mean. We are not specifying the column here, and there is a possibility that there are nulls in various columns. Will it replace all null values? If you specify the column, it will replace it only for that column. If you don't specify, df.fillNA will replace all the null values. Column is having null, and which value is going to take place in null column? Mean value, Ashwani. So that is what we are talking, na? df.qsec.mean. If you want to specify a particular column, you have to specify df.qsec.fillNA and then do it. Specify which column you want to replace. If you don't use the column name df.qsec.fillNA, then it will replace the entire data frame. Sriharsha, if there is no column name, then you cannot find it. You need a column name for that. Okay, but in our data set, we have one column without the column name, the second column. That will get a column name automatically when you read it. Check. It is called as unnamed one. The column name is unnamed one. The column name is unnamed one. The column name is unnamed one. Mean is for numeric, mode is for alphabet. What is alphanumeric? If you have alphanumeric, then it is also mode only. You treat it as a string only. Right? So this is how you basically replace your missing values. df.qsec.mean. Right? Now, what we are going to do, once you have done this replacement of missing values, The second aspect of the DF. So we saw how to take the data frame, access a column, and replace those missing values. Now, once you have done this, we will have to go ahead and then see how exactly we are going to change something in the data frame. Just try to write whatever I have written. I think that should sort out the issue without any issues, without any problem. Okay. So this is basically my DF. So once you have done this DF, right, the next aspect of a data frame, what we are trying to see is drop columns of a data frame. So how am I going to drop the columns of the data frame? So if you want to drop the columns of the data frame, df dot drop, df dot drop, inside that you have to specify columns is equal to, which are the columns? vs comma am. So you can specify this. If you specify it, those columns will be dropped. Can you do this, all of you? You understood how to replace missing value? Now drop the column. So if any column is having lot of missing values, you can drop it. Drop means you are deleting that columns. See here, vs and am both columns are there. You have just removed both of that columns. I'm not getting table as your result. You should get it. Just type that. It will make any changes in the original data frame? No. If you do df is equal to df dot drop, then it will make change. If you don't do it, then it will not. Original CSV will remain the same. Any questions? Replacing missing values, dropping the column, all of that are good. No questions? Nice. Now, the next one that we will be seeing is we will go ahead and then do some indexing. All of you remember the indexing that we did? We can drop rows also, but we will see that, Mayank. Columns are important right now. Okay, all of you remember indexing that we did? The indexing that we did it using Python based indexing, which is positive and negative indexing, or using row and column names. By using what we did it? We did it using negative positive indexing, or did we do it using the column names and row names? Only indexing, no? Very good. Now, here in Pandas, we have index by position and index by label. So label is nothing but location. So indexes by position is nothing but positive and negative index. So there are two ways how you can basically do this indexing. Indexing by position and indexing by label. Index by position and also index by label. So these are few ways how you can do it. Now, once you are able to do this, you're able to go ahead and then get this thing done. What exactly you're trying to do right now is, I will explain this to you carefully. See this. I will write and then I will explain, that will be better. So I will explain you this concept right now. And once I explain you this concept, we will see how things are accessed. We will not do many exercises as such today. What we will do is I will show you the basic things that we are trying to cover, and then we will do some exercises in the upcoming session. Okay, I will explain you the concept properly, understand the concept properly today, and we will do some deep exercises and all of that in the upcoming session. Can we see how to read record by record and validate name and replace character in name field? No, Arun, that is not possible right now. See, first thing first, we are basically going ahead and then seeing a data frame. Let us say you have one data frame called name, age, salary, and you also have, let us say, this one. Okay, this is N1 20 20K, N2, which is name 2 30 30K, N3 40 40K, N4 50 50K. So I've given the salary range here. Now this will basically have your normal.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. To this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplotlib, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What does the term inheritance refers to in object-oriented programming? Oops, in Python. Here are your options. A. It allows a classes to inherit attributes and methods from other class. B. It refers to the process of creating instances of class. C. It describes the encapsulation of data within objects. And option D. It is a technique for organizing code into reusable functions. You can comment your answers in the comment section. Now let's move back to our session.
Indexing. Let us say, for example, your row index. Here you give serial number 20, serial number 27, 34, and 48. So this is your row index, this is your column index. So basically, this one thing is your table. Okay, this has custom indexing, name, age, salary, and also custom row numbers. Along with that, you'll also have Python based indexing 0, 1, and 2, -1, -2, -3, 0, 1, 2, 3, -1, -2, -3, -4. Got it? You can either access using your custom indexes or you can access using Python based index. Both you can use it. Understood? Either you can use column names and row names to access it, or you can use your Python based with 0, 1, 2, 3, -1, -2, -3 also to access your rows and columns. Is this clear to all of you? I will tell you how to do that now. Now, there are two things how you can access. One is called as ILOC and other one is called as a LOC. What is ILOC? ILOC is a index location, which means you are using index, zero based index. The syntax is nothing but df dot ILOC open bracket comma close bracket colon colon. So I'm not going to tell you what is this colon colon, all of you know it already. This ILOC uses this Python based indexing location. LOC is nothing but df.loc colon comma colon. So this basically uses your names. So you can access it by using ILOC or LOC. Got it? Clear? You can specify the column names and access the data. So LOC will always be easier to access when you compare to ILOC. Yes, true. In ILOC, df of ILOC, what we are trying to do is you're just putting a colon comma colon. See, here the entire data frame comes into picture. ILOC. Drop column, add and rearrange columns, everything is possible. Yes. df ILOC, you get like this. Then if you do a LOC, that is df dot LOC colon comma cylinder to WT, we will get this exercise. I am trying to tell you 2 to 8th column of CYL to WT, row 2 to 8th row of CYL to WT. How are you going to get it? 2 to 8th row of CYL to WT. Do it. Take a minute, do it and let me know once you are done. 2 to 8th row of CYL to WT. df.loc, correct. You're right. df.loc of 2 colon 8 comma CYL colon WT. Got it? Very good. Same thing, do it using ILOC. df dot ILOC. What should I write here? What should I write for ILOC? Index location. Can you tell me? df dot ILOC 2 colon 8 comma 3 colon 8. Let us see if I'm getting the same thing. 2 colon 9. Same thing. Now you know how ILOC and LOC works, guys, and work it out or not. Let me do that. df dot LOC of colon comma, if you give CYL colon CYL, you will get this. Or you can just specify this. Also, you will be able to get. So right way to do is this. Correct way to do is this, because you have to specify beginning and end. So both of them you can do. Understood? Clear? See, as I told you, you only are getting the answers. You yourself are getting your answers. Okay. Now, the next one is simple. All rows from beginning till MPG, including MPG column. Can you do this? You can mention the name or you can directly do it. df.loc of colon comma colon. This is from the beginning of MPG. That's it. See all of that. Now, next exercise is don't get all rows, get the first 5 rows of the same thing. How to access specific rows, specific columns, all of that we will look at it. Not an issue. So let us go ahead and then see what all things that we did previously, and then we will also go ahead and then check what are the things that we did. What we'll be doing today. So if you can see our previous days code that we have done. So we started with identifying missing values. So data manipulation. So we started with checking and replacing missing values. So that was the first thing that we started with. So we basically need to import the data. So how do we need to import the data? If you want to import the data, you need to basically go ahead and then read it. pd.read_csv, you read your empty cars to CSV file here, and then you will be able to see that empty cars to CSV file here clearly. And once this empty cars to CSV file is done, we went for something called as describe. So all of you know what this describe will do. This describe will basically gives you the basic description about the data set. So basic description as in the count, mean, standard deviation, minimum, and maximum. So this is basically the describe function would give you. Now, once this is done, you understood that there is a missing value in your QSEC column. So once you have that missing value in the QSEC column, so once you have that QSEC 29, so basically 29 means you have basically three missing values in this particular column, which is 29. Now, how are you going to replace it? You saw how to replace it with the mean, qsec.mean. We are able to go ahead and then check this and then get this thing done. qsec.mean is something that we saw. Then you can also find it by using df.qsec.mean. By using a fill_na function, we filled it. So this is something that we did it. df.fill_na, df.qsec.mean. Then we have the same function for df.fill_na, qsec.mean.describe. So this describe function would basically show that it is already being replaced. 32. Now once this is done, you have something like dropping the columns we saw. df.drop, we used df.drop to drop VS and AM columns. Then we also had this index by position, which is ILOC, df.iloc, df.iloc space, this is something that we have, df.iloc colon comma colon, so this is one thing that we had. Then we also had something called as df of loc. So I showed you how exactly the ILOC and LOC, both the functions are working, right? So I exactly showed you how exactly the we did it. So ILOC and also LOC. ILOC starts for index location, where it gives you the location of the index. So by using your positive and negative indexing, you are accessing your data, which is ILOC. And the next one is nothing but your LOC. LOC works when you are basically using the location of your data. You can see this. One is your standard index name and the other is your row name and column name. So once these two things are used, ILOC and LOC are used. Any questions in LOC and ILOC? Guys, just give me a minute. I'll be back. Give me 1 minute. So what we did is we did this LOC and ILOC, which we explained it to everyone. Then we also saw some small exercises. How do we access by using LOC and ILOC? No questions? Anyone having any questions? Please put it in the chat window. Ashwani, they have not given the right for me. Fine. So now what we will do is, let us go ahead and then see how exactly we can put some values into the columns. Okay, so we will go ahead and then see that. See, in my DF, You can let me know, maybe you can type it if possible. See, in my DF, if you see, DF of VS column is having 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, everything. Now, if you want to replace all the values of DF of VS, DF of VS is equal to 11. If you type this and then print your DF, the complete VS column will be replaced with 11. Can you do this, all of you, please, quickly? I'll give you 1 or 2 seconds. Please do it and let me know once done. Just put done in the chat window. We'll complete it. Now, once you have replaced this, you know how to replace value of a column. Now we will see how to replace a value of a single element. So now how are you going to replace the value of a single element? Just go ahead, use the same DF. DF exactly by using indexing, correct, Ankur? You can see DF of VS you have given, na? DF of VS, this is your complete VS. Now in this you can access 0, 1, 2, 3 like this. So third element is 11. Now you can replace this third element with 100 and then print your DF. If you do this, you can see the third element will be replaced with 100. Can you do this and let me know once you're done, guys? Now, once you have done this, what we are doing right now, once you have completed this particular thing, we will go ahead. What we did is we basically created a data frame. In that data frame, we read a particular column. In that column, we took the third element and replaced it with 100. That's all. Now we did this. Just check this. In DF, we have around 13 columns. Not 13. No, 13 columns are there. Why warning is because we are doing slicing and storing the value. That is why warning. If you don't know the index number, you will not be able to replace it, Ashwani. That's all. You should know which one to replace. So if you don't know which one to replace, the index, then you may not be able to replace it. So that is one thing. Now, once this is done, the next one that we are talking about here is, you can see we have, okay, let me answer your questions. Can we delete one entire row? Yes, we can delete one entire row. Yes. Considering about the bulk data, no. However big it is, if you don't know the index, you will not be able to replace it. You have to search for that. Only then you will be able to replace them, Ashwan. Without knowing the index, you will not be able to do it. Now, once these things are done, once we have done all these things, so what we are trying to do right now is, you can see, unnamed one MPG, 13 columns are there. Now, out of this 13, we are going to create a new column. We are going to create a new column and then we are going to do an operation. So answering to Ashwani question, you should know the condition. So if you know the condition, then you will know the index. No? You have to put the condition, filter the index and then do the replacing. DF, you know how this thing is working. Then next we can go ahead and then unnamed one MPG cylinder disk HP, all these things are done. Now here in this DF, we will create a new column. So we will create something called as a, I will just put it, create a new column. So how do I create a new column? I will create a new column by just mentioning the column name, KMPL. So there's no column called KMPL here. I will create a column KMPL and then I'll assign 0. So only when you assign some value to KMPL, it will be created. You can see KMPL 0. Previously, you did not have KMPL in your data. Now a new column called KMPL is created. DF of KMPL is equal to 0 is something that we have mentioned. Now, what we can do is, instead of mentioning it as 0, so this will come to you in your feature engineering. You create new features by using values from another feature. So df of KMPL is equal to, let us say, 0.42. I'm just giving a number. It takes the value from MPG column, multiplies it with 0.42, and then it basically saves it in df.kmpl. Done. Can double and single quote be used interchangeably? Yes, you can use it. We have this for a new row also. No, row you cannot create like this because a column will have data of same type, you can create it. Row you cannot create like this. For row to pass, you need to define every value. Happy? You can give different value to every row provided you have that list with you. Now see, different value has come for every row. 8.20, 9.5, all these things. So how to create new columns, you understood? Very good. Now what we will do is, we will create a column in the middle of the data. How do I create a column in the middle of the data? df.insert of loc is equal to 3, which means the location column is at 3. The column is equal to, I will just put new call, okay, column name, and the value of the column is 100. So if you just put this, you can see there's something called as new call that has come in the location 3, which is 0, 1, 2, 3. Third location, new call has come. Yeah, Shirley, it will not drop. So you need to store it in DF. Whatever change you do, it will come. Hemachandra, you would have already run the code, so it will not insert it again. Same column. Check your DF. If the same column exists, then change your column name, then it will work. Okay, good. Now, once we have done this, what we are going to do is, we will replace all these 11s with 110. DF of VS 11s with 110. So DF of VS, you can see you have 11. Now replace all that 11 with 110. So except 100, we will have to replace everything. So how are we going to do that? DF of VS is equal to 11. So if you give, all the true values will come true. Only the value which is not 11 will become false. Okay. Now we need to filter them. So these things we will see how to do this filtering and all of that. We will see in some time. DF of VS, you basically check the condition is equal to 11. Then what you do? DF dot VS off. When you do this, it will only filter the true ones. The false one will be taken out. You can see 0, 1, 2. Third one is taken out because third one is 100. df.vs of df.vs is equal to 11. Whatever true values are there here, df of vs is equal to 11, that will be retained and everything else will be removed. Done? Clear to all of you till here? Very good. Is equal to 110. So if you do this and then print your df, you will see, oops, sorry, my bad. I have to put it into df. Okay. df.vs is equal to is equal to 100. I gave it, is it? Okay, I just need to give 110. I think I made a small mistake. Hold on. Okay, this has become true and false now, so it will not take. I just need to read the file again and then run them. Give me 1 second. I will read the file again and then I will run it. You are able to follow whatever I'm trying to explain, right? Without any problems. So I read the file. Then what I did, now I need to replace my df with 11 and 100. Those two lines also have to run. Vs of 3 is 100. So this one also we ran it. Now replace ds of vs with 11. Okay, this one first, this one second. So now my data will have 11 and 100. Yeah, if it's already existing, it will not work. Yes. Now if I go ahead and then do this, it will basically change. See here, 110, 110, 110. Only the third one is 100. All others are 110, 110, 110. Got it, guys? All of you. Third value to 100 is nothing but df.vs of 3 is equal to 100. Surely. I will repeat again. Give me 1 second. I'll show that command. This is the command for replacing third value with 100. df of vs is equal to 3. df of vs of 3 is equal to 100. So this is replacing 1. Okay, very good. I'll repeat how we did this. See, once your data is here, if I run it again, the data will be replaced. So I will just explain you the code. First, what you did df.vs is equal to 11. So once you do df.vs is equal to 11, that is equal to 11 basically talks about the equality, which means which are all the values in ds of vs is equal to 11. So which are the values that are equal to 11 is something that you are seeing. Now, once you have this df of vs is equal to 11, it will give you a true or a false. Wherever the value is equal to 11, there you will get a true. Wherever the value of 11 is not equal to 11, there you will get a false. Then you are filtering df of vs for trues and false. So df of vs of true you will get, which means wherever it is 11, those values will be selected. And in that values you are replacing 110. That's all. We can do all that options. All that options we can try. Yes. Now, what we are going to do next is we will go ahead and then use this. So what are we going to do? We are basically doing something called as a sorting. So what exactly sorting that we are trying to do? Here you can see sorting. So what is the sorting? Sorting the values of a column. One thing that you should remember is default sorting is ascending. So default sorting happens in an ascending order. Now, what we will do, we will take a simple example of MPG and then sort it. So how do we sort it? df dot sort underscore values. You just have to give by is equal to MPG. So if you give this, you can see the data frame will be sorted in an ascending order of your MPG. df dot sort values. So basically what we are trying to do here is we are trying to sort the contents of our column. We are trying to sort the contents of our data frame. And how are we going to do that is we are using our normal data. However, we are trying to go ahead and then use our normal data. By using our normal data, we are trying to sort it. How are we going to sort? Sorting is done by using sort values function, right? So once you basically go ahead and then use the sort values function, what we are going to do once that is done, we will basically go ahead and then sort it by using a column called MPG. Okay, understood? Why by used here? Which true and false path? Can you be a little bit more specific? So by is a column name. By means sort by what? Sort by MPG, sort by cylinder, sort by disp. So what do you want to sort it by? So sort by something. So that is something that you're basically checking it here, right? So you have some alternates. So you're basically sorting them by some value, but without by also works fine. Yes, it works. Adding 110 to the column. Okay. Yeah. Yes, it will work. But by is something, if you can use it, it will be good. So since you're doing it in the starting, you need to remember the names. That's why. Adding 110 to the column. See, path df.vs is equal to 11. Once you do this, it will basically scans the entire column and then it will give true value to only those numbers where you are getting 11. Now, when you give df.vs of the true values, when you get df.vs of the true values, then you will only filter those true values, nothing else apart from that. Once you filter those true values, what you're supposed to do is you're supposed to replace them with 110. That's it. Nothing else apart from that. So df.drop, what you're trying to do, you're just dropping off the values, Hemchandra. df.drop, which column you want to drop in this particular set of column. I wanted to drop new column. So that is something that you're trying to do. So just dropping those columns. That's it. Yeah, df.vs, all these things we did. Sorting and all these things we did. Sorting basically using ascending. Now, what we will do, we will also go ahead and then check for one more column. You can see I am copying unnamed one. Okay, unnamed one is basically df.sort by is equal to unnamed one. So if you do it, df.sort underscore values. Now, even though if it's a categorical variable, see here, even if it's a string, it is sorting. Can someone guess how it is sorting this? Very good. So this is basically sorting by using an alphabetical order, right? A, B, C, D, like that. Very nice. And now let us go ahead and then see the reverse of it. As we saw, the default is ascending. We will see the other thing as well right now. Okay. Now df dot sort underscore values of by is equal to, as I told you, we'll check now maybe disp. Okay, we will sort it by disp, comma, what you're supposed to give, ascending is equal to false. So if you give this, then the DF will be sorted in descending order of disp. Can you do this, please? Secondary also is possible. We will see that, yes, Satish, in some time. Can you do this, please, all of you? Maybe a second you take and then you do it. Once you have done this, the second one I'm asking to do is df dot sort underscore values. Here you have sorted using only one column. Now what we will do, first sort will happen on cylinder, then second sort will happen on gear. So if you do this, it basically talks about 4-cylinder cars first. In 4 cylinders, 3, 4, 5 gears. After that, 6-cylinder. In that 6-cylinder, 3, 4, 5 gears. Then 8-cylinder. In this 8-cylinder, 3, 4, 5 gears. So this is a multi-level sorting that we have. Understood this multi-level sorting, all of you? Okay, what I'm doing here is I'm just telling that df.sort underscore values by. So by cylinder comma gear, which means we are basically sorting it by cylinder and also gear. Cylinder is 4-cylinder first. In the 4-cylinder cars, you are checking 3 gear, 4 gear and 5 gear first. Then 6-cylinder cars. Inside that 6-cylinder, you are checking 3 gear, 4 gear, 5 gear cars first. Basically, you are subsetting it with gear and then cylinder. First is subsetting with respect to ascending order of cylinder, then subsetting it with ascending order of gear. Yes, we can do one ascending and one descending. I will show that also now. We will discuss about all of that. One, you did cylinder and gear. Now, what we will do in the same thing, if you just put this, comma, ascending is equal to false, then what happens? Everything will be reversed. Cylinder will be in descending order, gear also will be in descending order. So you get both descending order. Can you do this quickly? And we will see the others also. Now, once you have done this, done, good. Now we will sort cylinder in ascending order, gear in descending order. How are we going to do that? Take the same code. Ascending is equal to, so if you want to sort cylinder in descending order, give false. Then if you want gear in ascending order, give true. So if you give like this, cylinder will be in descending order, gear will be in ascending order. Then surely this is the question that you are asking. So Sajani, what we did is we basically sorted the people, cylinder and gear. So by default, everything will be in ascending order. Cylinder will be in ascending, gear also will be in ascending. By passing a list of true and false to this ascending function, we basically sorted cylinder in descending order because we made ascending as false for cylinder. Then true for gear is your descending order. Sorry, cylinder is descending order, gear is ascending order. So whatever order we want, we can do it like that. But cannot have gear in ascending order as value is fixed. No, you can see gear 3, 3, 3, 3, 3. You have 5, 5 here. Then you have 3, 3, 4, 4, 4, 5. Then you have 3, 4, 5. Based on your cylinder, gear is also changing. Now, let us go to the next ones. And then we will see what to do. We did basically sorting. Now we will do filter. So what do we understand by filter? Filter is nothing but based on a condition, you are basically filtering the things. Okay. Now, how are you going to filter? In Pandas, you need to filter the true rows. So true rows will get filtered. So how this true rows will get filtered? Let me show you an example of filter numerical columns. So how are we going to filter numerical columns? I will tell you. So you can see df dot cylinder. Okay, this is your df dot cylinder. So if you give df dot cylinder is equal to 4, you will get true or false. So whichever cylinder is 4, you will get true. Whichever cylinder is not 4, you will get false. Right? So is this understood to everyone, guys? Very good. Now what you're supposed to do, select only the true values because Python will select only the true values. How are you going to do? df of df dot cylinder is equal to 4. You need to give like this. If you give like this, it will basically filter only those rows where cylinder is 4. See, only 4 is filtered. This is how you give it. df of df dot cylinder is equal to 4. Clear? This is how you basically provide the value. You can even remove this particular bracket. This is also not required. Just do this and you will get it. df dot cylinder is equal to 4. This is the basic filtering.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. So this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplotlib, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What does the Pandas Python data science library primarily facilitate? Your options are A. Web development, B. Machine learning, C. Data manipulation and analysis, and option D. Game development. You can comment your answers in the comment section below. Now let's get back to our session.
That you are trying to do. Done? No questions? So this is how you filter numerical columns. So we will see some alternates in this also. How we are going to do it, what we are going to do it, and everything. Now, instead of this equal to, or maybe instead of the other thing, I will show you how do we filter categorical columns. Basically filter the categorical columns. So I will take unnamed one as an example. From unnamed one, what we are going to do, you can see here, df of unnamed one. Okay, df of unnamed one dot str dot starts with. So if you use starts with, what you will get? I will use mark here. You will get true false. So for string, string starts with is something that you will use to get your true false. Then what you will do? You will just have to pass this df of. If you do this df of, then you will get all the columns that starts with mark. Here you filtered out all the columns that are cylinder is equal to 4. Here you have filtered the categorical column which starts with mark, or you can even do this starts with is something that you can do, or you can also do something called as contains. Contains. If you do contains also, you'll get it. Start with means it will check whether a string is starting or not. If you put contains, then it will check whether some keyword is contained or not. Just like you are using equal to, here you are using starts with and also contains. Can you check this, guys, all of you, please? Can you do these two? Numeric filter and also a string filter. One thing that you did. Now we will include conditions for multiple filters. So we will see how multiple filtering conditions are being done. So let us go ahead and then apply things for multiple conditions. Filter. So df dot cylinder greater than 6. So this is one condition. Okay. For every condition, you can put them in square bracket. You will get true or false. Then you will use a or condition. Put another one. Df dot gear greater than 4. You can use a condition like this. So you'll get true, false, all these places. Now to access your df, all you have to do is df of this condition. So whichever is true, it will select. Here the cylinder is greater than 8 and also gear is greater than 4. This is OR. So basically when you give a OR, either of the condition should be true. Either cylinder is greater than 8 or gear is greater than 4. So for both these conditions, you have got a filter. Can you do this? Check this and tell me, please, all of you. Now, similarly, just take this code, combine both conditions. Instead of using OR, just use a AND. If you use AND, cylinder greater than 6 and gear greater than 4, you will get something like this. Can you do it? So basically AND filter or filter, all of that we have used it. Okay, take some time, no problem. The change is simple. Here you are using an OR, which is a dash. Here you're using an AND, which is an ampersand. There's no other difference here. Now, since you have done this, what we will do, we will basically filter strings and numbers both. So how do I filter strings and number both? I will basically take df of unnamed one, unnamed colon space 1, then str. Okay, you do one thing and or correct all Srinivas. So what you do, string filter for string and numbers, filter for something string contains mark and or gear equal to 4, you write it. Don't write it for gear greater than 4. Write it for gear equal to 4. Very nice. The next one, what we are trying to do is string contains P. Okay, capital P, and MPG greater than 20. Can you do this, all of you? String contains P and MPG greater than 20. Can you do it, all of you, without any problems? String contains P and MPG greater than 20. Very good. Happy. Very nice. So let me write it. Okay, all of you do it. I'll give you a minute. Onkar, very good. You're able to filter them now without any problems. Hemchandra, correct. Good. Samir, very good. Pawan, good. Very good. Any questions to anyone right now? Very good. So let me write this for you. df of unnamed colon space 1 dot str dot not contains, maybe I'll do starts with. So because P many will be there, or maybe we can do contains only, no problem. Contains P. And the second condition, here you have to put a bracket for this condition. So this is one condition. Now you are understanding how these brackets work, guys. df of mpg greater than 20. So now you're getting false, 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 false. One true is there, that's all. P means car, Porsche, I think. So all you're supposed to do is df of, see, only one car that contains P in its name, capital P, and then mpg is greater than 20, which is 26. Getting the basics of your data manipulations, guys, without any problem, all of you understanding it. Basic about your data set. So if you want to extract the data, if you want to do some data manipulation and all of that, you use Python to do that, nothing else apart from that. So Python is being used in all that purposes. Yeah, so it is basics for data sets. So coming to the missing value treatments, we will see. Yeah. In the previous session, we basically went ahead and then we started to speak about Pandas. So we started to do data manipulation, checking and replacing of missing values. We were checking this. Then we had something called as importing the data, WT. So QSEC is something where you have 29 elements. So in the 29 elements, we see 3 elements are missing. So 3 elements are null values. We see that those 3 elements are basically missing. Replace missing value with mean of the column. So basically mean of the column is qsec.mean. So if you want to replace it, df.qsec.mean, you are replacing it. Then df.qsec.mean, you are checking how to calculate mean of the column we saw. Then we replace with the missing values, df.fillNA. FillNA is a function which we are using to replace the missing values inside a data frame. So if you use df.fillAny, and then if you continuously use the value which is inside the bracket, you'll basically check that all these things, all the values in the data frame will be replaced with the mean value that you give here. Once you have this df.fillAny, qsec.mean, the complete data frame is replaced with NAs, right? So NA values in the complete data frame will be replaced with the value that you give here, which is your mean value. Then once we did this, we basically did a describe and checked whether it is replaced or not. We saw that yes, it is replaced. df.qsec.fillAny, df.qsec.mean. So you're basically replacing a column with the mean value of that column. So then we understood how to drop the columns. We saw two columns, we dropped them. Then we understood indexing, iloc and loc, which is index by location and index by position. Once we saw iloc and loc, we basically went ahead and then saw, you saw this, the WT. See, you saw how to access these things. So after once we did all these things, we went and then we saw specific row access, specific column access, some basic filter access. So all these things, creating new columns, all these things we saw. Then once we saw this, basically we went ahead, dropped new columns, filtered, and then also filtered for strings and also filtered for numeric values. Then sorting we did. And once we did all these things, we did some exercises on all this. So these are some things that we saw with respect to our pandas. And some more examples, some more exercises you can refer from this link. Right? Are we good till here? Any questions to anyone? Now we will go ahead and then start with Matplotlib. Matplotlib is a graph library, which means used to draw simple graphs, not complicated one. It is used to draw very simple graphs. Okay, you will not be able to draw any complicated graphs using Matplotlib, right? Have anyone heard or maybe worked on Matplotlib anytime before? You need dimension, you need lines, you need some other things, correct? You need a pencil paper, need some lines and join the coordinates, correct? Very nice. So whenever you want to draw these things, first step is you need some space to draw it. This is your space. Then what you will do as a second step, you will put off some lines like this. Third step, you basically give some details to it, correct? Basically give some details like this. Fourth step, you basically give colors and everything, correct? You can go ahead and then add some colors, and then you will be able to make it a little colorful. So this is how you write it, correct? A simple example, correct? And now when we are looking at a Matplotlib graph in Python, how are we going to do that? You will have space for writing a graph. Along with the space, you need many other components. So what are those components? You need axis. You have x-axis, you have y-axis. Once you have this x-axis and also y-axis, you will have certain graphs or maybe some grid line kind of structures like this. Once you have these, you will have labels, X label, Y label, title, then you will have your legends, sales, profit, etc. Then you will have something called as grid lines. Grid lines are something like this. So grid lines are like your graph lines. So like this, you will have many of them. So once you have all these things, so this is clear. This is clear to all of you. No questions. Very good. Now, since this is clear to all of you, what we are going to do next is we are going to combine all of them. So if you want to get a correct graph, these are all layers. So every layer will have its own code. Code 1, code 2, code 3, code 4, code 5, code 6, all these things. Now, once all these layers are here, what we are supposed to do is we are supposed to stack them like this. One below the other like this. So how are you going to do it? So you just need to write code 1 plus code 2 plus code 3, so on, code n. So how many ever layers you want, you can add it like this. So once you write your code 1, code 2, code 3, code n, and then you have to view it from the top. Then the resultant structure would look like this. So this basically will have a x-axis. This basically will have a y-axis. Then it will have graphs like this, two graphs. Then this will have X label, Y label, title, legend, then it will have these lines also, grid lines like this. Like this graph kind of lines. Understood, all of you? So this is a code by code, layer by layer approach. Clear to you? No issues. once you have already installed it, you'll have this basically requirement already satisfied message that you are given. Very good. The next is dir. No, next we have to import matplotlib dot pyplot as plt. Done. Very good. And now, once you have done this, we basically check len of dir of plt, which means you will get 254 functions. Yes. To check the version, how we are going to do? Import matplotlib, then matplotlib dot hyphen hyphen version. You cannot take plt directly. You have to import matplotlib to check the version. So matplotlib dot hyphen hyphen version. So this is something that you're supposed to do it. Done? Got it? You same. Okay. Same is fine. No problem. Anything is okay. Kindly check and then see how we can do it. Good. Very nice. So something that I want you to keep in mind is these things, all of them will have certain code. This is code 1, this is code 2, this is code 3, this is code 4, code 5, code 6. So every part of this has a code. Now I'm going to show you how we are going to write that code. Okay. See, every part you might have to write a small piece of code, and then with that small piece of code, you will be able to understand it. Now we are going to see how that small piece of code is written, and then we will check that. Okay. Small one, we are taking an example. All of you know what is linspace, right? I had told you what is linspace. So we will probably use linspace to generate the data. A is equal to np dot linspace of 0, 10, and then maybe 20. So 20 points will come. 20 points, this we will use it to plot it. Now, how are we going to use for a, we'll use this for a line graph. Okay. For line graph, give me 1 second. For a line graph, we will use multiple packages and libraries, and we will see how we are going to do it. The first one, the first part of the code is import packages. So what packages I need to import? I will basically import numpy as np, then import matplotlib dot pyplot as plt. So because I will use numpy to generate my data, matplotlib to plot the data. So what I will do, generate data. So what I will do now, a is equal to np dot linspace of 0, 10, 20. This one I'm using. Then all of you do it till here. Done. Done. Good. So once you generate this data, what you're supposed to do is you're supposed to draw a graph. So how are you going to draw a graph? As I told you, to draw a graph, you need space. So that space you will get from fig plt dot figure. So in this plt dot figure, if you give fig size is equal to 6, 2, then your graph size will be 6, 2. Then what you will do, you will take ax1, a variable, plt dot subplot. So if you give this function subplot, your space will be ready. See, these two lines are used to create a space. Plt dot figure and subplot with a empty brackets. I will tell you what will happen if you fill these brackets, but as of now, just see plt dot figure, plt dot subplot empty. Subplot empty will basically talk about a empty space that you will be using. Done, guys? All of you. 6 by 2 is the size of your graph. 6 units here, 2 units here. So if you make it 4 by 2, then it will become small one. 6 by 3, a little bigger one, like this. 6 units length, 2 units height. Clear? Very good. So I'll repeat it. So as I told you, there are different codes that you need to write to plot a graph. So what are those different codes? First is you need to import your packages. Import numpy as np, because np you will use to generate the data. But in other things, in maybe other graphs and other places, you can import, or so you can just use certain things and then you will be able to basically run it. Okay, you can either import it or you can just directly get the data from outside. So either things you can do. Now np dot linspace of 0, 10, 20, 0, 10, 20. So this is your data. For plotting, we are using this particular data right now. Once you have done this, plt.figure fig size is equal to 6, 3. Is it clear now, or is it still cracking? Is it clear? Okay. So here, this is your data. Then we are using something called as fig. plt.figure. So plt.figure is a function that will help you to determine how big you want your graph size to be. So the graph size here, what we are looking at is 6 units by 3 units, which means 6 inches in length, 3 inches in height. So this is basically the size of the graph that you are going to check. Okay. Then you are having ax1 plt dot subplot with the empty bracket. So what this particular subplot with the empty bracket tells us is you are using the entire space, complete space you are using to draw the graph. So that is what subplot empty will talk about. Subplot empty will talk about that we are using the entire space for our graph. That is subplot empty. Then once we have this subplot empty, what we are going to do next is we are going to plot the graphs in this. Now this part is clear now. We got this particular code one. Now we can either pick one or two, x, y axis, and then graph lines, and then we can plot it. We will add one component after the other after some time, but now we will see some basic components and then we will go ahead and then do it. Now you got the graph space, then the next component of your graph will be basically a line. So how am I going to do that? ax1 dot plot of a. I just have to do this. If I do plot of a, one more layer will come. So this layer is the line layer. So xy already comes, then this is the line. Are we clear? A simple line graph. Take the packages, take the data, define the space properly, then plot the graph, whatever graph you want. Clear to you? Subplot is nothing but in this particular area, okay, how much you want to use it for plotting your graph. If you put subplot with an empty bracket, which means use the entire space to plot the graph. If you have some value inside your subplot, which means you're basically going and then using part of your subplot, which we will go ahead and then check in sometime. Right? Right now, subplot empty means you're basically using entire space to plot this line. With some arguments, we will see in the upcoming sessions how we can divide this and use it. Okay, that is subplot. Last is ax1 dot plot of a, which means you're just plotting your a. A is this data. You can see 0, 0 0.5, 1, 1.5, 2, 2.5, 3, like this. The first value is 0, second value is 0 0.5, third value is 1, fourth value is 1.5, like that. 0, 1, 1.5, 2.5, like that you are plotting this. Starting value is 0, the last value is 20. So that is what you have plotted here. I mean, the last 20th value is 10. That is what you will get here, like this. Because it has index, no? Index also will be taken. Index is your x-axis. These values are your y-axis, Hemchanda. Subplot is for your space. Plot is for your element, the graph. I got the output code. but not the figure. I got the output code, but not the figure. Type this properly. You might have skipped something. If you have typed it properly, then you will get it. There is no other problem. If you want, you can put your code. We can check it in the chat. Just put your code in the chat window. We will check that. Put everything in the same cell and run it. Don't put it in separate cells, as Bharat correctly says. Put everything in the same cell. All your data for graph should be in the same cell. Because as I told you, it is layer by layer. Code 1, code 2, code 3, code 4. I showed you here, no? Like this. So all of them should be one below the other. Code 1, code 2, code 3, code 4. Only then it will come like this. When you run it in separate lines, it will not work. plt.figure fig size 6, 3, which means it talks about your graph size. 6 units here, 3 units here. So the size of your graph. Then subplot means whether you need to use this entire graph or should you subdivide it. Since I'm giving subplot empty, I'm not dividing this, I'm using the entire graph. plt.figure is a function that is used to give size to your space. Clear? plt.figure and subplot. Clear to all of you? Nice. Now I will add another layer. I will add another layer of graph. Nadim, it is simple. See, all these values have index 0, 1, 2, 3, 4, 5, 6 up to 20. Index is your x-axis, values is your y-axis. Nadim, got it? Very good. Now I will put another data here. Lin space of maybe we'll start from 10, 20. No, I will use 10, 30, 20. Now what I will do, the only thing that I have to do is here come and then put ax1 on subplot plot b. So can you add this? Add a data, add a subplot and plot it. Done. So this is the basic line graph that you are plotting. Import numpy as np, matplotlib.pyplot as plt, np.linspace, np.linspace. plt.figure, fig size is equal to 6, 3, plt.subplot, and then you're basically plotting. So all components of this graph, are they clear to you guys, all of you? Now, what we will do next is we will go ahead and then see how we are going to do the same thing, a little additional things that you're going to add to this. Okay. So let me tell you something. So this is a simple line graph that you have. You can add some elements of detailing and aesthetics to this. We will see how we are going to do it. So same thing, we are going to take the library, import packages. You can type along with me. Similar code I will type. Import numpy as np, import matplotlib.pyplot as plt. So this is basically my library. And then again I will take a is equal to np dot linspace of 0, 10, 20. Then, okay, let me take only A and then we will see. Then this is my data. Then fig is equal to plt dot figure of fig size is equal to, let's say 6, 3 only I will take again. Then ax1 is equal to plt dot subplot of empty I will take. Then once I take this, I will just put ax1 dot plot of a. So if I do this, plot of a, I get this. How A and B defines x and y axis. So since it is a single dimension, ax1 is a variable, Nilesh. That's all, nothing else. It's a subplot. Variable which has the subplot value ax1. Okay. Then Sriram, how A and B defines x and y axis? See, since it is one dimension, index will become the x-axis and then values will become the y-axis. That is by default. There won't be any change in that. Index will become x-axis and the values will become the y-axis. That's all. Okay, Shira. Now, see, some small changes I will make this. Range as in, yeah, the values, no, from 0 to 20, they are y-axis. Now, you're plotting A. You can change certain aspects. See, these are some detailing elements I will show you. Line width is equal to 1 if you give. Line width is this much. If you give, let's say 5, your thickness will increase. Line width. See this? So small changes I'm showing you right now. Observe these properly. Okay. Can you do this line width? Line width is equal to 5. Then after line width, you will have something called as line style. A line style is equal to, you can just use a dotted line. It will not be properly visible, but I will see if I can make it. Unless we zoom it, it will not be properly visible. But let me see. If it works, good. If it doesn't work, then we will not use line style. Some elements I will show you how you can alter the working of this. Is it working for you? It basically gives a dotted line kind of a structure. You can use a double dot. See, use two dashes, then you'll get a dotted line. 2 dashes. Okay. Then you can change color is equal to K. If you use color is equal to K, it will become black. R red, G green, B blue, like this. You can change to whichever color you want. This is color. Line width, I'll maybe make it 5. See, thicker lines. Done. Alpha is your transparency. If I make alpha 0, then the line will vanish because it is 100% transparent. If I make 0.1, lightly it is visible. 0.3, still little bit more darker. This basically talks about the darkness of the line, alpha. 8, still darker. 1, completely dark. So this is your line width, line style, color, and alpha. Working for everyone? Raghunath? Other styles, as far as I know, maybe you can use a star. I don't know. No, only this single line and double line I think we can use. This we need to check the documentation one. Alpha varies from 0 to 1. 0 is the lightest, 1 is the darkest. Good. Okay. Now, if you want to plot the values, what you will do here is you will use something called as marker. Marker is equal to star. If you use marker is equal to star, everywhere, wherever you had the values, their stars will come. Marker. I reduced my line size. You can see stars here. Wherever you had a value, there are basically 20 values, 20 stars are coming. First value, second value, third value, fourth value, fifth value, like this, 20 values. You can use a triangle by using an up arrow like this. See, these are your markers. You can use 0, I don't know, or maybe dot. Dots you can use like this. Dot, star, and triangle. Alpha is between 0 to 1 in the running. Varun, yes, getting value error for trying to give value more than 0. Correct. 0 to 1 only you should give. Alpha is a transparency. Values, I am not sure. You can show it. Aman, we need to check. Usually the displaying values is little difficult, but we can check that. Alpha is your thickness. If you make your line size as, let's say 2, you'll get a thicker line. By changing the value of alpha between 0 to 1, you can see it becomes a lighter line. If you make it 0, it will become completely light. If you make it 1, it will become completely dark. So do you want to make it a lighter line or do you want to make it a darker line is something that you are checking it here. Now what I will do is 0.5 I will make a thinner line. Marker color in specific you will not be able to change, Amruta. You might have to plot it separately. If you want to plot a separate marker, what you're supposed to do is plot it like this. Make it very, very less. Make a bigger line here, little bit bigger line. Alpha reduce 0.7. For marker, you make it B. So then I think two things will plot A. If you make A, so the same thing will come. You have to create a separate data itself, B. Since it's one layer above the other, you will not be able to see that. Alpha is 0.2 I will make. Let's see. See, now you will be able to see a little bit of this. So this is how you make it. Because they're overlapping, that's why. If you make it a star, then you will be able to see something. Right? You have to write components for everything. Clear? You can change the line size to a single line or a double line. Okay, import packages. We change value of B, then it will be visible. You have to change value of B and then write separate components to that. Only then it will be visible. Very good. Now, once you have used your A, similarly, I will use B also. For B, what I will do, I will take a little different value where I will reduce it 5, 0, 20. Fig size is there, subplot is there. You have lot of colors, Sundar. I will show you how many colors are there in some time. We will see once we look at the palette. The next thing is ax1 dot plot of B, comma. We will see line width. Let's say I'll make it as 1 only for as of now time being. Then line style. I'll again give line style is equal to, I will create a single dash. Then color, I will take it as red right now. Alpha is equal to, I'll take 0.5. Marker, I will take it as a star. Once I do this, see, I get 2 lines like this. From 5 to 0, from 0 to 10. Can you create this too? You're getting, no? Very nice. So now we will add one more component, ax1 dot set. Okay, set is a function used to give your title, x label, y label, title, all of that. This is my a graph. See, if you give set title ax1 a graph, clear? ax1 dot a graph. Code might seem changing here. Code might seem big. Why A is changing? A is not changing, Ankur. A is same only. A is here, B is here. See, the code might look a little bigger, but don't you think it is same throughout everywhere? Chat, I did not get the code, Ankur. Okay, I'll just check. I'll take your code. Wait 1 second. Let me take Ankur's code and then see what is the issue. Give space like this so that you get an idea. You have given B here, na? Okay, comment this and check. See, you're getting the line here. If you put it like this, you're getting different line because your data is different. A will not change. The value of A is correct only. Since you have made it till 30, the axis has expanded. See, if you don't give this, y-axis will be from 0 to 10. If you give this, y-axis will become from 0 to 30, but your value is still between 0 to 10 only, na? I did not give any code, I just typed it here, that's it. Okay, why A and B crossing is because that's how you define the data. A is from 0 to 10, B is from 5 to 0, 0 to 10, and 5 to 0, right? So this is something that I wanted to tell you. Is this clear, guys? Still here, Matplotlib basics? Right? Very good. So as I told you, we'll conclude a little early today. So tomorrow we will see different types of plots and everything. I will show it to you. Now, what we are going to do is, I will give you a recap of these things, what we are trying to see, and then I will basically end it right now. You see, we started learning about Matplotlib. We saw how to write a simple diagram like this, 1, 2, 3, 4. Now, once we saw the simple diagram, we had this particular uh, elements, right? So to draw a Matplotlib graph or any graph for that matter, you need to have this simple elements. Code 1, code 2, code 3, code 4, code 5, simple elements you need to have. So once you have these simple elements, every element will have its own particular code. Once this code is written, so you'll have to write one after the one below the other. For every element, you will have a code. For a space, you will have a code. For axis, you will have a code. For graph, you will have a code. For every element, you will have a particular code. Once you have this particular code, what you're trying to do is you're basically writing one code below the other, overlapping it, and then you are generating a file like this. Once all these elements are overlapped one after the other, and when you look at it from the top, you will see a resultant graph like this. Now, once it is done, we came to the graph part of it, installed Matplotlib. Once you installed Matplotlib, we saw import matplotlib.pyplot as plt, dir of plt, saw the functions, understood the length, then we are able to see the version and everything. Then I told you how to generate a data using linspace. So this is what you're trying to see. In the upcoming sessions, when we are plotting other plots, we will also see how we can take external data and plot the graphs. Those things and all we will see. Then we had line graph. So this basic line graph, we saw how it is plotted. Once we have this line graph, I told you, basically import package, generating data is one place, space is one, line is one. So basically figure will tell us the size of the graph, and then plt.subplot. Subplot will basically give us the subplot as in the space. So if you give brackets to this, subplot is empty, which means you're going ahead and then checking the entire space for drawing your graphs. Then ax1.plot of A, plot of B, whatever data you have generated, you're plotting it here, right? So this is one thing. And then you're basically coming to the next one, which is similar one, but you're adding some design elements to it, where you're plotting line width, line style, color, marker, and everything, and then you're generating this graph. So this is something that we saw today. So Pulkit has a question. I just wanted to ask that you are basically teaching basics of everything. Will that be enough? We have no knowledge of it. We don't know to code things. We just the functions you teach us. Would that be enough for us to get in test ready, or are we going to learn more? Pulkit, whatever you are learning, right? As you said, this is a beginning. So beginning of your data science journey, whatever is required to start, we are learning. And obviously, as you know, everyone know, learning, there is a lot of it. So even I am learning new things every day, and there is nothing like enough. There's nothing like a limit. So some people will know less, some people will know more. So this becomes like a stepping stone for you to learn more. So this is like a getting started. Using all these things, you will be able to go ahead and then build some models and also go to a intermediate level. So beginner, you can from beginner to intermediate. So mid range of that you can go. But beyond intermediate level, you have to explore it. You have to learn many things on your own. So those things will never be taught. Those things will come from experience, right? I am not sure who will help your projects, but there will be some projects that will be given that I think you might have to solve it. I may not be involved in your project work, but some other support faculty will be involved for that. Point is, will we be using any task or exercises to use these codes? Yes, Bharat. Those things only you will use. As I was stressing, read CSV for an example. That is something that you will always use to read an external file. That is where you will read the data. Once you read the data, you will add column, delete column, check the missing value, how missing value treatment is done. So I showed you how it is done. So sometimes you might use mean, sometimes you might use mode. So it depends on the data, depends on all of that. So basically plotting bars to read the data. Very good. And also everything works on plotting bars, bar plotting, correct? Yes. Read and compare the data using bars. True. Now, what exactly happens is in a bar plot, the main thing that you will do in a bar plot is you will use categorical data. Bar plots are basically used to generate or maybe represent categorical data. Correct. So bar plots are used to represent categorical data. If you want to generate the frequency or the number in a categorical data, you will use bar plot. So we will work on a bar plot now. So first thing, what is it? Import matplotlib dot pyplot as plt. So this is not a compulsory step because I will, since I'm using it, not like for the first time, I'm just going ahead and then printing it, right? So this is something, so you can use this because we are all practicing right now. It is not compulsory. If you use once in the notebook, that is sufficient. No need to use every time. So I'm creating a dictionary here where you are having your keys and labels. Then I'm using a lime 420. List of data dot keys. Then this is something that you need to create. Now tell me what will be there in names, what will be there in values. Done. Very good. So values will be values. Now, if I do my names, I will have list of these. If I do my values, I will have this. So this is a corresponding value. Now, if I plot this, what will be there in my x-axis? What will be there in my y-axis? What will be there in my x-axis, guys? For a normal bar graph, what should I take it in x-axis? Name, correct. What should I take it in y-axis? Values, true. So let me define my fig. Fig is equal to plt dot figure of fig size 4 comma 2. What this will tell me? Fig is equal to whatever I wrote here. What this will tell me? This basically talks about my plot size, correct? Exactly. So it talks about my 4 cross 2 plot size. Then ax1 is equal to plt dot subplot. So when I make a plt dot subplot is empty, what this will tell me? What plt dot subplot will tell me, as I told you already? Using the entire graph. Subplot empty means we are using the entire graph. Very good. Correct. Now, only thing that I will do is ax1 dot bar of names, comma, values. So if I do this, my bar graph is ready. I'll give you a minute. Can all of you do this and let me know once you're done, please? We use subplot for creating multiple graphs. I will show you, Samir, how to do that. Okay, nice. Now, in this, we have used few layers: code layer, XY layer, graph layer. Now, we will also add one more layer, which is our uh, title and also bars. Okay. Now see the graph. Graph does not contain any kind of title. So what we will do is we will put plt dot title of bar plot. Can you do this? Get a title like this. Okay, correct, Mayank. So whatever you wrote, that is also true. That is also working. Restart the kernel, import Matplotlib, and then do it. Okay. So I will tell you names and values again, Sriram. See, names and values is nothing but you are having a dictionary. Keys you are storing in names, values you are storing in values. So once you do this names and values here, what happens is you will be able to go ahead and then plot it properly. So that is something that you will be doing it. Okay, it's clear. You can use the same thing, Mohammed. Yes, what you're telling is also right. This is also another way of doing it. Yeah, all of you restart your kernel, whoever is getting module error. So you have plt dot title bar plot. So once you have this bar plot, now we will add another layer to it. Bar plot title is done. Now we will give X label and Y label. So again, plt dot X label. X label, I will give my names. Plt dot Y label values. So if we give this and run, you can see X and Y will have labels like this, right? So that much detailing is not available. So that is why I'm telling you, see, if you change also, it will require a lot of effort for you to code. So this is not a library that is used to create dashboards or very sophisticated graphs. It's a very simple graph, very simple code where you are going ahead and then uh, basically uh, creating simple graphs to analyze your data. Bar color we can change. We will see that in some time. And then this is a vertical bar graph. So horizontal bar graph we will create. So the only thing that you need to change for creating a horizontal bar graph, if you can check, is basically change your bar to bar H. So when you change your bar to bar H, your normal graph will change to horizontal bar. Here you can change your horizontal bar, and then this becomes values, this becomes names, just interchanging it. If you run this, you can see you'll get a horizontal bar graph like this. So you saw a vertical bar. Write everything in a single cell and then run it. I think you're running only few lines. You're running only few lines. Put everything in a single cell and run it. That is what you're supposed to do. I think you're running only few lines. All the code that I'm showing should be in a single cell. And then run it. You have to change bar h, Mohammed. See if you're changing this bar to bar h. If you have changed this bar to bar h, it will work. We will go to another type of graph. Some dots here and there type correct, showing distribution of data. Dots at the points of saturation. Values are scattered using dots to represent the data. Correct. So in scatter plot, you will use dots to represent the data. Now, scatter plot will be used for continuous data set or discrete. Scatter plot is basically used to put it for anything. You can use it for discrete or you can use it for continuous also. It is not fixed that you have to use it only for one. Okay, it can be used for any of them. Now what we will do is I will basically create a simple scatter plot. Observe this, and all of you also can do this. I've just created another small list. So this basically becomes my data. So I just created three lists. I will take AX and AY to plot my scatter plots. How much can we give? I will make it a moderate graph, 5 by 4. Then I will give AX1 is equal to PLT dot subplot. So I'll give this. So my area is also ready. Now AX1 dot scatter of A comma X. So this is my okay, AX and this is my X axis. Figure of fig size. Fig size is equal to, yeah. See, I have my scatter plot done here. One after the other. Can you do this? I'll show you much more variations in this. Slowly we will do it. So now, once you have done this, AX1 dot scatter. So what we will do is, I will basically add some small elements to this. You can see C is your color. What I will do is I will make it as Y. So if I make it as Y, the color will change to yellow. Number of values are required in X and Y, Bharat. If different values are there, you will not be able to. Okay, you can change the color. S is for size. You can change the size. You can give some number, so you can change the size. It is not a variable. It is basically a keyword. It's an argument in bar plot. I mean in scatter plot. Scatter plot, this is how it is used. Indranil, okay. These are the variables that we pass. These are not the variables, but the arguments that we pass. Okay, you can change the size like this. Then you can use marker. Marker is equal to, maybe we will use a star. See, you'll get a star like this. Maybe I'll use a green color, right? Then you can give alpha. This will make it a little lighter. So these are some options that are available for you in your scatter plot. Clear? See, the pattern or the flow is same. The structure of data that you write is same. Data, plot the figure, then plot the graph. Small variation in the graph will be there. That's all. Understanding it? For everything, you'll use the same kind of graph structure. Alpha is used for transparency. If you want to make your dots darker, use alpha as 1. If you want to make it lighter, use alpha as 0. That is basically used to uh, check the transparency of your graphs. Right? Thickness is yes. Size. Yes is the size of your dots. If you make the size big, your dots will become bigger. Ankur, yes, you can use the empty for data also. We can say default color in Python is blue. Yes. Blue or black. Either one it will take, but usually it will be blue. No. Size is for size. Size of your dots. Alpha is for transparency, whether you want it dark or light. Now, once we have done this, you are plotting AX1. We can do it, but that requires a little extensive coding. Hemchandra, we can do that. So you can try. Now, what I will do AX1 dot scatter of A comma Y. Instead of X, I am using Y. Then I'm using C is equal to R. I'm using C is equal to R. Then I'm using S is equal to 75. Then I will put a marker is equal to, let's say triangle we will take, comma, alpha is equal to 0.7. If you do this, you will get red dots. There is some issue. CS marker alpha. What is the issue? Oh, alpha spelling is wrong. Alpha. See here, along with your green dots, you also get red triangles for plotting. Here, axis value in A, how value comes between 0 to 0.5. Okay, 0 to 5. It is automatic, Shivani. Okay, slowly do it. I'll give you 30 seconds. After this, we will add title. Try to add grid lines by yourself. We will see if you are able to do it. plt.grid true. You have to make. Check if you're able to do it. So even though if you're seeing code is big, right? You're able to understand. Nah? So it's all like pieces. Yeah. So even if you see it in the one go, right? If you see it in the first thing, so see what I'm doing is I'm just adding all of that. See now, if I just remove this space and if I show you, don't you think you'll get a little scary when you see this code? You'll see what are all these things that they've written. You'll not feel so comfortable. So that's why I'm dividing it into pieces. So this is your library. This is your data. This is your uh, normal figure. And then this is your plots. Then this is your titles. Right? So it's simple. I'm just simplifying everything for you, right? Very good. So if you put true na, or if you can just run this also, it is fine. This also will work. If you put true, you're telling add the grid, that's all. If you just put plt.grid also, it will work. This will give you an error, but this will work. Subtitles, it will need extensive coding. So for simple graphs, all of that is not required, right? So you can do all of that. You might have to spend a lot of time, which is not worth spending. So scatter plot, we did it. Now let us go to the next type, which is called as histogram. So histogram, same thing. Why histogram is used? Can someone tell me? Because your data will be here AX and AY. See here, change this, Sri Harsha. Make it AY. Okay. Why histogram I am using? Anyone, why histogram we will use? Can someone tell me? Why will use histogram? Histogram basically gives me the frequency of the data. Means between two ranges, what frequency is there? Between a range of data, frequency, correct. Import Matplotlib dot pyplot as plt. I will create some data here. So let me take some data in some range. So I'm just taking some range of data, right? This is my data ready. Now I will do fig is equal to plt dot figure of fig size is equal to 4, 2. Ax1 dot Ax1 is equal to plt dot subplot of this much. So once you do this, you have Ax1. Okay, this basically will generate your space. Ax1 dot hist. You just have to do Ax1 dot hist. If you do this, it says you need to give the x argument. What is my x argument? Is my data. Put it like this, you will get a histogram like this. Very good. Now, the main thing aspect of histogram is the number of bars. So in histogram, we call those bars as bins. Okay. By default, you will have 10 bins, which means 10 bars. So if you want to increase or decrease the number of bars, you just have to use a argument called bins. And if you give bins, you'll be able to change the number of bars here. So this is called as bins. You can see. This is how you will be able to change the number of bars in your history. But how it is plotting values? Okay, I will tell you how it is plotting values slowly. Try to complete this graph, then I will explain you how it is plotting values. I will take 10 values here and then I will explain it to you. See this properly. 1, 1, 1, 1, 2, 2, 5, 6, 7, 8, 9. By default, I will take let's say 10 bins. Okay, 10 bins. First, what it will do, it will arrange the data in ascending order. Any histogram will arrange the data in ascending order. Once you do this, it will basically define a range. This is your values: 1, 2, 3, 4. Here will be the range. This is 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. So by default, I've taken 10 bars, 10 bins, which means this is one bin, this is two bins, third bin, fourth, fifth, sixth, seventh, eighth, ninth, and 10. So 10 bins will be created. Now it will check for the frequency. Between 0 to 1, how many values are there? 0 values are there. Okay. Now 1 to 2. So you can see 1 is there, 2 is not there. So 1, how many values are there? 4 values are. So you'll get a value bar for 4 here. Then 2, how many are there? 2 to 3, 2 are there. So it will come like this. 3 is not there, 4 is not there, 5, 1 value is there. So you'll get 1 bar like this. 6 also 1 bar, 7 also 1 bar, 8 also 1 bar, 9 also 1 bar. Like this you will get. So this will be a empty. Wherever values are not there, you will not get a bar. Wherever values are there, you will get a bar. So this is how your scatter plot would work. I mean, the bar graph would work. Understood? Done. Bins are nothing but the groups. So if you create 5 bins, then it will become 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. That groups are called bins. Clear to all of you? Very good. So this is how you basically create a histogram. Now, your statistics sessions are done. Statistic sessions are done? No. Okay, no problem. Fine. Till here, is it clear to everyone? Now, I will show you a graph which will be connected to your describe. Import pandas as PD. So, what I will do is, I will create a graph now. 24, 1, 30, 20, 10, 5, 20, 10, 60, 20, 40. So this is my data. Then what I will do, df is equal to pd dot data frame of total. So you're basically making a data frame. Df dot describe. So if you do this, you will basically get the count of total, mean of total, standard deviation, minimum, 25%, 50%, 75%, and maximum of total, right? So all of you are aware of this now. Amruta, when you will know how to import, you need to see if you want to use a data frame is part of Pandas. You need to import. So whenever you feel you need to use any function of that library, you have to import it. All of you are clear on this describe part, how I made it? In describe, you are having few values. Minimum value, 25th percentage, 50th percentage, and 75th percentage in maximum value. So this is called as your quartiles. Quartiles means if you divide your series of data between minimum and maximum. Minimum is 1, maximum is 70. The middle value in the distribution is 20, right? Minimum is 1, maximum is 70. The middle value in the distribution is 20. The 25th percentage value is 10. The 75th percentage value is 27. So this is the distribution. Minimum, maximum, middle, 25th percent, 75th percent. So once you have all these things, what you will be doing next is, once you are doing all of this, so the next thing that you need to do is you can plot these. There is a type of plot that will help you to plot these values. So the type of plot is called as a box plot. So box plot basically plots these values, the quartile values. When your data is there, minimum, maximum, 25th, 50th and 75th percentage it will plot. Also mean you can plot. So why do I need to use box plot? There are two different uses of using a box plot. So what is it? The two different uses of using a box plot are, the first aspect that you need to understand is it is used to understand the distribution of the data. How my data is distributed, you will know. Second thing is to find the outliers. Outliers are nothing but the values.
Just a quick info, guys. Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatar. So this course, you will master Python data science by working on various Python libraries such as SciPy, NumPy, Matplot, Lambda functions, and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science. Let's have a quick quiz question, guys. What is one advantage of using data frames in Pandas? Here are your options. A. Effective handling of large data sets. B. Drawing complex visualizations. C. Executing machine learning algorithms. And option D. Generating HTML reports. I hope by now you have commented your answers in the comment section. Now let's continue with our session.
That are does not belong to a mainstream group. So if you want to use outliers, if you want to identify outliers, you can go ahead and then use this box plot. So this is the purpose of box plot. I'm explaining it to you right now. Is this clear to all of you? So I will show you how it comes. So basically you're plotting the minimum value, maximum value, 25th, 50th and 75th value along with the mean. So outliers is nothing but, let us say you have age of a person. So what is the typical range of age of a person? 0 to 100. So if your data has age of a person is 2600, unless he is Guruji, you cannot have 2500, right? So that is an outlier, right? So that is something. So if you're having height of a person, so let's say 3 feet to maybe 6, 7 feet. If someone's height is 18 feet, that's an outlier, wrong entry, correct? That is something that we see. So happy, box plot is nothing but it is a plot of your data starting with your minimum value till your maximum value, also gives us the distribution of 25th percent, 50th percent and 75th percent. So that is our box plot, which we are yet to see now. Got it? Clear? Very good. Now let us go ahead and then understand how to plot box plot using this data only. Total, order, discount. So we will write a code for box plot. So for box plot, you have total. Total is equal to 20, 4, 1, 30. Is it the same value? Yeah, I will take the same value. Let me not retype it again. So just taken the same values. Data is equal to list of, I'm taking all of them, total, comma, orders, comma, no space, total, comma, orders, comma, discount. So once I do this, my data will look like this. I basically have three lists in my data. Total, order, discount. Three lists will be there. Now, once I have this, we have fig. Fig is equal to plt dot figure of fig size is equal to, I will use a fig size of 3, 3. Then ax1 is equal to plt dot subplot. You'll use like this. So now you're basically, your data is ready, plot is ready. In your ax1 place, you basically plot a box plot of data, because data is your three graphs will come. Or what you can do, just plot it for total right now and then see how it comes. If you don't want all these extra things, what you do is just add one argument which is plt.show, which means only it will show the plot. It will not show you the total. All that extra stuff it will not show. So here you can see the minimum value it is plotting. What is the minimum value? 1. So there is a box. Box starts at 1 here. What is the maximum value? 70. There is a dot here at 70. Or what I will do is I'll remove this 70. 70 is basically an outlier. It comes at 70. The correct value is around 30. The 25th percentage is around 10. 50th is around 20. 75th is around 27 or something. See, 10, 20, 27. So this is how you plot this graph. Whatever you get in describe, you're plotting it as a graph. So basically, Parth, the use of box plot is to identify the outliers. So whenever you have your data, once you get into your statistic sessions and machine learning sessions, you will know why do I need to use outliers. I mean, why do I need box plot? So box plot is used to identify outliers. So whenever you go ahead and then plot your box plot, your outliers will be identified. So to identify your outliers, you will use box plot. Very good. Now, this basically gives you a minimum and a maximum distribution. So it gives you a minimum maximum. You will not know where the data is dense, where it is sparse. So you will not get a distribution as such. So if you want to get a distribution as such, what you're supposed to do, you have another plot which is called as a violin plot. So I will take the same box plot. I will add the code here. violin, violin plot. How am I going to change it to violin plot? Just change your box plot keyword to violin, violin plot. That's it. And title also you can change. So only by changing this one particular function, your box plot will become like this violin plot. So violin plot will talk about the minimum value, maximum value, and also the median or your mean. And also this distribution will tell you the largest amount of data is between 0 to 40. So this largest amount of data. Whatever you are seeing later is a small one. Right? So this particular thing is something called as violin plot. Here, the largest amount of data is between 0 to 20. Whatever you're seeing later is a small data like this. Clear? String object is not callable. Put your complete code. Happy? Let us see. This is your violin plot. Guys, can you check and tell if there's any issue in this? Let me take the code, whatever you have given. I will take the same code and then I will plot it. See, in violin plot, if you see your data here, minimum is 1, maximum is 70, and the mean value is around 23 or something. Minimum is here 1, maximum is here 70, mean value is the 23 or something like that. Here, went ahead and then we saw the line graph. You can see how we generated a line graph one by one. So once we structure, we got it. So importing of the libraries, generating data, space, all of this. Then we came to the importing of packages. We started to import these packages, all these packages, how this works. Once these packages are done, we went ahead and then started with bar graph. So bar graph we saw, then we went ahead to do scatter plot, histogram, all these things we checked. Then we went to box plot. Box plot is a plot where box plot gives us the minimum, maximum, 25th, 50th, and 75th percentage. So this is something that we saw. And then once we have this, we have violin plot. So this violin plot also is used for the same purpose. So violin plot also is used for the same purpose, total order discount. So based on this, we created a violin plot for our use. Then once we did this, we will check out the pie chart right now. How exactly a pie chart is written. So before going to pie chart, what kind of AIs we can use in data science? So that's a very generic question, Parth. There's no specific answer for that. I have a doubt. We don't need to learn Python like developer. Is that enough to have Python syllabus for data science? Sisam, as I already told you, this is sufficient to get started. There's nothing like enough, right? So you might have to practice. You might have to read, learn more. But to get started, yes, this is basically for a pie chart, you would be using a categorical data, correct? To see partition is correct or true. So we'll be using categorical data only, right? Correct. So how are we going to do that? Learn statistics easily, true. So to do a pie chart, import matplotlib dot pie plot as plt. Okay. Then I'm going to create two labels, frogs logs. I'm just creating some labels. All of you can type along with me. Some names I created. Then I'm creating a list of values. 15, 30, 45, 100. So these are the values and these are the labels that I have. Now by using these values and also using this label, what I will do is I will create a pie chart. And along with this, I will also create one more tuple with zeros. I will tell you why I will need these zeros. Now, once I do this, I need to do fig is equal to plt dot figure of fig size is equal to 5, 7. Then I have ax1 is equal to plt dot subplot of close. This is one thing that we have. So what is this? All of you tell me. 5, 7. Very good. Very nice. Once you have the size of the graph 5, 7, subplot empty means, am I reading the complete graph or am I reading a partial graph? You're using whole space, correct. So this is the concept that you're supposed to do. Now, what I will do is ax1 dot pi. So this is the graph that I'm going to plot, ax1 dot pi. In my ax1 dot pi, I need to mention sizes. If I just mention sizes and run, it will give me an error because it will ask, okay, no, it is giving it plt dot show. I will do it here. If I do plt dot show, this extra text will not come. See, sizes means only the size it will plot. Arguments I will explain you one by one. Just do it till here and let me know once done. This is simple. Then plt dot show. Okay. Now, along with sizes, we may also need to add some labels. labels labels is equal to lab. So this lab is there, no? This list. So this lab is my labels. See here. Now, along with the size, I get my labels also. Okay, Varun. So how to get the value of each portion? The value is decided by sizes. So as we mentioned here, sizes is a list. It has 4 parts. So the sizes will decide the value of every part. Got it? All of you? These two things still here? Is it clear? Now, once you have this labels, what we will do is, there's one more function, or I call this arguments, which is called as auto PCT. Auto PCT. So this auto PCT is equal to, you might have to mention percentage 0.2f. So this is how it is mentioned. So if you mention something like this, you can see you have to mention auto PCT like this. Once you mention it like this, it will show you the values in percentage. You cannot show the direct value, you have to show it in percentage. So this is another argument that I have. Can you add it? So 0.2f means 2 digits of precision. 0.3f means 3 digits of precision. So like that. 2 digits, 3 digits, like that it will be. So once you have done this, we have some more simple arguments. Shadow is equal to true. If I make shadow is equal to true, there is no shadow for this pie chart. If I make shadow is equal to true, you will see there is a shadow that will come. Now, these are some basic arguments for a pie chart. Then once you did this, there's also one more argument. Explode is equal to exp. So what do you mean by exp? Exp is 0000, right? So once you do explode is 00, you are telling don't explode any of this pie. Shadow is true means you will get a black shadow here. That's all. Nothing else. Okay, shadow I explained it to you. Auto PCT I will tell you. 0.2 means when you are printing your data here, print it with 2 digits of precision, which means 2 decimal points. If you make it 3, you will have 3 decimal points, right? So if you make it 1, you'll have 1 decimal point. So if you make it 2, you'll have 2 decimal points. It's a format. Auto PCT is equal to single quote percentage 0.2f. Don't make it O. It is 0.2f, then 2%. So this is what you're supposed to do. Then you have shadow is equal to true, which means your shadow would come like this, black color shadow. Explode is exp means all of them are 0, 0, 0, 0. First one is 0, second one is 0, third one is 0, fourth one is 0. Now, I will make it as 0.1. The first value I give it 0.1 and then I enter it. See, the pie has come out a little bit. Means if you want to bring any pie outside, you will use explode. If I make it 0.2, this will come out a little bit more further. Exp means explode. I will give you 2 minutes. This is an important one. Change the values of auto PCT, shadow, explode, everything. Experiment for 2 minutes. You cannot add any conditions to explode. It is just number. Size not defined. That depends on the code, Amruta. I cannot say exactly what is it. What is the range of explode min and max value? Minimum is 0, maximum is 1, Indranil. You can also give more, but you will get it very far. So it doesn't look good. 9% if you want to come out, na? Change explode here. The value of explode, you change it here to 0.2 or 0.3, Priyanka, you will get it. How do we change colors? Changing colors, you might have to code it like how we used to do C is equal to. But do you really want to do it? Because it involves a lot of coding. It is not 7,9, it is 7.7.9, 7.8%. Change this number, it will come out. Explode must be of length of x. Yes, you have to give this 4 points only. 0, 0, 0, 0. Labels, sizes, explode. All of them should be equal length. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Auto PCT is how many decimal points you're showing in your graph. That is what is auto PCT. Okay. So you can change anything. 0.1 means 1 decimal point. 0.2 means 2 decimal points, like that. So, K sums up the size and show the percentage. Correct, Bharat. When I explode, it is completely going. If you use a big number, it will completely grow. Use a small number, 0.2, 0.3, like that. Then it will not go. So use a small number. So I will basically take you through another functionality right now. So the other functionality is all of us, we have used uh, subplot as empty till now, correct? What we will do is we should use subplot into multiple features. How am I going to use it? So let us say I will use my division of subplot now. I will show you after this. Divide subplot. Okay. So how am I going to divide subplot? Import numpy as np. Understand this code properly. Import pandas as pd. Oh, I don't need pandas here. Matplotlib.pyplot as plt. Then I will use two data sets. A is equal to np dot linspace of 0, 10, 20. Then b is equal to np dot linspace of 5, 0, 20. So I'm using two data sets, whatever we have already used. Then fig is equal to plt dot figure of fig size is equal to 5, 6. Then ax1, here I'm showing you plt dot subplot of 2 to 1 ax1 I've used. I'll use ax2 plt dot subplot of 2 to 4. So I'm now using subplot of 2 to 1 and 2 to 4. I will explain you what is this 2 to 1 and 2 to 4, and we will understand the things that are there here. Now, when I give subplot of 2 to 1 and 2 to 4, I am breaking my subplot and I'm using it a little separately. Now, what am I trying to do here? You can see ax1 dot plot of a. Then ax2 dot plot of b. I'm doing this. plt fig plt dot figure is equal to Once I run this, I should get two graphs. How they will come, I will show you. Then later we will see. Let it run for a minute. You can see here, I'm getting two graphs here. So, what is the concept behind this? So the concept is like this, very simple. I will tell you. See, when you use subplot like this, subplot is empty. Then you're using an entire space like this. Next, when you use subplot of 2 to 1, subplot of 2 to 4, how it works is, when I talk about 2 to 1, what it means is divide my subplot into rows and columns of 2 by 2. So this is 2 to 2 to 2 to 2 to, which means 2 rows, 2 columns. 2 to 1 means first quadrant of 2 by 2. 2 to 2, second quadrant of 2 by 2. 2 to 3, third quadrant of 2 by 2. 2 to 4 is fourth quadrant of 2 by 2. So subplot 2 to 1 means plot my graph here. AX1 will be plotted here. 2 to 4 means plot my graph here. So this is my 2 to 1 and 2 to 4. So if you give something like this, 1, 2, 3, 4, 1, 2, 3, 4. So this is basically 3 cross 3. This is 3, 3, 1, 3, 3, 2, 3, 3, 3, 3, 3, 4, 3, 3, 5, 3, 3, 6, 3, 3, 7, 3, 3, 8, 3, 3, 9. You can select any of these things that you want. So 2 to 1 means 2 cross 2, select whichever graph you want. 3, 3 means you divide it, take whichever you want. No problem. So it will take 2 by 2, 3 by 3, 4 by 4, and so on. So you can also do 2 to 1 means 2, 3, 1. No, whatever you want, you can define. So you can do, this is basically 2 by 2. This is 3 by 3. You can also do a 2 by 3, 3 by 2, 3 by 4, like that. Whatever matrix type you want, you can define. Understood this subplot now? What is this concept? All of you? So you can change it to basically 3, 3, 3, 3. If you make 3, 3, you will get, see, 3, 3, 1, 3, 3, 2, 3, 3, 3, 3, 3, 4. You can change it to 3, 3, 5. See, 3, 3, 5. 1, 2, 3, 4, 5. 3 by 3 grid. You have to imagine. You can also make 2 by 3, 2 by 3. See, 1, 2, 3, 1, 2, 3. 2 by 3, 2 by 3. So like this, it will come. Very good. So I'll go up, see this. Ashik, linspace is nothing but you're generating the data, Ashik. That's it. You're taking 0 to 10. I've already told you. Let me explain you again. See here. You're taking linspace, which means between 0 to 10, generate 20 equally spaced data points. That's it. Done? Between 0 to 10, generate 20 equal data points. That's it. That is what linspace does. Good. Very nice. Now I will explain you another small library which is only for your knowledge. So I'll not go into the depth of it. The reason being you may not use this at all. Okay. So we have another library which will draw graphs like Matplotlib, which is also built on top of Matplotlib. So Seaborn is also built on top of Matplotlib. So you are supposed to go ahead and then check this. So basic things we will see and will not go into deep dive it because this may not be used always for you. So that is something. I have given certain examples here in this. In the code that I've given few examples for Seaborn you can refer. But having said that, Seaborn is not a widely used graphing library, so we will not be using that. Right, so I've just typed pip install Seaborn, let it run. If you have done this, you will get requirement already satisfied. Are we done? Sri Harsha, give me 1 minute. Okay, you can see the code here. Right, so seeing the code, Sri Harsha. Good. Pulkit, sklearn is scikit-learn, which is used for basic machine learning purpose. Scikit-learn is sklearn, which is used for machine learning purpose. Okay, good. Now, once we have our C1, so I will explain you few small things about this. Import Seaborn as SNS. So we basically import Seaborn as SNS, dir of SNS. So if you run this, len of dir of SNS. So these three things you might have to run. So this basically imports your C1 library, gives you some brief functions about your C1 library, and then there are like 100 functions. SNS dot hyphen hyphen version. So you can see this. So basic things, can all of you run these things? Very good. So you might be having a similar version and everything. So this is how you do it. So this is a small library that is there. I'll give you one simple example of this. I mean, it is not as easy as Matplotlib, so let us not go into that. But for your knowledge, I will do this. Seaborn as SNS. SNS dot set underscore theme of style is equal to dark grid. So this is a style that you need to set. Now in the data set, we will load it. Load an example data set from Seaborn. So I will read a data which is called as fMRI SNS dot load underscore data set of, I will use fMRI. Then we'll plot it. plot. SNS dot line plot. It's a complicated one. LOAD. Yes, thank you. Path load data set. Correct. Line plot. Here you have to mention X. What is my X? X is time point. So this is the values that are there in the fMRI data set, which is MRI data set, signal. So you can just use this much and plot. Just give X and Y. It is asking me, could not interpret. TIME, I've given correctly. Time point. SNS dot line plot. X is equal to time point. Y is equal to signal. Maybe I will add few more. Hue is equal to region. I have to give my data. Data is equal to fMRI. Now let us see. Because I haven't mentioned my fMRI, it is not plotting. It basically plots this. You can remove this hue if you don't want. Hue is nothing but how you want me to see it. See, this is what it will go. This is a plot. X-axis, Y-axis, data. You need to mention these. So this is, see, for a same graph, you could have just plotted same graph. You could have just plotted a Matplotlib graph as plot. That was sufficient. You don't have to type this much, right? So this is something that I'm trying to explain. So if you use Seaborn, it is a little complicated. So you might have to write a little more. Module Seaborn has no attribute load. SNS.load. What I mentioned, you have to mention SNS.load underscore dataset. Na? See, you have mentioned SNS.load.dataset. Surely change this. Spelling mistake. Here you make it underscore and it will work. Okay. See, make it underscore and it will work. Okay. And then Prajakta's code, let me take. And then I will try to debug this. SNS theme dark grid. It is working fine, Prajakta. There is no problem in the code. Okay, your code is working fine. Raghunath, you can use X and Y. It is running. Prajakta, just restart your machine, restart your kernel. Just go here, put fMRI, and then you will see this is your data set. It has subject, time point, event, region, signal. So this is how your data is. Basically 1000 rows and 5 columns. Is there a way to read map in Python? Map you can read, but complicated ones. You would prefer Tableau or Power BI for that. Yes, Raghunath, maybe we will see how to do lambda functions. I will cover it, no problem. Because they were supposed to be covered by other faculty, if I'm not wrong. But anyway, I will try to cover lambda function. Is there a way to read map? You can do, sir, importing external data set to plot graph in Matplotlib. Matplotlib also you can do it, Bharat. So I will show you how to do that in tomorrow's session. Projector's code I think should work. It is working. Just change, just restart your kernel once and then check. Shirley, your issue is this. Load underscore dataset you have to make. You have load dot dataset. Shall we plot a graph using CSV file? Could you show an example? Yes, Sriram. Tomorrow we will see that only. How can we understand the error? Sarita, whenever you get an error, it is talking about some mistake that you have made. So you have to see, to understand the errors, you have to make errors. Practice, practice, practice. That's all. You have to go ahead and then uh, keep on doing some or other mistake, run the code. Once or twice, if you try to debug, you will understand it properly. I have covered most of the things that is required for you in reality, right? So all the topics that are required for you in reality, I have covered. So more than what is there in your PPT, I have gone into the depth and then I have covered of the required topic. And I have ensured that all of you understand those topics well. So lambda functions I can cover, no problem. But other topics, I felt there are some topics which are not needed, like Seaborn. So that's why I'm spending a little less time on that. That's all. Sir, there is some issue with the importing of libraries, Shirley. Shirley, just restart your kernel, import this, it will work. For me, it is working now. For you also, it should work. Try it once. Can we add a title? No, this you can add a title, but not like Matplotlib. Not so easy. Is there any book reference for NumPy and Pandas? Okay, I will give you a book reference. You can read this. So this one is basically a free book that you have. You can read all these things here. You can see Introduction to NumPy, Data Manipulation with Pandas. So it covers many things. Matplotlib also it covers. sklearn also it covers. So majorly whatever you require is available. Basics of Python, NumPy, Pandas, Matplotlib, and sklearn. So this link I'm giving it to you. This book you can use it. You will use components of NumPy. You will use components of Pandas. You will use components of Matplotlib. You will use sklearn, everything. So when you read your data, you might have to explore your data. So where you have describe, where you have your info, all of that comes in Pandas. Replacing missing values also is part of Pandas. Fill NA, etc., etc., etc. Once you do all of that, the next ones that you have is, give me a second, remind me later. Okay. So once you have that, you might have to plot some graphs to see the data distribution. That is part of your Matplotlib. Once you have that, if you build a machine learning model, that is sklearn. So that is how you combine all these libraries and use it. I mean, where we can press Matplotlib online, you have to use your Jupyter notebook only, Bharat. For few topics which were pending from previous instructor, you can ask for an extra 1 or 2 sessions, then we can, I think, try. But I'll try to give you the lambda functions and others. One thing that I can tell you, Raghunath, those topics are not at all complex. See, I have taught you OOPS, I have taught you concepts of lambda functions and everything. By this time, all of you should be able to learn small things by yourself, right? What I would suggest you, Raghunath, is try to see if you can learn that small topics by yourself. If that is possible, then I think it'll be great. Just try it once. If any questions are there, we can see. Kaggle.com is a website where you get a lot of information. Lot of projects are there. Code, everything will be available. Use Kaggle to get some basic info about the project. Why CSV? Yes, Sriram. Kaggle.com you can use. CSV is a comma separated value. That format is used very widely to create all this data. Lambda was already covered. Okay. So guys, if you have any questions, please feel free to ask it in the chat window. Right? Okay. Now, as I already told you, since we spent some time answering questions, I will show you, see, all these codes that you are seeing, right? You should not, or maybe I've already shared it, Parth. I've already shared all the files. I'll share it with you again. So if you see all these codes, you may not be able to remember all this. These are all like codes which you don't have to remember. I'm sharing the files again. Take it. It has everything. Okay. So these codes you don't have to remember. As I told you, Matplotlib is a function or a library that gives us codes readily for all the graphs. Matplotlib gallery. Pulkit, it's the same one, Pulkit. Same codes. Whatever I wrote, it's the same code that I've given. Matplotlib gallery, you have to Google. So once you go to Matplotlib, Anil, you can put your question in the chat window, please. Okay. Any question, Anil, you have, put it in the chat window. Okay. So if you Google for Matplotlib gallery, you will get a Matplotlib gallery like this. So what exactly Matplotlib gallery has? Matplotlib gallery has a collection of all the graphs you can see here. So if you keep on scrolling down, you will have so many types of graphs. You will have so many types of graphs. More than this, you will never need in your data science journey. Why am I showing you this? The main purpose of me showing you this is whichever graph you want. If you want to just check the code, give me 1 second, guys. Now, let us say, for example, you go somewhere like this, and then from here, if you basically select one small graph, one particular graph, you can see, let us select one graph here. Some graph I will take. Let me take a line graph, bar graph, bar H demo. So if you come to this, you will see the code like this. Matplotlib. So this is basically importing of your data. Then you're basically drawing your plot. Then you're taking your data. Then you're plotting it. This is basically a bar H, horizontal bar graph. So like this, you will be able to get all the codes for your graphs here. You don't have to remember anything. Okay, scatter plot. See, for scatter plot like this, you have a simple scatter plot, plt.scatter. So this is what we saw, correct? So this is how it works. Understood, everyone? For histograms.
So now, moving to the first question, what do you mean by the term normal distribution? Normal distribution, also known as Gaussian distribution, is a type of probability distribution that is symmetric about the mean. Here, mean, median, and mode are equal. Normal distribution appears to be bell curve in a graphical form. So here, you can see this graph. This graph is symmetry, and also mean, median, and mode are equal. So now, let's move forward. So the next question we are having is, what is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. Skewness defines the asymmetry of a distribution. Here, the data is not distributed equally on both sides of the distribution's peak. So basically, there are different types of skew distribution. The first one is the left skew distribution, and the another one is the right skew distribution. So in left skew distribution, it occurs when the long tail is on the left side of the distribution. That means here the mean is left to the peak, and also mean is less than the median, and the median is less than the mode. Along with that, left skew distribution is also known as negatively skewed distribution. Coming to the right skew distribution, it occurs when the long tail is on the right side of the distribution. It is also called as positive skew distribution. Here the mean is right to the peak, and also mode is greater than median and median is greater than mean. Now, so let's see in the graphical form. Here you can see that this is a graph of left skewed, right? So clearly mode is greater than median and median is greater than the mean. So now let's see left and right skewed distribution in graphical form. So here you can see that it's a left skewed graph, right? Because the long tail is on the left side of distribution. Whereas if you are talking about the right skewed distribution, the long tail is on the right side of the distribution. In a left skewed, you can clearly see that mode is greater than median and median is greater than mean. Similarly, coming to the right skewed, here mean is greater than median and median is greater than mode. Now, moving ahead, the next question we are having, what is the difference between bias and variance? Coming to the bias, bias is a prediction error that is introduced in the model due to oversimplifying the machine learning algorithms. It is the difference between the predicted values and the actual values. So let's suppose you have created a machine learning model. So while creating a machine learning model, we'll get some predicted values. So basically, the difference between the actual values and the predicted values is known as the bias. Now, coming to the variance, variance occurs when the machine learning model performs well on the training dataset but not on the test dataset. So now, moving to the next question, how will you handle missing values in data? So there are several ways to handle missing values in the given data. The first one is you can replace the values with mean, median and mode. For example, let's suppose if you are having any numerical column of let's say price and there are a lot of missing values, then you can replace it with the mean. Now, moving next, we are having the dropping the values. So let's suppose if you are having any column that is present in the data set and the null values are present more than 70%, then you can drop that particular column. The last is replacing with arbitrary values. So that means you can choose a random value without any reason or system. So the next question we are having is, what are the techniques used to detect outliers? So there are various techniques that are used to detect outliers. The first one is the box plot. So talking about the box plot, we know the length of the box is IQR, that is nothing but an interquartile range, right? And the minimum and maximum values are represented by the whiskers. So the whiskers are generally extended into 1.5 times of the IQR distance on either side of the box. Therefore, all the data points outside this range values are flagged as outliers. So the next technique that is used as z-score. So z-score is a parametric outlier detection method in a one or low dimensional feature space. This technique assumes a Gaussian distribution of the data. The outliers are the data points that are in the tails of the distribution and therefore far from the mean. So the last method that we are having is interquartile range. As we know, the formula of interquartile range is that it is quartile 3 minus quartile 1. Basically, it is the difference between the third quartile and the first quartile. So to detect the outliers using this method, we define a new range. So let's call it decision range, and any data point lying outside this range is considered as outlier and is accordingly tailed with. So the next question we are having is, what is the difference between overfitting versus underfitting? As we know that overfitting and underfitting are the two key problems in machine learning that decrease the performance of machine learning models. Now, coming to the overfitting, overfitting occurs when our machine learning model attempts to cover all or more than the required number of data points in the given data set. So you can see that in this graph, our machine learning model tries to cover all the data points, right? So now, what happens here as a result? The model gives inaccurate values in the dataset, and all of these factors reduce the model efficiency and accuracy. The overfitted model has low bias and high variance. The more we train our model, the more likely it is to become overfitted. You can see in this graph, the model tries to cover all the data points. So it looks efficient, but in reality, it is not so. Because the goal of the regression model is to find the best fit line. But here, we have not got any best fit, so it will generate the prediction error. So now, let's see how we can avoid the overfitting in model. So there are some ways by which we can reduce the occurrence of overfitting in our model. The first one is the cross validation. Second, we are having training with more data. So whatever the data is there, we can train it, right? So there are some ways by which we can reduce the occurrence of overfitting in our model. So let's see some of the ways. The first one is the cross validation. We can also train with more data. Then we can remove features too. We can early stopping the training too. Along with that, we can also apply regularization as well as ensembling. Now, after knowing what is overfitting, now let's see what is underfitting. So underfitting occurs when our machine learning model is unable to capture the underlying trend. So to avoid overfitting in the model, the feeding of the training data can be stopped at an early stage, causing the model to learn insufficiently from the training data. As a result, it may fail to find the best fit of the data's dominant trend. Underfitting occurs when the model is unable to learn enough from the training data, reducing accuracy and producing unreliable predictions. So let's back to the previous slide. So in underfitting, a model that is underfitted has a high bias and a low variance. For example, the following output of the linear regression model can help you understand about the underfitting. So here you can see that the model is unable to capture the data points in the plot, right? So now let's see how we can avoid underfitting in the model. So there are two ways in which we can avoid the underfitting in model. The first one is increase the model's training time, and the another one is the increasing the number of features. Okay guys, so the next question we are having is, what is the difference between supervised and unsupervised learning? Supervised learning is a machine learning method that uses labeled data to train models. For example, here you can see that how a player learns in the presence of his coach. So this is an example of supervised learning. Now, there are two types of problems that can be solved using supervised learning. The first one is the classification and the another one is the regression. So let me give you the example so that you can understand, right? So let's suppose we have an image of different types of cars. The task of our supervised learning model is to identify the cars and classify them accordingly. So to identify the image in supervised learning, we will give the input data as well as the output for that, which means we will train the model by the shape, size, color of each car. Once the training is completed, we will test the model by giving the new sets of cars. The model will identify the car and predict the output using a suitable algorithm. So there are different types of supervised learning: linear regression, logistic regression, random forest, decision tree, etc. So now, after understanding supervised learning, let's see what is unsupervised learning. Unsupervised learning seeks to extract structure and patterns from the input data. It requires no supervision like supervised learning. Instead, it discovers pattern in the data on its own. Unsupervised learning can be used for two types of problem. The first one is the clustering and the another one is the association. Here you can see that in this figure, you can see that the model will train itself and divide the groups according to the most similar features between them. So let's take an example. So here we'll not provide any supervision to the model. We'll just provide the input data set to the model and allow the model to find the patterns from the data. With the help of a suitable algorithm, the model will train itself and divide the cars into different groups according to the most similar features between them. So the next question is, what is the difference between regression versus classification? So regression algorithms are used to predict the continuous values. Regression is a process of determining correlations between dependent and independent variables. For example, price, salary, etc. I'll give you the example of price versus experience. So let's understand by taking some examples. So let's suppose I'm having a data set which consists of one dependent variable and one independent variable. So the independent variable contains the years of experience, whereas the dependent variable contains salary. So as we know that as the experience of a person increases, the salary will also increase. So this is the example of the linear regression. So there are different types of regression algorithm: simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree, random forest. Now, talking about classification, classification algorithms are used to predict or classify discrete values. For example, male and female, true or false. Even you can take the example of male, whether the mail is a spam mail or not spam mail, right? So let me explain you how does classification work. So let's suppose a computer program is trained on the training dataset, then it will categorize the data into different classes based on that training. Different types of classification algorithms are logistic regression, k-nearest neighbors, support vector machine, and kernel SVM. So guys, let's move further and see what is confusion matrix. So the confusion matrix is a table that used to estimate the performance of a model. It tabulates the actual values and the predicted values into a 2x2 matrix. So now, let's see what is true positive here. So let me give you the definition of true positive. True positive denotes all those records where the actual values are true and the predicted values are true, right? So here you can see that the actual value is 1 and the predicted value is 1, and we got here true positive. Now, coming to the false negative, this denotes all of those records where the actual values are true but the predicted values are false. So you can see that this is false negative, where the actual value was 1 whereas the predicted value was 0. Next, we are having false positive. So in this, the actual values are false but the predicted values are true. So this is our false positive, where the actual value is false. So we are considering false as 0 and true as 1, right? So here we can see that the actual value was false and the predicted value was true, right? So after understanding true positive, false negative, and false positive, now let's see what is true negative. So this is a true negative. Here, the actual values are false and the predicted values are also false. So if you see, this is the true negative. Here the actual value is false and the predicted value is also false. So this is how the confusion matrix works. So now, coming to the 10th question, what is the use of p-value? P-value is the measure of the statistical importance of an observation. It is the probability that shows the significance of output to the data. We compute the p-value to know the test statistics of a model. Typically, it helps us choose whether we can accept or reject the null hypothesis. If the p-value is less than 0.05, then reject null hypothesis or else accept null hypothesis. Moving to the next question, we'll see what is a residual. So residual in a statistical or machine learning model are the differences between observed and predicted values of data. So here you can see that this is our best fit line, right? So these are the predicted values, whereas these values are the actual values. So the difference between the predicted values and the actual values is known as residual, right? So these are the residuals, right? Again, this is the point that we have done the prediction, right? These are the actual values. So the difference between the actual values and the predicted values will be our residual. The next question we are having is, what is dimensionality reduction? So the dimensionality reduction or dimension reduction is the transformation of data from a high dimensional space into a low dimensional space so that the low dimensional representation retains some meaningful properties of the original data. So let's take an example to understand in a simpler way. In machine learning classification problems, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then work on it. Sometimes most of the features are correlated and hence redundant. This is where dimensionality reduction algorithms comes into the picture. So there are various methods that is used for the dimensionality reduction. The first one is the PCA. So PCA stands for Principal Component Analysis, and the another one is the LDA, that is Linear Discriminant Analysis. So the next question is, what are the steps involved in machine learning? So the first step is data collection. Basically, we are defining the problem and assembling a data set. Then moving forward, we are having data preparation. So basically, we are preparing our data. Then we have to choose the model and train it, right? And after that, we will evaluate our model. So while evaluating a model, we will choose a measure of success. Also, we will decide on an evaluation protocol. The next step is parameter tuning. So basically, we are doing here scale up, right? Developing a model that overfits and regularizing your model and tuning your parameters. And at last, we will do the predictions. So this is the way, and these are the steps that are involved in machine learning. Moving to the next question, what is tuning and the decision tree? So I will give you the simpler definition here. Pruning simply reduces the size of decision tree by removing parts of the tree that do not provide power to classify instances. Here, in this diagram, you can see that before pruning, there are a lot of sections of a decision tree, but after pruning, so here in this figure, you can see that before pruning, there are a lot of sections of the tree that are unnecessary, right? But after pruning, we have removed that particular section. Okay, so let me read the definition for you. Pruning in a decision tree is the process of removing the sections of the tree that are not necessary and redundant, right? So why do we use pruning basically? So why do we do pruning in the decision tree? So that our model performs better and gives a higher accuracy, right? What is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. MSE is where mean square error, right? RMSE measures the average magnitude of the errors and is concerned with the deviations from the actual value. RMSE value with 0 indicates that the model has a perfect fit. The lower the RMSE, the better the model and its predictions. A higher RMSE indicates that there is a large deviation from the residual to the ground truth. RMSE can be used with different features as it helps in figuring out if the feature is improving the model's prediction or not. Now coming to the question number 16, what is the use of elbow method in k-means clustering? So first we'll understand what is elbow method. Elbow method is one of the most popular methods to determine this optimal value of k. So what is k here? K means here the number of clusters. As I already told you, it is the most popular method for selecting k for the k-means algorithm, right? So to do this, you need to calculate the within cluster sum of squared error for different k values. So here you can see that it is written as WCSS, which is nothing but a within cluster sum of squared error, right? So it is described as the sum of the square of the distance between each data value and its centroid. You will then choose the value of k for which the WCSS error starts to become negligible. So here in this graph, you can see that this is the number of cluster and this is nothing but WCSS, right? And here at this point, this is your elbow. So the number of clusters will be 5. So the next question that we are having is, what is naive Bayes? So naive Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. So basically you have to keep remember the assumption, right? So the assumption about each feature is that a feature should be independent and equal. So the next question is, what are the disadvantages of linear model? The first disadvantage is prone to underfitting. What does it mean? It means that it is a situation that arises when a machine learning model fails to capture the data properly. So this typically occurs when the hypothesis function can't fit the data well. Next, it is sensitive to outliers. So as you know that outliers of a dataset are anomalies or extreme values that deviate from other data points of the distribution. Data outliers can damage the performance of a machine learning model drastically and can often lead to models with low accuracy. Next, so the next thing is that you have to take the assumption of a linearity between features and the target variables. So here you have to assume that the feature is having a linear relationship with the target variable. Moving to the 19th question, when do we use normalization and standardization? So first, we'll see what is normalization. So in normalization, it is used when features are of different scales. Along with that, it is affected by outliers too. So when do we use normalization? It is useful when we don't know about the distribution. Also, it varies from -1 to 1 or sometimes 0 to 1. Along with that, if you want to use it, then there is a scikit-learn library that provides a transformer called min-max scalar. So you can use this transformer and you can apply normalization. Next, we are having standardization. So standardization is used when we want to ensure zero mean and unit standard deviation. Unit standard deviation means standard deviation is equal to 1. Along with that, it is not bounded to a certain range like normalization. So in normalization, the scale was from -1 to 1 or 0 to 1, but here it is not bounded to a certain range. Next, it is much less affected by the outliers. So if you want to use standardization, then there is a library scikit-learn that provides a transformer known as standard scalar. So this is all about normalization and standardization. Next question, explain hypothesis testing. Hypothesis testing is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, null hypothesis denotes as H0, whereas alternate hypothesis denotes as H1. Now, after understanding what is hypothesis testing, let's see the steps involved in hypothesis testing. So the first step is stating the hypothesis. For example, you can take the example of students with height more than 5 feet have BMI more than 20. Next, collect data, and after that we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that we will take the decisions. So as I already told you, that let's suppose there is a student with height more than 5 feet and having BMI more than 20. So this will be your null hypothesis. So what will be your alternate hypothesis? Opposite of it. That is, students with height more than 5 feet do not have BMI more than 20. Now, according to the statistical test, we'll support the alternate hypothesis or null hypothesis, right? So this is how it works. So the next question is, what is the difference between training test, validation set, and a test set? So first, we'll discuss about training test. It is a portion of our actual data set that is fed into the machine learning model to discover and learn patterns. So let's suppose that if you are having 100% values in the data set, so we'll take 70% of the values or 60% of the values to train that data set. Next, we will see about the validation test. So the validation test is used for hyperparameter tuning. And at last, we'll see what is test set. So the test set is used for the final evaluation of the best model. Moving to the next question, what are the different statistical techniques used in data science? The first one is the correlation. So it establishes and measures relationship between different variables. For example, if we are having data set, then we are having a lot of features along with the dependent variable. So it will show the relationship of features with the dependent variables. So next we are having regression. It allows identifying if the evolution of one variable affects others. You can take the example of experience versus salary, right? Where one variable is affecting the other dependent variable. Next we are having time series. It predicts future values by analyzing sequence of past values. Basically, time series is used for the forecasting. Next, we are having the sentiment analysis. It determines the attitude of specific agents or people towards an issue, often using data from social networks. So the next question we are having, what is box plot? A box and whisker plot, also known as box plot, is used to show the spread and centers of a dataset. It is also used to detect outliers. It shows the dispersion of data across the mean. It summarizes the result as the minimum. So here you can see that. So this is a minimum, which means minimum value in the dataset excluding the outliers. Next, we are having first quartile. So this is the first quartile, or you can also say this as a lower quartile. So it means 25% of the data lies below the first quartile, right? So here, these are the 25% of the data that lies below the first quartile. Next, we are having median. Median is nothing but the midpoint of the dataset. Half of the values lie below it and half above. So this is the median. Next, we are having upper quartile, that we say Q3, right? So it means 75% of the data lies below the third quartile. So here if you can see, this is our upper quartile, right? So 75% of the data lie below this quartile. Next, we are having maximum. So it means maximum value in the dataset excluding the outliers. After that, we are having interquartile range. So this is our interquartile range, which is nothing but the length of the box, right? So it consists 50% of the data. Okay guys? Now, we will see what is whisker. So whisker is nothing but the upper and the lower whisker represent scores outside the middle 50%, right? So here you can see that we are having the lower whisker here, upper whisker is here. So this is all about the box plot. So the next question, what is SVM? So SVM stands for support vector machine. So what is the use of SVM? SVM are used for classification as well as the prediction task, right? So let us understand about SVM. It consists of a separating plane that discriminates between the two classes of variables, and this separating plane is known as hyperplane. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future, right? SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are also called as support vectors. So these are the support vectors. That's why we used to call the algorithm as support vector machine. So after understanding SVM, now let's see some of the kernels used in SVM. So the kernels that are used in SVM are polynomial kernel, Gaussian, sigmoid, and hyperbolic. So moving to the 25th question, what are a z-test, chi-square test, f-test, and t-test? Okay, so first let's see what is t-test. So we use t-test to compare the mean of two given samples. Also, t-test assumes a normal distribution of the sample. So when we have to use t-test, when we don't know the population parameter, that is nothing but mean and standard deviation, right? In that case, we use t-test. So after knowing t-test, let's see what is z-test. So a z-score is calculated with population parameters such as population mean and population standard deviation. So in a z-test, we assume the sample is normally distributed. So what is the use of z-test? So we use this test to validate a hypothesis that states the sample belongs to the same population. So in a simple terms, when we have to use the t-test as well as the z-test, so we will use the t-test for the small sample size, whereas we will use the z-test for the large sample. Coming to the chi-square test, or even you can say chi-square test, it depends, right? So we use the chi-square test to compare the categorical variables. A chi-square test fit for the two independent variables, used to compare two variables in a contingency table to check if the data fits. So let's see the definition here. So chi-square test is used to determine the difference observed and expected frequencies of a certain observations. Alright, so the last test we are having as f-test. So when we use f-test, so when the hypotheses of the interest are about the differences between population means. Okay guys, so the next question that we are having is, what is the difference between correlation and covariance? So now, first we will discuss about the covariance. So covariance shows the extent to which the two variables are dependent on each other. Basically, higher the number, higher the dependency. Now, what is the range of covariance? It varies from -infinity to infinity. Right? Now, moving to the third point, it is affected by a scale of a variable. So now, let's see what is correlation. So, in covariance, it indicates the direction of linear relationship between variables. Basically, it shows the extent how two variables are dependent on each other, right? But in correlation, it measures the strength of two variables considering other conditions are constant, right? The next point is the range of correlation is from -1 to 1. So basically here we are having the Pearson correlation whose range is varying from the -1 to 1, right? Along with that, it is not affected by scale unlike covariance. Next question, what is cross-validation? In a simple term, cross-validation is used to validate models efficiency, right? So let me give you the formal definition of cross-validation. It is a technique for validating model efficiency that involves training the model on a subset of input data and testing it on a previously unseen subset of input data. In a simple term, it is a statistical method of evaluating and comparing learning algorithms by dividing data into two segments, one used to learn or train a model and the other used to validate the model. Next, we are having the cross-validation by k-fold. We can also do the cross-validation with one exception and many more. So this is the idea about the cross-validation. Moving to the next question, what is sampling? Mention some techniques used for sampling. So let me give you the definition of sampling. Sampling is defined as the process of selecting a sample from a group of people or from any particular kind for research purposes. It is one of the most important factors which decide the accuracy of a research or survey result. For example, if you want to take the sample that how many people are affected by COVID, so you will directly go into the population and out of that particular population you will take the sample about 1 or 2%. So this is nothing but known as sampling, right? So mainly there are two types of sampling techniques. The first one is the probability sampling and the another one is the non-probability sampling. So what is probability sampling? It involves random selection which makes every element get a chance to be selected. That was the example just now I have given to you. So what are the different types of probability sampling? repeat, we will see that probability sampling has various subtypes. We are having the such as simple random sampling, stratified sampling, cluster sampling, and many more. Now, after understanding probability sampling, let's see what is non-probability sampling. So non-probability sampling follows non-random selection, which means the selection is done based on your ease or any other required criteria. This helps to collect the data easily, right? So what are the subtypes of non-probability sampling? Convenience sampling, quota sampling, referral sampling, and many more. So this was the overall idea about sampling. The next question, what is ROC curve? So ROC stands for Receiver Operating Characteristic. It is basically a plot between a true positive rate and a false positive rate. So here you can see that we are having the graph of true positive rate and false positive rate, right? Also, it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So I will give you the idea about ROC curve. So let's suppose if the curve is closer to the upper left corner, the better the model is. In other words, whichever curve has greater area under it, that would be the better model. Now guys, moving ahead, what do you understand by random forest model? So random forest model is a combination of multiple decision trees. It combines multiple models together to get the final output, or to be more precise, it combines multiple decision trees together to get the final output. So now coming to the question number 31, what do you understand about a decision tree? So as we know that random forest is a combination of multiple decision tree, right? Whereas let me discuss about the decision tree. A decision tree is a supervised learning algorithm that is used for both classification and regression. The same goes for the random forest also. Here, each node denotes the test on an attribute, and each edge denotes the outcome of that attribute, and each leaf node holds the class label. So here, if you see the diagram, this is the root node, and these are the leaf nodes. Okay? And this is the edge. So moving to the next question, that is question number 32. What is boosting? Boosting is also a homogeneous weak learners model, but works differently from bagging. In this model, learners learn sequentially and adaptively to improve model prediction of a learning algorithm. So let me give you some points about the boosting. Boosting is an ensemble model technique that attempts to build a strong classifier from the number of weak classifiers. It is done by building a model by using weak models in series. So what happens here? Firstly, a model is built from a training data. Then the second model is built which tries to correct the errors present in the first model. This procedure is continued and models are added until either the complete training dataset is predicted correctly or the maximum number of models is added. Right? So what is the uses of boosting? It is used to reduce the bias. As I told you here, each new subset contains the components that were misclassified by previous models. It is a way of connecting predictions that belong to the different types. Here, the models are weighted by their performance. Along with that, new models are affected by the performance of the previously developed model. What is bagging? Bagging is also known as bootstrap aggregating. So it is also a machine learning assembling algorithm which is used to design to improve the stability and accuracy of a machine learning algorithm. Right? So what happens here in bagging? It decreases the variance. Right? So bagging is used to reduce the variance of a decision tree. Along with that, it attempts to tackle the overfitting issue. So here every model receives an equal weight. Alright? Unlike boosting, here every model is constructed independently. Right? So this is the overall idea about boosting and bagging. Explain univariate, bivariate and multivariate analysis. So first we will see what is univariate analysis. So univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Moving next, we are having bivariate analysis. So here, it involves analyzing the data with exactly two variables so that the data can be put into a two-column table. For example, analyzing the data that contains temperature and altitude. Okay? Also, this kind of analysis allows us to figure out the relationship between the variables. Next, we are having multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables. So here, the number of columns of the data can be anything, even more than two. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, analyzing data about house prices, which contains the information about the houses such as locality, crime rate, area, the number of floors, etc. Next question, what is recall? Recall tells you how many times the model was able to detect a specific category. In a simpler term, out of the total positive, what percentage are predictive positive? So let me give you the definition of it. It is a metric that quantifies the number of correct positive predictions made out of all the positive predictions that could have been made. For example, here you can see that this is a formula of recall, right? So recall formula is true positive upon true positive plus false negative. So basically out of the total positive, what percentage are predicted positive? Moving next, we are having precision. Precision is how good the model is at predicting a specific category. Basically, it measures the accuracy of correct positive predictions. So let's see the formula. So precision is equal to true positive upon true positive plus false positive. As I told you, basically it measures the accuracy of correct positive predictions. Also, the precision value lies between 0 and 1. Now, moving to the question number 37, what are the popular libraries used in data science? So there are popular libraries that are used in data science such as TensorFlow, SciPy, Pandas, Matplotlib, PyTorch, Scikit-learn. Let me explain you some libraries. For example, Pandas. Pandas is used for data analysis. Coming to the Matplotlib, this is a library that is used for data visualization, whereas Scikit-learn is a machine learning library. So moving to the question number 38, what is deep learning? Deep learning is a subset of machine learning, which is essentially a neural network with 3 or more layers. Deep learning is an advanced version of neural networks to make the machine learn from the data. In deep learning, the neural networks comprise many hidden layers that are connected to each other, and the output of the previous layer is the input of the current layer. I will give you the example of deep learning in a simple term. Deep learning teaches computers to do what comes naturally to humans. Along with that, it is a key technology behind the driverless cars, such that enabling them to recognize a stop sign, etc. So now, moving to the question number 39, what do you understand about linear regression? So when I'm talking about the simple linear regression, so there is one independent variable and there is one dependent variable. For example, experience versus the salary. So let's see the points here. So linear regression helps in understanding the linear relationship between the dependent and the independent variable. So as I told you the example of experience versus salary, as you are having the experience more than 3 to 5 years, your salary will be gradually increasing. Next, linear regression is a supervised learning which helps in finding the linear relationship between two variables. So here, one is the predictor or the independent variable and the other is the response or the dependent variable. So this is a basic idea about the linear regression. So now, coming to the last question, how to calculate the accuracy of a binary classification algorithm using its confusion matrix. So first of all, let me give you the definition of accuracy. So accuracy is also a metric that is used for evaluating classification models. So what is the formula of accuracy? Accuracy is basically the number of correct predictions upon the total number of predictions. So here, to calculate the accuracy, we need to divide the sum of the correct classified observation by the number of total observations. So when I'm talking about the number of total observations, so it will include true positive, it will include true negative, it will include false positive as well as false negative. The accuracy will be true positive plus true negative upon the total number of observations.
Just a quick info guys, Intellipaat offers Master Data Science with Python course in collaboration with IIT Pavatal. So this course you will master Python data science by working on various Python libraries such as SciPy, Numpy, Matplotlib, Lambda functions and much more from IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards the growth in the field of data science.